Welcome to this intermediate React course. This course will cover in depth different details about how React internally is working and how by understand it we can optimize our application and write more efficient code. So we'll get in details in how React hooks are working. We'll understand how we can write clean front-end architecture by writing containers, components, services, adapters. We're understanding these structures and how we can adapt them in React and also dependency injection, and we'll be using TypeScript everywhere inside the course, so we'll avoid the keyword any, will not use it at all, and we will be using TypeScript types from React. We'll understand how the virtual DOM is working and how by understanding it we can optimize our application using memo and callback, but we also understand how it is updating our DOM. We also understand how React Router is working, and we have different types of pages and the different types of routers that exist inside it. And we also will discuss server-side rendering to optimize our application for SEO. And we're building this to-do application, and we'll build all of this structure, and you can add a certain task for this application, and you can set one to done. You can edit any of them, add description. You can also do some hand notes, and you can save all of this. You would have multiple pages, and again all of this is rendered using server-side rendering to have speed and fast load for your application. And there would be certain knowledge that is expected from you before starting this course. It would be expected that you have some knowledge about HTML and CSS, some knowledge about ECMAScript 6 and TypeScript, of course, and some basic knowledge of React, although it's not mandatory, it is just recommended. If you have no idea about React, there would be link for a quick course. You can check it out to have some idea, but again, it is not mandatory, and we'll discuss in details from beginner up to advanced, all of this in this course. And all details about this course, like summaries and also the code base, would exist in a link in the description section, which would host all of these summaries and tips and tricks, and also extra links if you would like to get into more details into React, and of course the code base for the to-do application so you can try it. I would recommend that you watch the whole course to get an idea about all of these advanced concepts, and then you can try them later, or you can repeat the video again to understand it and also go step by step during this video. So this video or this course would help you to advance in your career, become a more senior developer, and write better and cleaner code as well. And of course, if you have any questions, just leave them in the comment section during this video. Just leave them as notes so you can ask them when the video is done or when it is ready. So without further ado, let's start our course. And let's give a short summary about React, the library itself. You already know React is mainly used to build UI components, building UI, and many front ends, and a lot of applications are already using it. And it has like over 15 million weekly downloads, or 16 sometimes, so it is already heavily used. But what's inside the library, when we import it, it is divided into two libraries. There is the first thing, or two components. There is the first thing, which is React library, which would have the different functions like useState to manage the state. There is useEffect to manage side effects and so on. All of these are things to manage the state. So React itself, in essence, it's just to manage the state of our application. You tell it, I would like my application to have this state, and React would find a way to transfer it from A to B. This is what React is trying to do in the end. So this is the first part, which managing the state. Then there is the renderer, or the things that would try to render it on the UI itself. So you would have, for example, you have React DOM, and this would render it on the DOM itself. So it would transfer the state into the UI. So if you say this button or this ticket should have like 2, 3, 4, it would transfer this to the DOM. There is the other one which we are going to discuss at the end of this video, which is React Server, and this helps to render React on the server side as well. And of course, you heard already about React Native, although like it is not part of React at all, but it has the same concept or it follows the same concept that you have a place where it manages a state, and then eventually there is a renderer to render all of this. Of course, again, this is not part of React. This is like a different thing, but the same concept eventually. You have a library to manage the state, and then you have another library to render it on the DOM. That's why if you watch some videos or so on, you already see like you import like React and React DOM. So this is the only separation between them. Or if you don't now import it, because now it's implicitly imported as well. And before we start writing any line of code, let's discuss how we are going to build our application. So you already know we are going to build a to-do application, which would have at the top, there is a header, and then there is another form here to add different to-dos. Of course, we will discuss the first part at first, and we will discuss the other components later. But this is the first part. You have like a field here, and then the add button. There is other buttons here to filter the to-dos, and then we have a list of to-dos down here. And each one of them would have an edit button, and there is a delete button, and there is another checkbox button to say, okay, we would like this to be checked and so on. All of this we are going to build, but how we divide it? So these small things, we call them components. So you have like header, this is called component. You have a checkbox, this is called component. The D button is also a component. The field is a component. All of these are component, and they are basically a representation UI. They are presenting these components, but they don't have any logic inside them. And when I mean by logic, or rather not logic, but rather state. So they don't manage any state or try to have any logic, but rather they just present something from the outside to inside. So if I am passing some text, it would represent it in a certain way. If I would like this button to have certain properties, it try to represent it in another way. So this is the first part, which is called components. Containers, on the other hand, would be collection of things that would have some internal logic to them. So for example, the to-do container would be this whole part, which would have some logic to import the to-dos from the back end. So we'll get like some JSON, and it would bring it to our application. This is called a container because it has some logic, and it also tries to manage the state at the same time. And eventually it does some computations and then pass it to our components to show them, either to pass it to the list of the to-do items to show them as each one on its own and have an array and so on. But from the outside, the container is telling to the to-do list, hey, please represent these to-dos to me. But it doesn't manage how it would look like. The component is what manages how it would look like at the end. So these are the first two concepts from the architecture perspective, components and containers. And now let's try to work them inside React. And during this course, we are going to use create React app. It is mainly used for educational purposes. Of course, if you are using production, I would advise against using it at all, because you could have other better tools and you would have your own custom tools. And I would advise using, for example, Webpack or Vite. Of course, like Vite is more advanced now, but if you are interested in Webpack, I already have a course for it, and Vite would be coming soonish. So in this video, we are going to use Create React app, but again, I am pointing out it is advised to not use it in production projects. And let's now go to Visual Studio Code. If you haven't already installed Create React app, you can install it because it's super easy. And we are going to create our project using the Create React app, and we will define it. We are going to use TypeScript. So let's create our application. Let's now go to our application. We write code to do, and now it opens our Visual Studio Code window. And let's start our project. So npm start, and it would start the React app, which is a simple like hello world application. And let's discuss every directory. So node modules already have like the different node modules and dependencies you already installed. Public directory would have like different images, icons, JSON file, anything that are not JavaScript and CSS. This is not mandatory, it's just how it is structured here. You could have them inside the source file, which would include your source code, but you could also keep them inside the public, depending on how you would like to organize your project. And then we would have our index.tsx file, which would be the entry for our project. So internally, there is Webpack that is going to build all of this. Of course, there is now way to build the React applications, but for creating app is just using Webpack, and it has an entry file which is the index.tsx file. And basically what it's trying to do, it is trying to find a node on the DOM which has an ID called root, and then it would build the React application and then attach it to this node. Where to find this node? It's inside the index.html file. You would see it here inside the div, and you would have the ID, which would say, okay, please attach my DOM or my React application to this node. Let me also zoom a little. Yes, this would be better for the video as well. And then after it builds the application, of course, like it builds the application, like we said, it attaches to the root. And then we have our app, which is inside the app.tsx, and it would have our application. And what you see here, it's JSX, and JSX is HTML inside JavaScript, but it is not actually HTML inside JavaScript. It is just a way to write something that is developer friendly as an HTML, but internally all of this is translated into JSON. You remember when we said we have like two libraries, there is React and React DOM. So the part of React, it is building, of course, like not React itself, but JSX, it is building this DOM as a JSON. And then React DOM would translate this JSON format into the DOM eventually and map it. This is how it eventually works. So all of this is eventually translated into a JSON. It is not like this way. There is a function internally, it is called create element. As far as I remember, this is from React, and from here inside you could define, okay, I would like to say it's div, it has different properties and it have various children element. This is how React is translating JSX, which like we say it's HTML, but it's not actually HTML, but it translated from this format into these methods. So it would translate div, and then internally inside the array, there would be another create element, which would have the header, and then it would have other properties, maybe class name if you would like to define it. So you could write this format into this format. This is valid, but of course it is better to see it as like HTML because it's more friendly. If you would like to use create element, it is fine. Also, a small note, JSX, it is not part of React. It is used inside React, but it is part of Papel. So there is a Papel transpiler which would transform these like semi-HTML elements into the create element function, which you could eventually implement it in other ways. You maybe say, okay, I don't want every element which is div to be translated into div, but rather maybe you would like to use web components. So you could do this translation, for example. Let's now change all of this just to see how it would look like as well. And it's basically could remove all of this and we call it hello world, just to have our hello world application. And it would immediately refresh, and now we see our hello world. And during this course I would be copying pasting stuff just to speed things up as well, just to not get into the boring things that you already knew. So let's of course like do some cleanup, and now let's start creating our first element, which is the header part inside our to-do application. And how we are going to build it? First we need of course to define our header, and then we would have inside it some navbar. So all of this is just writing as if it's an HTML things. And we could have our home, and we would have another one which would be stats, as we saw in the intro, and there is also an about link. And when we save it, you would start to see our application is getting some looks to it. And we would like to have an H1 to see the to-do app. So it's as if you are writing HTML, and eventually all of this is returned. It is transpiled to this create element that we told you, and then it would return inside this function when it is executed. So this is just a normal function, and then it returns what is going to output to our index .tsx, and then it is going to be rendered and attached to the DOM, just to have like in your mind how it's building and transpiling and doing all of this. And here is the React DOM that is going to translate from React to the actual DOM. Okay, so we now created our header and it would have some looks to it. Let's now abstract all of this into its own component file, because of course, if you're going to build the whole application in a single file, it wouldn't make much sense because it would get huge, but rather we would like to abstract things to its own separate files. So let's have our header.tsx component, which would be its own separate component, and let's write it step by step. So we can write export const header. So we would like to export a header function, but it is not function, of course, it is functional component, but we just like say it's function. And then we can return, of course, we can return create element if you would like to do this, but it doesn't make much sense. But I would just like you to see how it would look like if we return a div, and we would have internally maybe some children, which is called the inners of the component. It is similar to inner HTML, but in React it is called children. So we would say children, maybe it's using create element. And this is how we create our element. And then if we would like to use it, we will just define it. And we say we would like to use header as an element. This is not similar to this. This is different. This is a React component, or in our case, it's a React functional component. And this is the normal normal header from the DOM. These are two separate things. Just wanted you to have an idea. And let's save it. And now we see using create element. So it is working internally, but of course, we wouldn't use the create element because it doesn't make sense. And we are going to use our JSX that we already created. So let's remove all of this and return and remove this extra header. And now we're exporting our header component, and let's clean all of this. So now instead of having huge file, we have a single element which would encapsulate everything that we already would like to create. And this is called a component because it's just representational. It doesn't have any logic. If we have a presentation and some logic other than this, we will show it, of course, like later, but it would be called a container. So these are two separate things. And from the looks as well, it doesn't look great. So let's add some styles. So let's create header.css, not CSS. We are going to use Sass in our case. So we define we are going to use Sass. And I'm just copying the styles from another file just to speed things up. So we can have header and header title like this, or we can, of course, use at first our header element because we can target HTML elements. And let's define this one as h1. And then we can import the Sass file into our application. Because I am using create React app, it would transpile Sass into CSS and then add it to the document. If it doesn't work, then of course you need to define these things using Webpack or Vite. You need to define these loaders. So let's import our styles. And if we save it, start compiling things. And let's see how it would look like. Now it is looking goodish. Maybe we need also to add some styles for our links. And I have copied them as well. So let's go to our header.sass file and add some styles. So just like color, decoration, and some cursor pointer. And now it is getting a little bit better. Of course, there is now a little bit of a problem because we're now applying the whole styles to the whole document. So for example, in our application, maybe for some reason, I would like to add a link after the header. And if it's a single line, you could return directly. But if you're going to return multiple lines, you need to add it inside these brackets. Let's add our link and we say body link. And it would complain because we are returning two elements from the same root. So inside JSX, you have to always return one element at the top. So we can abstract or like add just a div around them and return a single root just to bypass this error. And I will explain later how to can actually fix it. But you can see the link that we have added already, it doesn't appear because it already has a white color that it got from the CSS or sass. One way we can do or fix it, of course, you already know how to have some class names, and we can also have it for the other one. And we can change this one. Okay. And we can then add the styles. And to add the styles, you would think, okay, I would add class, but class is not working because this is like we said, it translates to JavaScript and JSON, and class is a saved keyword inside JavaScript or like protected keyword or like this forbidden keywords that you can use as variables. So instead there is class name that you are going to use. So we can add header not header title for this one. This one would only have the header styles, and let's add class name for our application. It would have the header title, maybe also change it from h1 to div just to remove all the default styles. And we have the others as well, would have class name header link. And this now should work and only affect our styles. So it looks good now. Now there is a better way to actually do these styles because of course, like if you check them inside our div tools, you would see they have our class. But if we have another team that is working creating another component, in this case, it would have another name. They sometimes may have another name or the same name, and then you would have contradiction between the CSS styles, or you have like conflicts. So each one will have their own rule, and then you start to see like the important things that we add after CSS styles, and this is wrong. You should never use it, only in extreme cases. But if we would like to avoid all these naming collisions, there is a better way to import CSS files, and CSS styles, and I'm saying import because instead of having them as class names, we could actually have a random name that is generated inside not React but inside Webpack itself. There is a loader to transform these styles into another random names, and they would be unique to this component, and they are called CSS modules. And CSS modules is coming from modularizing them. So basically we're trying to create like modules from them, and they would become unique. And how we can do it, we just rename our file from header only to become header dot module, and now we can import it. We will change of course the name dot module, and we can now import it as classes from this file. And let's console log this one just to see, like eventually it's going to generate them as random names. Let's check the console, and now you see there is the name of the style that we already have. This is the actual, like not the actual one, but this is the thing that is familiar to us as an object or key for the JSON objects that we are importing. And these are the random names. You start to see like header underscore header. This is the name of the file. This is the name of the class, and then some random unique things just to make our styles unique. And by using CSS modules, we are making these styles only apply for this part of the application. So we're sure there is no collision between styles between our component, for example, we are building, and another team's component. This is the beauty of it. There is a better one called CSS in JavaScript, but like HTML in JavaScript is a little bit controversial for some people. So CSS in JavaScript would be more controversial for this video. So let's keep it for another video, but it's actually better than even using CSS modules. So let's start use our classes, and instead of, because eventually it's just like a key and object, like key value, and we just need to import the key and then it would replace it with our value. So let's change our class names to the other ones. And in JSX, this would be, of course, like normal things that you already know, but when we change it to these curly brackets, what's inside all of this is now JavaScript. And you can transition between JavaScript to JSX and JSX to JavaScript and from JavaScript to JSX. This is all of this possible. And we are going to see it like with adding conditionals and loops and mapping and all of these good stuff. So let's now change this and use classes dot header. And now you see like it's auto-completing automatically. And let's change our header title, or yeah, header title, and also for our links. And I'm going to have multi-cursor. If you don't know it, it's using I'm using option in Mac, and I think also in Windows it would be Control or Alt. Just try one of them and it would work. Okay, now I added the curly braces, and you have classes dot header link. Okay, let's check them out. So now our links is getting better, and we can eventually move the body or like the extra links that we added inside our app. And maybe before I remove the extra component regarding this div, like we eventually added an extra div around our application, which is not good. It maybe be fine because it's just an extra div. It is not a problem, but it's unnecessary div. So instead of just keeping it, there is something called React Fragment, or like it's also like it's a DOM fragment or something. It is just a virtual DOM node. It is not like a real node. So what we can do it is just we remove this div, and now we have our fragment thing, and it will create a virtual DOM fragment around our app, around our internal children, and we don't need to have this extra div. And now our application would be cleaner in this case. Okay, anyway, this is a side thing. Let's just like clean our app because all of this is not necessary. And let's keep the fragment because we might need it. And in the spirit of cleaning things up, we wouldn't keep our header on this top level because it doesn't make sense to keep it there besides the whole file because it would get longer. So we are going to create a components directory, but I wouldn't add them inside our components directory. We'll just like keep the directory here, but rather I will create another special one. I call it partials. And partials are things that are used once inside the application, but they are not used multiple times. So components would be from our application. Like for example, you would have checkbox here, but also when we start editing, there would be like another checkbox there. There is button here, button here, button here. It is used in multiple places. So all of this, I call them components. But if something is used only once in one place, I would name it partial. This is, of course, personal preferences. I'm not saying this is how you should build your React application, but it's just like how I like to build these things. You could name it whatever you would like. Maybe you could name it like templates, I don't know, or like small parts or parts. Like all of this is possible. And this is one of the other benefits of React. There is no opinions. You could build it with whatever way you would like to do it. It doesn't tell you, hey, you must build it this way, but rather it makes it open. You could build it with A, B, Z. You have all the options you would like to build it. So let's now move our header to the partials, and I'm going to create another directory and I call it header just to make things clean. And I would move the header to it, and of course it would start complaining because all of these are not now working correctly. So we'd import the header. So now we fixed all the links and it is working nicely. Let's also abstract the header link because like we wouldn't keep the links like this. It doesn't look great. So let's create another component, and I am creating it inside it, not at the top, but rather inside our header link. And the reason behind this is that it makes easy to access it. It is only used under the header. If it's used elsewhere, I would move it, of course, to the components. But since it's only used inside the header, I keep it inside the header because if I would like to read this file later, it's just easy. it's inside the header, so it's probably inside the header directly. So I just like go to it. Let's create our header directory inside it, and let's create our file. And also let's create the modules file as well, or module CSS modules. And it is Sass. I need to keep remembering it's Sass. Let's move our links here and our component or our JSX for this component, and let's export const header link and create our function and then return it. And the classes are not imported, so we need to import them as well. So import classes from header link dot module dot sass. And now should be working. Yes, I named the file incorrectly. It should be header link. So now it is named correctly, and let's save it. Maybe it just needs some refresh. It's a small stupid thing. We didn't import the file or didn't use it. Okay, so let's use our components that we already created, and let's replace the others. And of course you would start to see we are going to have a problem, because if you check them out, it's home, 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 home. So we need to make them unique and change what's going to be rendered inside. So we can fix this, of course, easily using the concept of props, which is the first concept is in React. Of course, we discussed two concepts in front-end architecture, which are components, containers, and the special case of components, which is partials. But there is also concepts of React. So first concept of React is props. So we would like to, similar to attributes inside the DOM, you would like to change what's inside it. We pass them as props. And since this is a function, to pass a prop, we pass them as arguments. So inside the function, there is the first thing or first parameter. It is going to be passed. It is called props. You can name it with whatever you would like. You can name it like, I don't know, like T, X, U, L, whatever you would like. All of these variables are fine, but doesn't make sense. But what makes sense is props, of course. So we create props, and one of the props that is going to be passed, we could have different things here. Like for example, we could have title, and we could say we would like to pass title as home for our case for this one, and the other one would be about and states. And if we go back to the header link, there would be a prop. If we console log it, there would be one of the props. It's called title. Of course, this is TypeScript, and we'll start adding TypeScript. But like we said, we first add any, just to make things work out. And then we see there is home, about, and stats. And you also notice that it is as if it is rendering twice. And this is something new about React 18. It is rendering components 2 times. It's a way to make sure that things are stable, and if there is something unstable in regarding states, effects, of course we'll come to them later, but just to answer this quick question, it is just a way to protect you and show if there are any errors. And how to stop it. Of course, this is only during development. How to stop it is just you would remove the strict mode. You keep the strict mode during development because it can show you bugs, but then we can remove it during production. Let's get back and then we'll come to it later, but just to answer why it is rendering twice. Okay, so now we can access the props, and like we said, we can have the brackets and props.title. And we can now refresh and we see like home, about, stats. This can be a good way to render them, but I don't like this way of doing it. I like to pass them as children because it's easier and looks good, and it's like similar to what we see in HTML as div elements. So we can just replace, instead of passing them as one of the properties, we just pass them inside, and we create another header link as a closing tag. So let's now create the three of them, and we have about, and we have stats. And let's replace this one. Instead of props, we have children, and just see, yeah, working. And instead of passing props like this, we can actually do object destructuring and just extract children from inside. This is a ES6 feature. Okay, it is still working. Of course, this is like just getting angry because ref is empty. Just let's add a default one for the moment being. And of course, we are going to replace it later in our React router part. But maybe let's add it here. So we could have URL and we can use it here. Okay. And everything should be nice. Now let's replace this any part and we'll just create a type, and I like to call them the same name as the component, but I just add props and then we define our types. So URL is just a string. This is easy. Children, what should be the value of children? For our case, it is fine to be just a string because we're only passing a string, but we need a general term for anything that is passed as React. And the name for this, it is called ReactNode. It is not importing correctly. Let's just like import it. And it is imported from, of course, React. This is a TypeScript type. Yeah, TypeScript type. Nice name. And let's just replace any with the header link. And everything should work. Let's see why it is not working. Yeah, it's just like the URL is missing from some of them because we didn't pass them anyway, so we can define it as an optional property. So what is React Node? If we go to the definition for it inside React, we can see it is defined as a React element or string or number or React fragment, the ones that we defined it earlier, and a boolean, null. It's basically anything that could be passed and it is printable, that could be converted to string. But inside React, there are two things. There is React Node and there is React Components. So what is the difference? You know, there is classes and there is objects. And classes are the blueprint and objects are what is going to be created. So React Node and React Components are the same concept. React Components are going to be the classes. They are what we are creating here. Like header, link, they are React components and they are called functional components. So you could actually define it as function component and it is imported from React. You could define it and then you could pass different props to it. As far as I remember, this works. But it's just like complaining because we haven't imported it yet. So we can import it and it's the same thing, but it is just redundant. It is not necessary because it's already understands that this is as a function component. But when something is being executed, because this is a function and it's going to be executed to create element from React, all of this is going to return a React node, which is the actual thing that is going to be rendered, as if it's like React elements, strings, booleans, any of these things. They are called React node under all of this umbrella. So children would be React node. When we come to a very, not a very advanced, but rather like one of the advanced things, which is called higher order components, we are basically taking a React node and returning a React node, but just like adding extra stuff to the node being passed through. Okay, so now we explain this. Let's just do some cleanup and let's git commit because we haven't committed so far and we don't want to mess things up if we missed it later. So git add, git commit, -m, create header and header link. Okay. Let's now add some styles, like more styles, because yeah, this doesn't look good. And also I don't like the name of Todo app. Let's name it Just Do It app. We just do it, you know, the video. Anyway, if you know, just comment. Okay, so now we need to add some global styles, and we are going to create a directory called styles, and we are going to create two Sass files, and I'm just also going to copy paste them and just explain them because they are not huge, but just they are doing too many stuff. And the first file would be our design tokens, and these tokens are just like small, not yeah, small, yeah, small Sass variables, and they define the different styles that we have, colors, font sizes. So we have different colors that we are going to use inside the app. There is definition for what font we are going to use. So we're going to use Poppins. We are going to have some spacings. We are going to have some font sizes and border radius as well. Yeah. So we are going to have some tokens, and these are something related to design, system designs, because we are not going to use Bootstrap or Tailwind or any of these things. I'm just creating our own design small system similar to Tailwind. So basically we are going to have Tailwindy looks. So the first part we created now is the tokens, and the second part would be our general.css. Of course, it doesn't have to be called general. Again, you can name anything you would like as what you like, because this is what React gives you. It gives you control on whatever you would like to do. It is not like Angular, for example, that tells you, hey, there is a certain way to do things. But here it gives you like, do whatever you would like to do. Total freedom, anarchy. Okay, so I'm going to copy them. These are the general styles, and let's go through each one. So the first part, I'm just importing our tokens. Here I'm defining the font, Google fonts that we're going to use, which is Poppins. There is also font awesome icons because we are going to have some icons like the edit and delete. So we're going to have them. There is some body styles we're going to add. This is just to make bordering, padding, and margins work correctly. We are going to have flex grow, width 100, because I don't want to use like these things, just to give you an idea that we can do all of this. And now the fun part is we are going to create similar what you have in Tailwind. You have like of course, if you don't know Tailwind, it is fine. It is totally fine. You don't need to watch it. So in summary, we would like to have, for example, m-1. So we would like to have m-1, and then it translates to some margin. If you would like to have margin right, it would translate to some right margin. If we are going to have margin left, it will go and translate to certain margin. Margin top, it's going to translate to another margin. Margin 2, 3, 4. So all of this is possible, and we would like to do it as well with padding. So PT means padding top, and then -1, it would be the first spacing. But instead of writing all of this manually, like P1 is equal to this style, P2 is equal to this style, PT1, all of this would take a lot of time, but rather I created spacing and what are the names that are available, and then I loop through them and start creating our margins. This is just a 2 for loop. It just takes one of this and one of this, and then get the spacing of it. So it takes one of the margin, one of the spacing, like each margin name. And for every spacing, it would start creating our styles for it. So we are going to have O2, 1, 2, 3, 4. And then we have margin, margin right, margin left, margin bottom, and margin top. And instead of like adding these styles manually inside the CSS, just if you saw it when I'm writing them, you know, these are the source for our styles. So we now created it, and now let's fix for the other styles that created for the header link and header as well. So let's go to partial header link. This doesn't seem correct. It should be small k. Yeah, it's a subtle difference. Okay, so we go to our this, and just I'm going to replace them. So I'm just replace the token. Now we are using one of the tokens and empty line. You see, of course, like from get, from the changes on the side. So this would be the header link. And now for the header as well, we would use our tokens. So also font size using the token and just importing the token file. And now let's also add our styles for the header link on the side. So it is going to take each one of them. Each one of them would have their own styles. Of course, we could have class name at the outside, but again, this is not necessary. We could just add them internally. But what we need to do is, yes, maybe just some naming conflict. It is just the token. It should be tokens. That's it. Now it's working correctly. Let's get back to our header, and for the nav, we need to have margin auto just to make it to the center, to center it. Let's refresh. It doesn't take effect. Oh yes, because we haven't imported the general styles. We can remove the app, it is not needed. And instead we import our styles general. .sass. Okay, now it's working nicely. And we need to give padding for our links as well. So we can just concatenate strings. So we can add plus, then add some space. And we have margin right 1 and margin left 1. Maybe change them to 2. It would look better. Okay, so looking good so far. And I'm going also to get commit our changes, because yes, again, don't miss styles, miss our changes. Okay, now let's do our to-do items. And what usually happens is that yes, I will create a component and import it. This is one way. Another way is just like develop it here and then abstract it and then move it to its own file. This is just a way of habit of how I would like to do my changes. It depends from time to time. Yeah, it was unnecessary. Okay, now let's start working on the todo item and todo container and our main application. So the first part we would need to create, of course, is the todo container, which is our basket. And then we'll write a bunch of code. And after it is ready, we would create our todo item container and start creating different components inside it and then branch them out to their own file. It's just a way of doing it. And why we are saying it's a container and not a component? Because container is going, one of the things it's going to do is to fetch an API, to call an API, get these values, and then populate our to-do item list. So from the start, it's obvious it is container. Of course, if you start writing some code and you are not clear whether it's container or component, you just like write some and then see how it would go afterwards. So let's create our containers directory, and we are going to create our to do container.tsx, and of course it is going to have its own styles as well. So let's create it inside its own directory, and let's move our file here, and let's create our modules file as well, or yeah, css modules. It is module, not modules. Okay, and let's export it. Support const to do. Let's export to do container as a function, and let's import as well. Oh, this is incorrect name. Okay, yeah, seems to be fine. And I like to just return some hello world or something just to see it is working, like it's a little bit of trust. So to do container, and let's see how it works. We are returning as a string instead of, okay. Yeah, that's fine. Just maybe like some brackets happening here. Okay, just we have now like a playground where we can develop our component for us. Okay, and let's also import our classes from todo container dot module. Okay, and we need to add dot sys. Okay, everything seems to be fine. And now let's create our element. So basically it would have a div, and then there is another div inside it. We're going to have an input, this input of type checkbox, and then we are going to have another div which would have task to do, the name of the task, and then we are going to have another div, and this div would have a button, and this button would be delete button, or the first one would be edit button, and the second one would be our delete button. And let's check it out. Yeah, just yeah, of course it's empty. And we can go to font awesome icons to see different icons you would like to apply. This is the icons that we already using. So for example, for the edit, for delete button, we would like to use the trash icon as an example, and you would have the different rules of how to import it. You don't need to use React or Vue because yeah, we are not using the library itself, but rather you can use styles. Okay, let's get back, and instead of having this one, I will just use the one for the edit to use the pencil icon, and for the delete we are going to use the trash icon. And let's remove this empty space, and let's close this. Okay, now it has edit and trash, and let's make them all on the same line, so they would have class name flex. This is the ones that we created inside the general rule, and then we need to apply some general styles for the whole to do. So I'm going to also import it, of course not the whole to do, sorry, for the to do item, and I am going to call it, and I'm going to copy it again. So and I'm going to explain each one. So we have here todo item. It has some background. This is the whole item itself. And then to do when it is done, we just pass it through. We are going to use this style later. Okay, let's import it. So we can just change this one to become supporting JavaScript and classes dot todo item, and then space plus, and then we have our flex. Okay, now it is going good. Let's also reduce the size of the page because yeah, it wouldn't span the whole application, not the whole window. So we can change this inside the app. It is fine. So instead of having to do container, let's just quickly do it, and I will explain how we can do it better. But we are going to add a class name, margin right auto, margin left auto. And what is going, we are going to change later, but just I would like you to see it is possible because it is eventually going to JavaScript stuff. You have style, and you could add your custom styles. So we can add width, and we can say it is not 100, but 100, not 100 even. We would like it to be 500 pixel, and let's change it to a string. It is as if you are defining styles explicitly for certain components. And now the item is not confined with its own styles because it could be in a place where it is small, it could be in a place where it is large. So it doesn't define its own space, but rather the component who is importing it would tell it, hey, I would give you only 500 pixel and you need to adapt to it. This is another way of course, like to style things. Okay, let's continue. Let's push this pencil and trash to the end. So we are going to give margin auto. Let's go to our to-do container. Of course, we need to abstract this to to-do item because now it doesn't, it feel like it's going to be its own component, but just let's add it. Okay, so this would have class name and margin right auto. Uh, Not this one, but rather our to item itself. Okay, so now it has some margin, so looking good. Let's move now this to become its own component, and again this is only used inside our to-do container, so we can just have it inside here. So we have our to-do item component, and we create our tsx file, and of course again our module file or Sass module file, and let's export const TodoItem as a function, and let's return. Let's get the styles from here, and let's define TodoItem as one of the items, and let's, yeah, this would look good. Copy and paste, and let's copy our TodoItem styles from the container, because it's not longer part of the container, but rather it is part of the TodoItem. And let's import the styles. I would just, no, not copy paste. We'll just import the styles from here. So import classes from TodoItem dot module dot sys. Okay, let's see how it was looking like. Yes, it's looking nice. Maybe we can remove this console log, because it would later, we will forgot where it was. Okay, yeah, it was inside the header. I'm just like removing some console log. It is not necessary. Okay, back to the TodoItem. So it is looking good. Let's also do some styles to our buttons and checkboxes. But as you can now understand, these buttons are going to be used in other places. So we can abstract them to their components, because they are not going to use in one place, but they are going to be used in multiple places. So we can create components for them as well. And we are going to, of course, add some custom styles to them as well. So we are going to the components directory, and we're going to create a button directory, and we're going to have button.tsx, and then we are going to return this button. So export const button, and let's create the function and then return it. So return our button. And from what you see, of course, also the class icon, we need to replace it with children, because we need to be able to customize it. So children, and the structuring here as well. And let's pass button props, and let's define the type. Button props is equal to children and ReactNode, and we need to import it. So import ReactNode from React. Okay, and now we can use our button inside our TodoContainer. Let's close all of this, because also one thing, I don't like having too many files open, because it is a little bit distracting. So back to the TodoItem, and replace the button with our JSX1, and now we import the file, and we replace the icon here, and then we can remove the old one, and we can do the same for the trash. Okay, and let's check it out if it's working. Yes, it's still working. Maybe refresh as well. So we can refresh, it's fine. Let's do as well for the checkbox. So checkbox, and we can name it checkbox field. And let's create a file for it. So file.tsx and module.sys. It would be great if Copilot could create those files when I create like a directory. Yeah, but this for another time. Okay, export const checkbox field. We return it. And what we're going to return, let's go back to the TodoItem. Let's copy or cut and paste. And let's import classes from our checkbox field dot module dot sys. Okay, and let's now use our component instead of the old one. So field, okay. Let's check it out. Okay, everything seems to be working nicely so far. Let's now import the styles for each one of them. So I'm also going to add button.module because I didn't create it. Okay, and let's import it as well. So import classes from button.module.sass. Okay, so now let's add some styles for each one of them. So for the button, I'm going to copy paste these styles, and basically we are going to add some border radius, some border, padding, transparent, add like a text transform to make it all uppercase, font size, line height, and cursor. And of course, for border radius, we can change it with a variable from border radius, this one. Let's check it out. Okay, because we didn't apply the styles yet, so let's go to our button, and class name is equal to classes dot button. This now should apply. Okay, there is some, like they are not transparent, so we can add some transparency to them as well. So let's go to our styles file and let's add transparent, and we are going to replace it later, but I'm just like would like to keep. And of course this doesn't look good as well, so we need to add some styles. So let's add for the text first. We need to make it center, top and bottom. So we add some margin top auto and margin bottom auto. So margin top auto, margin bottom auto. So now this one is centered, and also we need to center our checkbox as well. So I'm just going to copy it again because it would require some playing around. I just like created some margin top, margin bottom, but it goes a little bit down, but I need to offset it with some styles. So it is just a matter of changing position. So again, not a CSS course. So I copied also the checkbox styles as well, and this would add some cursor to have some pointer. When we hover over it, it would have a pointer, but of course we haven't applied it yet, so we need to apply it. So let's get the checkbox name and apply it around our input. So I'm going to create a div, add my input inside, class name, and then classes dot checkbox. And I just cannot find the file, so we just need to correct this one. Okay, let's check it out. Okay, it is nice-ish. We can remove this margin. Let's check it out. Yeah, not better. Okay, let's keep it for now. Yeah, it would be good if there is like half pixel, which I guess it's possible, but it doesn't make sense. Anyway, it's not a problem. Let's keep it for now. Okay, so yeah, it is got better now. And we can eventually create multiple to-do items. But of course, we need to now replace this text that we already passed to become one of the props. And let's make sure that we don't have any in the components that we created. So we don't have any, this is fine. Let's go to our to-do item, and now let's pass our to-do as a text. So we can name it to-do. And again, we are going to have type. So type to-do item is equal to do, and it's going to be a string. And we are going to not to do item, sorry, it should be to do item props, and we define this one here, and we need now to pass it because now it's a mandatory field. So let's go our to do container because it's the one containing it, and let's name it to do is equal to do something. Let's see it. And we need to replace it because we didn't replace it inside. Yes, we didn't replace it. So let's replace it. So instead of to do, we replace it here inside the text. Now it's fine. And this would lead us if we would like to have multiple to-dos as well. So we can return. And again, we would need our fragment here. and do other something, do another something. Okay, so yeah, this is fine. But of course, we wouldn't be creating these things manually. We need to eventually fetch it from an API, but we wouldn't go with fetching APIs now, but rather let's go step by step. We would like to create our array of to-dos, like it would store different to-dos inside it. So we are going to have to-dos as an array, and we would have different things. Do something one, or do thing one, do thing two, and maybe do something this thing. We can copy it. And eventually we would like to change this array to become items. And this is the idea of mapping, because we would like to map string to a JSX. And then of course React would transform it from JSX into the DOM eventually. And we can use map. And if you remember, we have our curly braces, which we can use JavaScript inside it. So we can eventually, yes, we can do dot like to-dos, and then we can use map. And then inside this map function, it would loop over every item inside the array, and it would give us one to-do. And then we can use the arrow function to return one of the JSX items. And this works. And let's remove the others as well, because it's not longer needed. And let's use our to-do instead of this string and pass it as one of the props. Let's save it. And we see it is working. To do thing one, do thing two, do something. And this will give you a warning that you need to have a unique key to be used inside the loop, because when React is trying to eventually build the DOM tree and try to map what is the current state and when you need to change it later, because you would like to change the state for numbers and so on, React needs to find some unique ID to be able to map from the current one to the next one, just to speed the re-rendering or not to do any unnecessary re-renders. And that's why it needs this key to identify which item maps to the other item inside the tree that is going to be. Of course, we are going to speak about this whole virtual DOM thing later, but this is the concept. It is trying to find an ID here and the ID to the upcoming tree, and then map it and find what is changed, and then find, okay, this change, okay, I was just to replace the whole DOM and re-render the item again. So we can add a random key for like any key for now. Of course, like it's not like this. We write it like key, and then we can use index for now. Of course, later we would have a real ID. Okay, so we add the index, and let's refresh. The warning now gone. And we have our mapping. Of course, this is not needed, this curly brace, because it's fragment and curly, and then it's going to return JavaScript at the end. So we can just remove all of this and just return. Okay, so it is going to be returned as one line. Okay, this is prettier doing its own stuff. Oh yes, it needs to be fragment because it is going to return an array. It shouldn't be working like this. So it was originally correct. This one is needed. Okay, so this is working. And let's commit as usual. So git add, git commit, create TodoItem, because it's the first one. We didn't create the TodoContainer yet. Now let's create our form so we can start adding tasks, because eventually we don't need only this array, but rather we should allow our users to have their own task as well. So let's first start by creating a form component or a form tag or JSX in this matter. And then we are going to have a text field, and we are going to have a button component, which you already have created. This is with the JSX, not the HTML one. And also you see like it has like a different color. And then we add the add button. Now looks good. And of course we need to style this input, but eventually we are going to create it as its own component. So why not from the start create a component for it? So we create under the component directory a text field directory, and we create the JSX file and the not JSX, TSX, and also the Sass modules file. Okay, and let's cut it from here, and we add it into the file for the text field. So export const text field, and we exported function to return, and let's just paste it. And we also need to import classes. Import classes from, we need to add the current directory, text field dot module sass, and then we can use it. And the text field, we need to import the file as well. Let's check everything. Yes, still working. And then we add the styles in our Sass file. I'm going to copy and paste them as well. And basically just adding some padding, some border radius, and width to be 100%. And let's apply the class name. Let's import it correctly. Okay, looks good. We need to make all of this on the same line. So we go to our container again, and maybe we can add all of this inside a div, and this one also inside a div. And we apply both of them into another div. Yeah, too many divs. And class name is equal to flex. Okay, looks good. And we need to have width 100 just to take the whole width. Okay, we need to apply another class. And it wouldn't be this one, but rather we are going to apply class name for the other one to have flex grow 1, which we already have created inside our general to basically let it grow. This is flex boxes as well inside CSS if you would like to check it as well. And basically this is the styles that we have applied to make it take the whole width. Okay, also we can see that the button doesn't look good, so we need to style it because all of them are transparent. And in this case, we could have multiple styles depending on certain parameters that we pass to the button. So one way people might say, okay, let's add class name and then pass it from the button inside to the internal button. But to make the API consistent, we would rather have a property that defines the type of this button, and then internally we could say, okay, if you pass a property that is called, for example, primary, then we have a blue background. If you pass another property secondary, it would make it yellow background, and so on. If you pass transparent, then it would be transparent, or by default, it is transparent. So in this case, it would depend on a certain property that we pass to the button, and then the button would determine my own styles. But from the outside, we don't care about which styles are being applied. But internally, button would be the one caring about this, which is its own main concern as a UI. So let's copy the styles that I already have created for the multiple variations of our button. So I'm going to copy them and explain them as well. And I just need to remove the old transparent background color. And then we are going to have bottom dot primary. So if we have a component that has style of dot button and dot primary, it would apply this background and color. Secondary would apply these colors, and so on. We have also one for disabled and also one for transparent. And let's start seeing how it would work out. So if I go to my button, and then if I add plus, and I add some space, and then I add classes dot primary. I think I imported the incorrect. Oh yeah, I need to add the plus. Yeah. Okay, let's see it. So now we have our blue background. So in this case, instead of having these tiles passed from outside to inside, we would rather have another property here. We call it primary, and this would be a boolean. And this is not necessarily needed, so it's optional. So we have one for primary, one for secondary, and one for disabled. So let's name them secondary and disabled. And we can have also another one for transparent. So transparent as well. And this is also optional. Okay. And what we are going to do is we are going, for example, like there are multiple ways to apply it. We can have a a string. We can say it like let class name is equal to an empty string, and then we could have if primary, or not if primary. We need to extract it, of course, from the props, and we say primary, and we say if it's primary, then please add class name, which is primary. Then we add this one. So just like adding an extra space in front of it. And if it's a primary, we just add it to it. And we need, of course, to assign it. It says there is an error. Of course, it makes sense. And the default also, we need to copy it. The default, which is button. And we copy paste here to be as the initial start. And then if we define this as primary, it would have blue color. So let's go back to our to-do container and pass primary equal to true. And it would have our blue color. Also notice that if we remove this true that we already passed, this is also true, like without passing it. If it's available, it is also true. And this makes it much better to read and also for the eye. Okay, and we also need to configure the ones for every to-do item to be a transparent. So we need to pass transparent for this one and this one. Yeah, there are only 2 buttons. Okay, but they wouldn't read it because we need to add the other if conditions. But we could have this one as this, and then we have our transparent as well. This all would be fine, but I'm going to show you like a better way, but just to see if it works. Okay. Oh, yeah, it's capital. Okay, now it's transparent. Another way to do it, which I prefer, is to have it as an array. So we have an array like this, and instead of having this extra space and so on, we just replace this with dot push. So it's the same thing, but it's just another way of writing it. And we have this one as dot push, and instead of having class name, we have class names, and we change this one to const, which I always like to have variables as const instead of let, because it says, okay, this wouldn't change the reference to it, but when we define it as let, it would say, okay, I'm going to change it later. So if this is a small component, you're writing it well, it is fine. But if it's a huge component, yeah, it might be a little bit hard to know where it is changing easily, of course. Okay, let's get back, and we have class names, and then class names dot join, and we can have our separator here. And when we check it, everything is working correctly. And we need to have some margin between the button and the text field. So let's go back to our Todo container, and besides flex grow, we have margin right 1. And now we have some space. Maybe you can change it to 2 actually, would look better. Okay, this is looking good so far. Let's now do it for the other styles for the button. So we added primary, transparent, and also let's add secondary as well. So secondary, and we needed to extract it from the properties up here. Maybe not edit this place, but rather here, because it's primary, secondary, and transparent would be the last one. Okay, secondary wouldn't use it now. It would be used when we have our filters, which we are going to do later. Okay. Okay, before we continue, we commit our changes. So get add, get commit, and add text field, and change button styles. Yeah, this would be fine. Let's now speak about the second concept in React, and probably the first React hook that we are going to use, and it's called useState. And useState helps us to manage the state of the application. And instead of us managing it inside variables and DOM APIs and calling it, and when this variable changes, like for example, when a button is added, we get the value from the text field, and then we add it to the array, and then we like re-render the DOM again. All of this, we are offloading it to React, and React is giving us a function. It's called useState, and it would help us to first get the current state of the application to inject it inside our representation of the DOM of JSX, and React, of course, would manage the re-rendering part, and it would give us a second thing, which is a method to help us update the state. So in this, by using this way, it would offload managing the state from our side and having too many functions to React, and then React would be able to compare, okay, this part in the DOM it changes, this part it changes. So I would speed and start applying these changes to the DOM. And we are offloading all of this to React instead of us managing it. So without speaking too much, let's start looking at it. So I am going to comment first this array and start importing or using useState, as I said. And it's just a normal function. And the first parameter of it is the initial state for the array, or like this variable or this state. Since this is an empty array, we just add an empty array, or we can use the current ones that we have already added before. So we're now using them, and useState would return two things. So the first thing, it would return, of course, like it returns it inside array, so we need to use array destructuring. And we get the first one, which is the current state, which we call it todos. And the second one is set todos, which is going to set the state or update the state. For example, when we click on a button or when we do any change and so on. Okay, so of course it says this is not defined. We already defined todos and we are using this one. Okay, maybe it just needs some refresh. Okay, yeah, it just needs some refresh. Anyway, so we have our method to set todos and we have the other one to get the todos. So what we need to do is when a text field changes and we click on a button, it adds something to the array. Let's do it step by step. First thing, we would like to listen on the add click. So when something is being clicked, let's add some dummy thing to this array just to see how it would look like. So we need to create a new property to our button and we call it onClick. And this would be a method being passed to our button. And we can create our method here. So we can say const on add clicked, and it's a function. And let's define this property inside our button. I will just like first copy paste the method to pass it as one of the properties and then create it inside the button. So we need another property. We call it onClick, and it's basically a function and it returns void because it's just an event handler. And when the button is clicked, we fire this method. So we say onClick and we pass our onClick as one of the properties. And we need, of course, to import, extract it from the props. And this is also an optional prop. And for every element inside the DOM, since, like I said, this is just JSON or representation to JSX, but you have every properties that already exist in the DOM API. So you have onClick, you also have on key down, on key up, on key press, on mouse move, on mouse down, because we are going to use this inside the canvas. So all of these methods already exist inside our element. And you are using this camel case way because this is the same as DOM API. Okay. So what we have done so far, we already created a property inside the button component and we pass it from the outside into the inside, and then when the button is clicked it would fire this method. So how about we write something just to console log it, so we can console log the event and we console.log event, and of course it would complain because it doesn't have the same signature. So we can say okay, it's any for now, and inside on the add click inside the button, let's go to it and define it as any at the moment, just at the moment. We, of course, we are going to use the correct one. Okay, let's refresh. And when we click add, it seems to work, but looks like it is refreshing. And the reason behind this is our form, because the form that we have created, it's also submitting. The default value for a button is submit. So we need to change this one to be of type button, just to keep the default. Because the default is submit, we need to change it to button. And now let's refresh and let's click add. Now the event is fine and it doesn't refresh the whole page. Okay, let's do something nice. Let's do when I add something, like when I click on add, I add something to this array so that we can use our set to dos function. Let's call our to do set to dos and let's replace this one. And set to dos, you could do two things. You could pass the whole new state because you always have to pass a new state or a new value for the whole array. You don't pass a single one because it doesn't know is it an array. Maybe you are passing a string, you're passing a boolean. So you need to pass the whole value and it's going to replace it. And that's where it would find, okay, this is the difference between both of these states. Okay, we need to update like the whole DOM, and then it finds where is the differences and then it changes inside the DOM. So what we can pass to our method, we can first pass the array and pass the current state, like todos, and then we pass new item. This is one way to use the set todos function. By the way, set todos is not a mandatory name. We can use whatever. You could have like set state, set value, like all of this is valid. Okay, so what we have done is we are copying the current state, which is this one, like todos, and we are splitting it inside the array, and then we are passing a new item to our set todos function. And let's try to add. And what it's going to do, it is going to add it inside the current state, and then it is going to be re-rendered again inside the todo items. So let's click on it, and we see a new item being added now. Let's refresh, and it is working. So this is the first way of using set state or set to those in our case. The other way, instead of passing new value, you could pass a function, and this function would give the first property the current state. So you don't need to use this one. And we'll explain why this function is actually a better way to do it. So let's replace it, and it is going to pass to us a function, or we pass to it a function, and it's going to pass to this function the current state. I will just call it the current state, and we can replace it with the other name later. And what you are going to do is you can return the new state. So what you can do is return, and then you could spread the current state because it's the same like the array, and then you could add new to-do item. Okay, and it would do the same exact thing, nothing different. But why this one is better? Because React actually is not setting the state at this exact moment, but rather it is adding it to a queue, and then it is going to apply these changes in this queue. It is not doing it at the moment, but rather it is going to do it later. It's similar like promises, for example. It is going to do it later, but not now. Or also like set timeout. Like best example would be set timeout. So it is going to change the state later, because this is how React is trying to make priority for different changes. So there are certain changes that have higher priority and changes that are low priority. And React tries to manage these priorities. And the main reason behind using function is it would help us to skip closures. So if you only pass the value, it would basically get it from the current function context running. And you could maybe had already set timeouts that would run later, and this one would run after it. And now they both have different states, so it wouldn't be correct. It's a little bit of edge cases that would happen, but you would have unreliable current state if you basically depend on having the correct current state. But with having this arrow function and passing the current state, you are guaranteed that it's going to be the current state, not this one, like not the one that is coming from the context that this function running into, but rather you are guaranteed this is the actual current state after any changes that already was expected to happen. Because also React doesn't fire these methods immediately, but rather it adds it to a queue and then it will start firing them later at another point. So that's why it is more reliable to use functions instead of using like the current state and passing it, and it would become unpredictable. Okay, let's now change current state to maybe like previous to-dos, just to have like better names than current state because it's unclear. Okay, now what we need to do is also listen to changes for text field, and when these changes, like we need to store them inside a state because we cannot store them inside a variable, and then update it and try to manage all of this. No, doesn't how it works, but rather we are going to store when I change text field here, it's going to update a state. So it's going to listen on this function, pass it to set state, and when I click on add state, it would get the value of the state and add it to our array. So let's do it step by step. First thing, we need to have our method here that is going to listen on changes, and we can call it on input. You can name it by the like any name you would like, but I would like to call it on input. And we create our state that is going to store the current value inside this variable to store it. So we can call it task, and the other one is set task, and we are going to use state for this. And we pass the initial value as an empty string. Also, useState can use types, so we can pass it here. Like this one is an array of strings, and the second one, this would be a string. And this is not necessary because this is an initial value, but yeah, it is fine if you would like to pass it. And eventually we need to pass it later in this video. Okay, so we now have set task and task, and what we need to do is when something changes, we pause this change and then set it to our set task. And this would be an event on our input, and it's called onChange. Let's also pass a function just to see how it would look like. So we can console.log, and basically it passes an event, and we console log this event. And let's we need to add something for this. Let's just remove it for now, for the time being. Okay, and when we change, we listen to the event, and basically we need to access the event target, and then we get the value to get the current values that we need. We can pass the whole event back to our container, but rather we can only pass the value. We don't need to pass the whole event. It is unnecessary. And that's why we can pass only the value. So let's first allow our onInput function again. So we would have this function already exists inside the text field. So we need to extract it. And we define our props as well. So TypeScript doesn't complain is equal to onInput as one of the properties, and it's optional. And let's set type any. I know we already have some any's, and we are going to remove them one by one, but just adding this priority first. Okay, and we are going to get this function. And what we are going to do is we are going to create this anonymous function, and we are going to call on input from outside. And what we are going to do is we are going to pass event.target.value. Okay, and we're going to get event from here. Yeah, it's going to be, there's going to be an event. Yeah, this was just auto-completing stuff. It's not necessary. Okay, and we're going to have our own input here. And we can create a function, const on task field changes. And this would be a function. And we're going to set our task. And we're going to get our value from here. And this value is going to be a string. And we just set it to our current task. And we don't need to pass it as a function because it is unnecessary. It doesn't make much sense. Because a function would need the previous and then update it, but this one just always passes the current state. So we just need to replace it as a whole. We don't care much. Okay, and now we passes it. We just need from changed, and pass it to our own input. And let's see. Of course, we need to maybe like console log it. So console.log, and we pass task. Of course, I'm sure it wouldn't get the current state because it would get it from the closure. So you see, like this would be the previous one, and this is actually the current value because set task would run later. So instead of having it inside our function, we could have it, maybe you can print it here to make sure that we already get the current value. So when input changes, it would call this function, call set task, and then React would re-render the whole DOM with the updated current value. So as you can see, it is listening correctly. And we need that when we change the field, we call onClick and then set our task. So instead of like set todos, instead of the constant that we already passed, we replace it with task. So get the current value. Let's refresh, let's write, let's add, and it adds it. And maybe we also would like to remove like this task to make it, to clear it. Okay, so set task as an empty string again, and let's refresh, add, and we see that it is not being replaced. And the reason behind this is that we already changed it, like the state already is passed as is updated to become an empty string, but we didn't pass this updated state back to our field. So we need to pass also the current value back to our field. So we create a new prop, we call it value, and we pass task. And inside text field, we are expecting value as a string, and we extract it from the properties, and we pass it to our field, and it is its value. This is also an HTML, so we're getting it from outside, passing to our input. So we are making sure that we are always rendering the current value, because like you see, it's inside the input. Yes, it looks the current state, but there was a button that already updated the state, and our input didn't get the updated state. And that's why we pass always the current value to our component to make sure it is getting the updated value from the state. So the source of truth is not the input itself, but rather the state from the outside, the one inside React. It is the source of truth. Okay, let's now refresh and let's add. And now we see it is being cleared because React is updating it. Let's now do some cleanup. So instead of having this form like here, in this case, we could create a new component or a new container, but yeah, it's a component container thingy, and we call it add item form. So basically it would hold our form, add an item, and we create add item form. Let's now do some cleanup. So instead of having this form, we can create it inside its own component or its own container. So we have our add item, add task, or add to do item form, if you would like all of these are valid names. Again, this is what React is giving to us. And we define our TSX and also our Sass modules file. Okay, and now let's export const add to do item as a function. And let's extract the code from here. And we are going to return it from the AddTodoItem. Let's also use it. So AddTodoItem. And we can remove our functions and states from all of here. Like we can pause. And we can move our task field change function, and with it also the state for the current task into the AddTodoItem, because this one is needed. And we need a function to fire when on add being clicked. We also are going to take it from here and add it into our TodoItem. Okay, but now we see like todos is actually on the container level, and we are going to be using it. Like we are going to call function to set todos, the state for todos, which are already inside the TodoContainer, but the click button is called on the AddTodoItem itself. It's inside. So in this case, we can create a new property. That's easy. And we can call it on add clicked. And we define our type. AddTodoItem props is equal to this, and we define any for now, and we are going again, promise, we are going to change them. Okay. And we now have add to do. And instead of calling on add clicked, here we're rather going to call whatever the function is being passed to us from the outside on the to-do container. And let's also move the other method. So we need also on task field change. So this is the text field to manage its state when it is changed. And also we move our task state itself and pass it to our add to do item. And let's do our imports just to fix them. Okay. And we also need to, when the add button is being clicked, we need to pass the current value of text field to our to-do state. But you would notice that to-do state on the to-do container, so we cannot like pass it there. So in this case, we could pass a function again and pass it to the to-do container, and it would update our value. So let's create a new property on add to-do item. It's called on add clicked, and we are going to pass it the on add clicked function. And basically when the add button is being clicked, we are going to pass the current task or the updated task. We can just call it task. This is fine. And its value is string, and it's going to add it to our array. And set task is no longer here, but rather it's inside on the add to do item. And let's define our property on add clicked, and let's just say it's any for now. And what we need to do is that when on clicked is added, we need to pass it as a string, like to pass the current value as a string, and of course remove the set task. Okay, so we define a new method called on click add. This is different one. This is like the internal method. And we define it as an arrow function. And when on add clicked, we pass, like we said, the current task. And we also set task to an empty array. And we use this one instead of the old method. Okay, so now everything should be working. Let's refresh. Let's write some stuff. And it is updating as expected. Let's now fix all the inits that we have defined. So add to do item. Let's create type add to do item props, and it expects a function called onClicked, and it would pass a task, and its type is string, and it is expecting to return nothing. And let's use this one here. Let's check also our text field, and on input again, this is also a function, and it is going to like return value as string, and it's expecting it to return nothing. And it says like, because on input could be like an empty function, because we are saying it's an optional. One way we can say, okay, we are going to pass a default function. Like we can do this one, or because text field is always going to return a value because why you are using it. So we would remove this optional part. And yeah, then here we are going to remove it to bmouse event of type HTML button element. And yeah, okay, maybe I defined it incorrectly. So we can mouse event handler. Yes, mouse event handler, and probably we need to import it, and that's it. Okay, now it's fine. Yeah, some of these types already are imported in React, and let's make sure everything is nice. Let's check it out. There is no any keyword that we already used. Okay, now it's nice. Let's git add and git commit, and we can say create add to do form. Okay, let's now speed things up, and we will speak about the third concept in React, and it is called useEffect. And useEffect is used to do side effects for our component. Okay, this is the meaning. Okay, why do we need it actually? Let's say our product manager comes in and say to us, hey, we would see our users already see it's a little bit slower that they go to our text field and they need to input it. I would rather when I refresh, I want this text field to be already focused. And this is the reason why we have useEffect. It's basically to do side effects on our elements. One way to do it, you could already, like if we're using pure JavaScript, you would have maybe listening on the document and have an event listener. And when the whole document is loaded, you would run a function because it's run once and to focus on our input. But instead of doing this, React already gives us a function. It's called useEffect to do these side effects. So let's do it inside our text field and then we are going to abstract it later again. We always find a place to do our demo code, make sure it is working, and then we abstract it to its proper place. So I'm just going to, instead of like returning it an error function, I am going to create a function just to be able to write JavaScript code inside it. And we have our return and we define our useEffect to call the focus. So we say useEffect and we can have an ID on our element and we can say text field task just for now. And inside the body for the useEffect, we already pass an anonymous function and we pass the other second argument. It's an array and it's basically dependencies. These dependencies can be different states that already exist on our application, or it can be an empty array. If it's a state, it means that when this state changes, it would rerun the useEffect again. If we pass it as an empty array, it would rerun once when the component is loaded the first time. So since this component is loaded the first time, we don't need to have like any dependencies to do the focus again. We just like do it once when this component is loaded the first time. So we can do document.get element by ID. And then we have our text field and then we say focus. Okay, let's now refresh and we see it is paying focus now. So useEffect is mainly used to do side effects in our application, either to do DOM manipulation or if you would like to call an external API to get data. These are the two most prominent things. And the other part as well is maybe like integrating with a third-party library. So, but these are the two main things, is to either manipulate the DOM or you have to call an API externally. Okay, now let's speak about the third concept. So we speak about, so far we spoke about props, useState, and useEffect. This is the third. Now we speak the fourth. It is called useRef. So you see that we already define a certain ID for our element here, but like you would probably won't have this only text field. You would have many text fields. So instead of using this ID, we can pass a reference to the DOM element itself. And in React, it is called ref. This is a property. And what you are going to do, you are going to pass it a variable. And then when this DOM element is loaded to the DOM, React would pass the DOM reference back to it. So again, there would be our component being loaded inside our DOM. And then we would have a property, we call it ref. And React, when it loads this component, it would pass this value, which is a reference to the DOM, to a variable that we already have. This variable can be a variable, like a normal variable, or you could have a state, but all of these doesn't work correctly because the DOM, if it's reloaded, you would lose the reference to the DOM. But rather we use something called useRef inside React, and basically it's a value that is going to be consistent across re-renders for our application. So it would be always consistent as long as, of course, the DOM element is not removed. So in this case, yes, you're losing the reference. But as long as the reference is there and the DOM element is there, it would keep this across re-renders. And this is important. So let's now use it. And it's a simple function. We would have const, and we can say it's input field ref. And we can use useRef from React. And we can pass it to our reference inside the input. Oh, we just removed. Okay, so input, we are back again, and we pass the ref property. This is from React. and we pause the useRef that we have defined. Let's save to make sense look better. And then we can use this reference instead of accessing document.id. So let's replace it and we can use it. So input field, and its value, it's under current. And we'll make sure that it is already defined. And we need to define the type as well for our useRef. So HTML input element. And we can say it starts with null value to fix this error as well. Okay. So now everything is working. And if I refresh, now you see it is focused and value, it is not corrected because I'm clicking on enter. Okay, we are going to go through the enter issue. But if I like write some stuff and click add, it is working nicely. Okay, regarding this enter thingy, this happens because if you check back inside our AddTodoItem, we had a form element, and form element default behavior is if there is any input field inside our form and we click enter, it basically it submits this form. So we can, one way to do it is to prevent defaults. So we can have event and then event.prevent default, and this wouldn't happen. But you would notice that when I click enter, it doesn't add. I would like to also have this behavior, like I could write a to do and then press enter. So what we can do is to have, instead of like prevent defaults here, we can call actually like onClick add methods that we defined earlier, and we can remove it from the button, and we can change our button type to become submit. So basically it would submit our form, but in this case it would override every buttons that we have here, and we don't want that. So we can pass it as one of the props, and we can define it type, and it has type of string, and we can pass it from the outside, and it has default value as button, and then we can pass it to our button. And yeah, it needs like different types. Like it's not like every string, but rather it have few types. So we have button and we can have submit. So let's define these. So now the error is disappeared, and let's also define it as an optional value. So it is not required to remove any error. And for our button, for add, we define type to be submit, to submit our form when it is clicked. And when on clicked add, now we can change it to on form submitted. Can change it here, and then we get an event. Let's use any for now, and we can say event.prevent defaults. And now let's check it is working. So if I refresh and enter, still submit. It is prevent default, not defaults. Okay, let's refresh and enter. So enter is working. I promise I'm pressing enter. And also let's try add. So add also, it is working because add would submit our form as well. And let's now do few cleanups. So for event, it would be of type form event, not the event itself, but rather the form submit function. It is of type form event handler, and we pass the type of HTML form element. Okay, so now this one is working, and let's get back to our focus inside the text field, because like we said, we don't want to keep it here, but rather we would like to be able to reuse it. So what we need to do is to be able to extract it from outside our text field and pass it from the outside. So it's saying, okay, maybe we could pass it as a prop, but ref is a special one. We don't pass it inside the prop, but rather it is passed as a second argument, and it is passed as like I said, like a second argument. And to be able to pass it as well, you need to encapsulate the whole component into another function. It's called forwardRef. So what we are going to do, let's first keep our code somewhere here just to not lose it. And I'm just going to comment it. And we are going to encapsulate the whole component into forwardRef to be able to pass it from the outside into our component. And we can use ref here directly. And now we need to also define it. And this would be inside our forwardRef to basically define the type. So we can define the first, what is this type of our ref? So it's an HTML input element. And the second one would be the value for our props. So we just copy them. And in this case, we can remove all of this. Okay. Now we can use this ref from outside inside our AddTodoItem. And we now have access to a property called ref. So we create it. And then we define our focus on the AddTodoItem. Let's paste our code and uncomment it and pass it to our ref. And then call our methods or import them. And let's make sure everything is working and still works. Okay, now let's get to the second, get to another concept that is called custom hooks. And custom hooks basically is just to extract multiple hooks or multiple functionalities and put it in a single function and return whatever is required to do this functionality. This is the idea of custom hooks. You're just getting a couple of hooks and putting them in their own function just to be able to reuse them elsewhere. Because yeah, in our case, this would be the only element we need to focus, but maybe I would like to focus first on edit or stats or whatever. So in this case, we can reuse this functionality elsewhere. So we can use this and define it in a separate function. So we can call const, and all custom hooks are starts with use word. It is not, by the way, again, it is not required, but it is always the recommended behavior. And if you are using prettier, it would complain because it's a custom hook. So it would tell you, hey, please start with use. So we can say its name is use auto focus. We can define it as a function. And we need to return something. And what we need to return is our input ref to be able to use it here inside our element again. So we can call our use focus here. So we can const input field ref, and we'll call our use focus, and we need to return it here. This is just like making things a little bit cleaner. Okay, let's check it. Still works. And finally, we can move to its own separate file. So we can create another directory under source, and we can call it custom hooks, and we can have use autofocus.tx. TS, not tx. Okay, let's cut and paste. So export our function. Let's do our imports. Okay, and we can import it here. Okay, looking nice. Let's remove all of this that is not used. Let's refresh, and it is still working. Let's do some renames. So for use focus, because it's called input field, yeah, we can just call it input or element ref, because it can be any DOM element to be able to focus on it. Okay. And since for this use effect, maybe the element could be changed, so we can add it as one of the dependencies. This is not required, but it helps just in case the element is unmounted and so on. It is not this one, but rather, yeah, this would be the correct one. Okay, you can use this ref. So basically, to be one of the dependencies, if this element is unmounted and so on, it would rerun the useEffect again. Okay, let's now commit. So git add, git commit, we can say some refactoring, and create custom hook. Let's now replace our array of to-dos with a call to a backend server, because eventually we don't have like this array, but rather we are going to have a server and call to it and add to-dos, get to-dos, delete to-dos, edit to-dos, everything. So I'm going to create a server, and since this is not a Node.js course, I'm just going to copy paste it and I'm going to explain it. So I'm going to create a directory at the top level and I call it server, and I'm going to create a file called server.js, and I am going to copy my code from here. And we need, of course, to make sure that we install Express if you don't have it. So npm install Express to make sure that we have it, and also we need to install course. So npm install course. And let's get through explaining each part. So at first, you would see here we are just importing different Node.js files, and then we start creating an Express.js server. And we define that we need to use course because eventually the backend and frontend are not on the same domain and port at the same time. So we are using course. And then we define that we are going to use JSON for our application. And then we import list of already database to-dos JSON file, and I'm also going to copy it and create it. So it would be also on the same level as server, and I call it dp.json. dp.json. And I'm going to have, it's like simulating our database instead of like having MySQL and SQL and so on. So I'm just simulating it, and here I am importing our file and defining, okay, this is our database, and then I'm starting to define the different endpoints that we are going to have. So let's get through them as well. So the first endpoint, we are going to have an endpoint to get different to-dos, and we already defined some filtering on it because we already have some buttons to define if a to-do is true or if it's false to filter them, and we are going to implement this filtering later. And then we are returning these to-dos. And we also have another one to get a single to-do. So in this case, we are trying to do an edit. And there is another one when we would like to create to do as well, and another one when we would like to edit to do, and we send an ID for it, and we send the object to override and patch it, and the other one is just adding to our array and returning it, and the last one is to delete it. And lastly, we define, okay, we would like to start our server, and when we like control C to end the server, we just like exit the process. It's like something related to Node.js. So it's just a simple backend server to create, add, delete, edit, and post, and all other endpoints that we need. And what we need now to do is to start our server, and I'm just going to define another Node.js like script, and I'm going to name it start server, just for us to be able to start it directly. And then we call nodemon. We need to also to install nodemon because it would help us if we would like to do edits to Node.js file. It would be easy to restart it. So npm install dash dash save dev and then nodemon. And while it is installing, we just also call our server and server.js. And we can create another terminal to start it. So npm run start server. It would take a while. Okay, now it started, and let's check it. It would run under localhost 3001, and we can check the to-dos endpoint. And probably I set it to go to another file. I just need to remove like this extra dot to be in the same directory, and let's rerun it again. And now it should start, and it is working. So now we get our list of to-dos, and we should be able to replace our to-do array with it now. So let's go to our container, to-do container, and we are going to replace it. So to replace it, we are going to use useEffect. because we would like to run a side effect when we start when we start mounting this component at the first time. So we need also to define it as an empty array, and we are going to do side effect beside it. Some would say, okay, why not we just call fetch here directly? It wouldn't work, because in this case, every time when React re-renders, it would call the API again, but we need to only call it once when our application starts. So let's call our API and replace fetch, and we call our endpoint. So I'm going to copy and paste it, and we then call .then, and we get our response, and then return response.json to parse it for our UI, and then we call a then again. Let's put these on 2 lines, and we finally can set our state using our to-dos that we get in the array. So before even we can set it, because it would have different type, because this one is used to be a string, but the ones that we are getting from the endpoint would have different data inside it. So we have ID, we have task, description, head notes, and is done. So let's first console log it to make sure that we are calling the API correctly. So console log it, and let's go to our application, and when we refresh, we can see our to-dos. So what we need now is to call setTodos on it. So we are going to do some changes. First thing, we are going to define our state before this one, just to have an access to our function to set to-dos. We are going to replace this one with an empty array. And now we are not going to get an array of strings, but rather an array of to-dos. So we need to define our to-dos model, or to-do type, or class, whatever you would like to call it. Again, this is how flexibility React helps us. So we can create a new directory on the top under source, and we call it models, and we can define inside it our to-do model. So we can say todo.tos, and I'm going to copy and paste it. So we define it's a type of to-do, and it has description of string, hand notes, it's a string, and this would be the handwriting that we are going to implement at the end with not at the end, but after a while with the canvas. And then we define the ID, task, string, and is done is a boolean. And now we can use it for our set state. So we can say to do an array of to-dos. Let's also remove all of these unnecessary stuff. And now we can set to-dos as to-dos. And when we fetch it, we can define it as type of to-do array, just also to say that it's the same type. Okay, now we will start getting few errors because TodoItem is expecting a string. Now we need to replace it to expect a to-do. So let's also close the others just to make things easier to open files. And we'll go to our TodoItem and replace to-do string to become it's a type to-do. And we import it from model. And we can start showing the correct one for our task name. So we are todo.task, and it should be working. And also when we fire a task for add to do, let's go to our add to do item. It's of type string. Okay, this one we will do later. And for add item, we will do it later because it is adding to like another state. So we can just add the moment. Let's comment it, just to keep things simple, and let's refresh. And now this array from to-dos, we are getting it from the backend. So now we are able to fetch it. Let's also do another effect not another effect, but another call to add to-dos. So let's uncomment this. And instead of setting to-do inside our state, our source of truth of our data is the backend. So we first need to send the to-do to the backend, and the backend would attach it to our list, and then we can refetch it again. Some libraries would do it in a better, smarter way, like it would have something called optimistic like optimistic API call. So basically it would say, okay, it would probably succeed. So I'm just going to attach it to the state and show it. If it fails, I would remove it from the state and show an error. So there are multiple ways to handle it in the API. But for our simplicity here, we are just going to send it and then refetch it. So we can copy our endpoint call and we are going to change it to post because this is now a different method. So we can define method is type post, and then we can define our body. So it would be our payload. And we say it's JSON dot stringify because we need to stringify our body itself, or maybe also we can, we will stringify it, and let's check how it is expected from the server. So when we are posting a new to-do, we're expecting inside the body there is a property called to-do, and it would have our new task. So we say to-do, and then we get our task here to send it. And after it finishes, we might not need the response at the moment, but we rather need to refetch again our to-dos to be able to show it in our array. So we can use the same function here, but it's not good. So we can define it inside a const, and we say fetch to-dos, and we can reuse this function again. Okay, so we define our fetch here, and we can also return the promise. So if we would like to await on it, it would be possible. Also, like at the moment we don't need, and we can define fetch to-dos here as well when we add our to-do. So let's refresh and let's try. So let's call subscribe to the channel and let's enter. Okay, it is not showing, so probably we are missing something. We sent something incorrect. And probably we need also to define our headers as well to say it's of type JSON, so Express can understand it. So we also define content type application-JSON, and let's refresh and let's try to do again. Subscribe to the channel, and now it is working. So it is now sending it correctly. So please subscribe to the channel so you could receive like new videos in the future. Okay, let's get back to it. So we now are able to fetch, and we're able also to add. How about also we do our delete? So we can define on our every to-do item, there will be an event that we call, which is called on delete clicked, and we can call it from the outside similar to on add clicked. But the idea behind why we add it internally here, because we are able to listen to different to be able to get the ID of the to-do when delete is clicked per each item, so it would become easier. So let's also implement it inside our to-do item, and we can say on to-do clicked, and what we're expecting an ID. We're expecting to send an ID, and we don't expect something to be returned. And we can define it here when we click on the trash one. So we can define on click, and we will get a function, and we can define on delete clicked, and we send our to-do ID, which we get from the outside as well. So to-do ID. So when clicked, we call our on delete clicked that we get from the outside and pass it like to the outside. That's the simplest as it can get. And we need to get it from the props as well, extract it from the props. Okay, and we can create our function. So we can say on delete clicked, and we can create our function here on delete clicked, and we are expecting, we can call it even here to do ID. This both are fine, the type. And we can call fetch again. By the way, like fetch is not fetching, but rather it is a fetch API, as simple as this one. Okay, and let's check what we need to, how we need to delete. So we need to send an ID. So we can define it's the ID, and it's our to do ID, and we eventually fetch again after we delete. So let's delete this incorrect task, and it is fine, and now it is deleted, and when we refresh, everything is working nicely. So we can add the last task like the video. Okay, so this is our task, and now we need to move these functions away from our container, because eventually like these API calls are going to be reused again when we would like to do like edits and so on, or we would like to do other API calls. So instead of having them inside a container, we need to abstract them to their own separate file. And this type of file is called services. So far in the front-end architecture, we understood components, which is a small component, like it's just a small representation, and we have a container that contains different logical parts. And now the third concept, which is a service. And a service is used to integrate with a third party libraries. One of them is the API call. Like for example, if you would like to integrate with, I don't know, like charts, we can call it chart service. Or you would like to integrate with 3JS to do some 3JS with JSX, we call it also 3JS service. But for our case here, it's an HTTP. We are integrating with the HTTP API of our browser or our DOM. So we call it service, and this is integrating with external party things. So this is the third concept inside our front-end architecture. This is not related to React, but rather we also would describe like this front-end architecture inside our video as well. So let's create a new directory, and we call it services, and we define inside it our todo.service.ts. And we can export them as various functions, but I prefer to export them as class, because eventually it would help us when we do dependency injection, which we are going to describe later in this video. No, not later again, also like in a few moments, we'll describe the concept of dependency injection. So when we have it as a class, it makes it easy to inject them inside our components. If you don't know what dependency injection is, don't worry, we are going also to explain it in details. So we can export it as a class, like we said, and we can call export class to do service, and we can define our various functions inside it. So we have get all to dos, and we have also add to do, and we have delete to do. For now, we can do the others later. Okay, and what we are going to do, we're just going to abstract the API call. So we can copy and paste. This is to do our fetching, and we then return it. And the other one is going to do our add call. So we are going also to copy it and paste it. And the last one to delete as well. So we copy it and we return it. And let's now also make it more generic regarding this part. So what we also, like the last add to do, also need JSON. So we return JSON and we return JSON here. And then we are going to do something incorrect, and later we are going to fix it, where we are going to just create our new to-do service here. Later we are going to replace it. Okay, so we now create it, and instead of calling fetch, we can to do service get all to-dos, just to fetch, and then we return our to-dos, and we can do it as well for on add to do, and for delete to do. And you will notice that we need also to pass variables, so we know which to do to delete. So we need to pass to do let's first the first one. For add to do, we need to pass the task, and in this case add to do is expecting a task of type string, and this would be the task to be sent. And for delete also expecting an ID of type number. And we pass this one to do ID to our delete. Let's now check. So probably we have missed something. Yes, it is not ID, but to do ID. Okay, let's now refresh. Let's try to delete. So we already published and we edited and get 1 million subs. Okay, so now add and delete works and get as well. And as you can see, using services makes it cleaner to abstract. Like, for example, we have the body, stringify, and header. We need to define like these different things, and then we need to do the JSON. But eventually, our Todo container doesn't need to care about all of this. It just needs to, okay, I would like to call our Todo service and add the to, and that's it. I don't need to care about what headers, what API call, whatever you would like to do your thing. I don't care. So this is useful of having things abstracted from each other. But you will also notice that Todo service is probably not going to be the only service in our system. We might have like other services. We might have another service to go to get our user, another service to get user authentication, another service to get user contacts, another one to get app settings. So all of these are different services. So we need also to abstract more. We need to abstract the HTTP client itself, not just the service. So the service would abstract which to do. We need to edit inside the body, maybe like different types and so on. But we need also to abstract our HTTP client, and this abstraction is called adapters. So to edit a little the concept that we have defined in our previous explanation for services, we need also to explain more details. So we already have our component, maybe, or not our component, but in our case, we would have our container, and it is calling a service. And this service would eventually call an adapter. So adapter is similar to what you think of adapter, like your socket or electric socket. It tries to translate from one format to another format. This is called the adapter pattern in design patterns. And the idea is that it tries to translate from one format to the other format. This format is coming from the service, which would send, okay, I would just need to send the ID. I would just need to send the ID, and maybe I need to send a task in a certain format inside the HTTP body in a certain way. But the adapter would translate, okay, you need to call my http.post. I am using the modern fetch API, so I'm going to translate it from what what is the payload you would like to send and these different formats, and then I will translate it to my fetch API. Maybe for some reason you need to use XML. So what you need to do eventually would go to the adapter and just change it. While you might have multiple services, because like we said, you could have one for your to-do, another one for user, another one for authentication, and so on. So all of these, instead of going in everyone and it's changing the HTTP server or the HTTP client that we're using, which is the fetch API, we just need to replace it in one place, which is inside the adapter. And in this case, it would be a simple replacement. So it's more of abstraction as well, abstracting the HTTP client on its own. Of course, like abstraction could get very deep, but sometimes it's unnecessary. But for this structure, it makes sense. You would have one for container and one for your service and another one for adapting to these to HTTP client. And last one here, we have different components. Yeah, I'm writing like a doctor. Okay, anyway, so let's get back to our code. And we need to create now the other level, which we call adapters. And we create our HTTP client. You can call it also HttpAdapter. It's all the same. So maybe also we can rename it to HttpAdapter. So HttpAdapter. And we can also export it as a class. And we have HttpAdapter. And we can then have the different functionalities. You can now think it doesn't know task or doesn't know any to-dos or users or whatever. It's just integrating to the API structure for our DOM or browser itself, like the normal fetch API. It's trying to integrate to it, this one. So what we need to do is just to copy these things. So we can we have the first one, which is doing get, and we can return our fetch, and we need to abstract the main base URL because it would be agnostic. It doesn't know which server you would like to call. So we can create our constructor, and we need to pass to it our base URL, and then we set it. So this dot base URL is equal to base URL, and we need to define it, and we can define it. It's of type private read only base URL, and then we need also to define the type inside the constructor. So I could just define it here. Base URL is of type string, like an inline definition, and it would be fine because eventually it is only defined here. Okay, and now we can use our variable. This would be the base URL for our backend. And since it doesn't know todos, so we also need to pass URL. So we can define it. It's of type string. And we can replace this one to become URL. You can define it also endpoint. It would be fine as well. So now we have one for get. We need also to define another one for post and another one for delete. And both of them also get the URL. But the difference for post, it would now abstract the concept of headers and body. So all of this is now abstracted internally. So let's add them inside our post. And we are expecting to send body or content. Both of them are fine. Or we can define it as well, data. And now it's a generic, so it's of type T. And we can pass the type here inside the function. So it would be generic. It doesn't know which data type you would like to pass. And then we can replace it here inside our body itself. And now we have our post. Let's also do our delete as well. So we're going to return it. And we need also to pass our data. And it's of type generic T. And we define T here as well. So now it should be possible. So let's use it inside our service here. And let's create our constructor. And again, we are going to replace the new keywords that we are going to define it here with the correct implementation in the dependency injection section, but we are going to explain it later. But just I'm going to add it here. So we define new HTTP adapter, and we need to pass our base URL. So we copy and paste. Okay. And yeah, HTTP. And we can define it as private read only HTTP adapter. And we can start, oh yeah, it wasn't passed as string like this, but rather inside JSON base URL. And we can now start using it. So instead of our fetch call directly, we would have our this dot get, and we have our todos. This is the first one, and then also for our post and delete. So let's set it for post. I'm just going to copy here because it would make things easier. I'm going to copy our to-do task, and let's remove all of this. And we need to pass the type. It's of type to do, and then instead of get, because this is add, so we need to call post. And I think I made something incorrect because it is not of type like the body itself that we are going to pass inside the adapter. This is data, not the to do. This is the thing that needs to return to do, but rather we need only to set the body itself. So it's of to do, and it's type string, just an inline one. We could also set the return like in another generic, but it is not needed for the time being. Okay, so this one is for setting, and let's make one as well for our delete. So I'm going to also instead of like this one, and just to create another return, and this dot http dot delete, and we need to call our endpoint to delete our to-dos, and we need to send inside the body the ID, and we set the type for it, so it's in line as well. Of course, you can create like types for them, but it's unnecessary for something simple like this. I'm just like would like to show to you like something simple. It doesn't need to be overcomplicated. Okay. So we now get to those, and we can also define type for get. So we can say we need to make it generic of type T, and we can say the function itself would return promise, and it has data type T, and we can use it inside our get. We say it returns todo array. So now it should be working. Let's check why it is not. Oh yes, because the .json doesn't exist on our level on service, we need also to remove these into the adapter because they are not necessary for our service. They are only for fetching. So we can remove all of this and define it in our adapter. So we already have it in adapters, yeah. So we just needed to remove it. Okay, so now get it is working. Let's check. Okay, this one is not working for delete. And the problem is that we forgot to pass the method type as well. So we have method for post, it is of type post. And for delete, it is of type delete. You see, like, even with 100% preparation, there is always bugs and errors. So let's delete. Okay, now delete is working. And let's try add new video, and it is working. So now we have done more cleanup, and we can use our HTTP client elsewhere with new services, and we can abstract our services to be outside of our container. So let's maybe like delete this now, all to those, because it's unnecessary. And let's get add and commit our changes so far. So let's get add and get commit. By the way, if you would like to get a get course, there is also a link for a get course. You can see it here. You can check it out. I have like a lot of advanced things in get and also like understanding different commands of get. Okay, so get commit, use todo service, and implement HttpAdapter. Okay, let's now explain the concept of dependency injection. So before understanding why we like what it is, let's understand why we need it. So you would see here inside the TodoContainer, we define our new to-do service, and inside our new to-do service, we define our dependency on our HTTP adapter as well, like here. And we have now a to-do container, but again, we are going to have multiple containers. So maybe we are going to have our edit to-do container. So it would also need, and like it would need also dependency, or it needs to-do service to send our updated to-do. We need maybe another one to get like stats. So we need another endpoint to get our to-dos. So we need again another to-do service. So now we need it in 3 places. If we are using the new keyword, we now started 3 dependencies, like 3 classes or 3 objects, and each one of them also depend on HTTP adapter. So it's going to also create 3 again. So we now have 6 objects while we only needed 2. We just needed to call these methods. And this is why we use dependency injection. Instead of having objects and multiple, like one of the uses, of course it has multiple uses, but one of the uses is that instead of having the object created multiple times, we created only once and then reuse it. So this is the idea of injecting it. And instead of creating it, like instead of dependency creation, we are dependency injecting it. And we basically create it from the outside in an object, for example, or a dictionary or whatever you would like to create it into it. And then every container or component would say, please send me this dependency, I need it, and then it would create it for us. This concept is already implemented internally inside Angular. You don't need to re-implement it because it's already implemented there. But in case of React and also in Vue.js, they are not implemented. You have to implement them manually when you need to use them. And of course, you would need to use them. This is why it's makes the code cleaner and easier. And also, dependency injection is very helpful when we are writing unit tests. So there would be another video about unit testing, and I'm going to explain how to use it. But we are going to use this method of dependency injection to inject these things inside our components so we can mock it from the outside when we are doing tests. And this is the whole concept behind dependency injection. And it consists of few parts, which are, the first one is our dependency container. So we have here dependency container, and this would hold the different objects. So it would have our Todo service and our HTTP client, and it could have also other services as well. So it could have, maybe you would need like user service if we need to use it, and so on. So all of these dependencies that are injected inside a container, they are stored here. So we just define them. And this is defined in the dependency container. We can also name it only container. This is fine as well. And then we need our injecting method. And this is going to use our higher order component. And we are going to explain what is higher order component is. But in essence, what higher component are doing is just they are injecting something into our container. We would like to add something internally to it. So we would have our container element from the outside, and we would like to inject these dependencies into the container. So we're just passing it to it. And it's simple as just adding extra props. We just return component or a new anonymous component, and we just insert or inject these things as props. And that's summary of it. Like, this is as simple as what is dependency injection is doing inside React and how it is implemented. We create new objects, and then we get our container. We create it as an element. So we have our TodoContainer, and then we return it as a new anonymous component, like using the anonymous function. We can define it with a name. It is fine. You would see it inside the code when we start implementing it. So we just pass it as one of the props. So we could pass like our Todo service, whatever services we need to it. So we need to define in a place what are the keys that we would like to inject to our container, and we are going to use our HOC or our higher order component to inject it. So we are now going to explain two concepts: higher order components and also dependency injection. Let's now get to the code and start implementing it. So before we continue, I will just remove the new keyword for our to-do service. Instead of it creating our HTTP adapter, I would handle it to our to-do container to implement this part. We are going to abstract things step by step just to make things clear how we are doing it one by one. So to-do service would say I would need, as a service, I require a dependency. And this dependency would have the name HttpAdapter, and we define the type of it as HttpAdapter. This name is not necessary. We can define it as HTTP only. It is fine. But I would rather, instead of defining it as an object, I would define it directly inside the function to make sure that it is in this place. I would like you to pass my HttpAdapter. You could make it as like a dictionary, but it is fine. I would like just to keep it here. And instead of us using the new keyword, we just pass it from the outside. So we now Todo service would get it from the outside. So TodoContainer would need to define it here. So we can define our const HTTP adapter, and we can use our component and define it here. And let's make sure we imported it. Okay. And now we can pass it to our Todo service. And what we need to do is to pass to-do service into the container. So we can remove this to the outside. So TodoContainer doesn't need to care about creating this to-do service and its dependency, which is HTTP client. So we can say it is going to get it from the outside, and we can define it as to-do service, and it is of type to-do service. And we can define it inside the prop. Like I said, it's just passing it from the props from the outside. So we can define the type, props, and we can say it's to-do service. Yeah, we don't need the definition here. Okay, we define the definition here inside the type. Okay, and we can start using it because it would say just there is a duplicate. So yeah, we don't need even to change the name because it's the same name. Okay, so now we defined how we are going to use it, how we are going to implement it. Let's get back to our let's get back to our app where we already defined our to-do container, and it is basically saying, okay, I would like to get a to-do service here, and you can define it on this level, and we can reuse it and everything would be fine. But we need to abstract it from here into our higher order component. Basically, we are defining it similar to our custom hooks to be able to reuse it elsewhere if we have with dependencies as well. Like we are going to use it again with the stats to have to-do service. So instead of creating also another container and we need to define them here, we can abstract them into another separate entity, which we call it higher order components. So it is as simple as creating first. We are going to create it as a component, and then we are going to abstract it to its own method. So first part, we can say we are going to create a to-do container, but we call it with dependency of to-do service. I'm just writing a long name now, but I'm going to make sure it is smaller. Okay, and it is just going to be a normal React component. And what we are going to do is we are going to return our to-do container, and we are going to have our to-do service, and we can then define it on the top level here. Not top level, but from the outside, before like using it. And we can import our files to make sure everything is working. And we can then pass it here. And we can use our container now independent, like they are now separated, one into the function and one into where we are going to use it. And this is basically hidden. And everything is working nicely. Let's now do more abstractions. So TodoContainer, we don't have it here. We don't want to have it here because we could have multiple components that we need to inject our to-do service to it. So we can, instead of expecting, instead of having it inside the name, we can expect to pass it as one of our parameters. And we can say we pass a component, and we can use it here to define it. And this is possible. You can take any component from outside and then define it. And we can have our const to-do container with to-do service now is equal to with dependencies. And we need to pass our to-do container to it. But we are now passing, like, if you think about it, what we are doing here, we are calling our with dependencies. So we're creating the component, and then we would like to run the function again. It is basically as if we would like when we are doing something like this, it is as if we at first create element. Remember the first part, we are creating the element, and then we're rerunning again. So it doesn't work. You cannot rerun the functions twice. So what we can do is just, instead of creating the component, we would return an anonymous component. This is as if you are creating it in a const and then returning it. But by writing it this way, we can get our HttpAdapter and Todo service, or basically our Todo service, using closure, using this arrow function. And this is the concept behind it. This is the whole higher order component. You're just creating a component that you are going to create different props, and then return a new component. This is similar to, like, if you check it out, it is similar to exactly when we are defining this function. It is exactly the same. And this is higher order component. We are just creating a component that is going to return another component. And then we can call it or define it wherever we would like to do. Okay, so now we created our higher order component that is going to inject our to-do service. But of course, we don't want to keep it here. So we are going to keep it inside TodoContainer because it's the one that is going to create its own dependencies. Or basically, at first, it is going to create it now, but then with dependencies going to implement the whole injection and declaration and so on. And this is one of the advanced concepts in React. So it's a little bit of advanced concept. So how we are going to do this dependencies, we can implement it inside our to-do container, but yeah, it would just clutter it because this file just cares about defining the different API calls, fetching and so on. So we can define it inside an intermediate file and we can have it inside our index.ts. You can have another file called it containers or whatever you would like to call. All of this is fine, but it's just how I like to implement it. So what we need to eventually do is to export as default our higher order component. Let's go our app here. And we can just, yeah, let's copy the first part. And we can export it as like this. It is fine, like export const and then reuse it. But when you have it as default, you can reuse it elsewhere if you need to, not use it elsewhere, but rather you can rename it as if you can rename it whatever name you would like to do. This is the usefulness of having export default. You can have it with whatever name you like, but for our case, the top level components we can use default, and also it would help us when we need to do code splitting later. Okay, so let's just put our index here and put our app here, and we can export default with dependencies, this function, and we can then also move our definition from here, move it here, and we can export this one, export default our to-do container with dependencies on on service, and we can import our container. Let's import our adapter and our service, and we need also to change the name from tx to have tx because we are using also JSX. Eventually we are going to remove this and only have ts. Okay, and now we are importing our default, so we can import it directly, and we are importing the index, so we can import from the top level, and we can reuse it instead of this whole long name. Okay, yes, and we can remove this one as well, and we can clean this. Yeah, like too many deleting. And our to-do service, it is fine, and TodoContainer, we can delete this as well. So now in summary, what we have done, let's just check that everything is working. Yeah, everything is working nicely, and delete is working nicely. Okay, so you see like it's more cleaner. You have TodoContainer, like inside the app file, it just reads I am a TodoContainer, and we're just renaming it. It is internally, it has the with other dependencies that we need to inject. But here we can see it, it's the only TodoContainer. When I go to it, sometimes, yeah, let's go to, also let's remove this. This will be fine. And when we go to our file, we have our with dependencies to do, which is a higher order component. And what it's going to do, it is going to create the adapter, to do service, return an anonymous component or React component, and is going to inject the to-do service. And then it is going to create it and then export it. And this is a dependency injection. But what we need to do now is to make it more even generic. Okay, let's do one last cleanup as well before we can continue. So I'm just going to remove this intermediate naming because it is not needed, and we can directly export our with dependencies. And our aim now is to make with dependencies more generic, because we could have multiple dependencies and each container could have its own dependencies that it needs. For our case in TodoContainer, it needs to do service. Maybe we would have our title bar, it has a user, and then we need to inject our user service or authentication service. So we could have multiple different services, and each container could require different dependencies that it needs. And in this case, what we need to do is just to make this more generic. So before we can continue, I just need also to explain one last concept in React, and it is called property spreading. And property spreading is similar to function. You can create an object and you can spread its values to our component. So we can create our const props and we can define it as an object, and it would have the name of the props that we need to pass, which is TodoService, and then the name of the value or the object that we need to pass, or the prop value basically, and we can then spread it. I needed to explain this concept earlier, but yeah, it's the same thing. We can spread it similar to our function, but it's important to understand in our dependency. Okay, so what we need to do is to make this generic, and to make it generic, we need our file like here in index. It would say, okay, I would need to do service. I don't care how you create it. Like to do service here needs dependency on HttpAdapter. It maybe need another sort of dependency, but just provide me to my prop, like the props that we already passing here. Please give to me something called to do service, like define to me our to do service. So as an implementation, or how we are going to use it, we just need to pass an object like similar to this prop thingy. And we can say, okay, my prop is called to do service, and please give to me something for you from your dependency container or dependency injection container called to do service. And to do service, like this whole name, or like maybe this one, to do service, it's a name inside our container which stores the different dependencies. It's just created once, and then our with dependency is going to extract it because our TodoContainer is requiring it. For just this moment, I'm just, instead of having like to do service with capital T, I'm just going to name it DI, but eventually we are going to have a better naming. Okay, just now let's rename it from with dependency, from with to do like with dependency of to do service to become with dependencies, and now it requires a property called dependencies. And let's type any, because this was going to be a little bit of a complex TypeScript, so just for now to care about how this is implemented, and then use it. And then we need our dependency container, which would hold, we need our dependency container, which is going to hold all the dependencies in our system. So if you remember from the picture, we have our dependency container would hold these different dependencies, and then the container would say, hey, give to me like to do service. So our dependency container is going to hold it, and then our HOC, like the higher order component, which is with dependency, is going to extract them and then inject them to our container. So let's create our const container, which is going to hold all the dependencies, and it's easy as just a normal dictionary. And it would have just key value to our name and then the actual implementation to the to-do service. So let's extract our declarations. So we can define them from the outside. And we can then say, if you would like to get DI to do service, I am going to pass to you my to do service, this implementation. And then inside the with dependency, it doesn't, like, it's more agnostic now. And it would say, okay, whatever keys you would pass inside this props, I am going to pass the actual implementation. So what we need to do, because this would be an empty object, now what we need to do is to get the different keys and then replace them inside my props. So we can do object.keys and we can loop through them. So we have our dependencies and we get our keys, the name of the props, and from them we can get the values and then replace them from the container. So it's simple JavaScript stuff. So we can loop through it with for each, and we can name it dependency key, or not dependency key. We can say like prop name. This is the name of the prop that we need to pass inside our container. And honest dependency key. This is the things that we get from our dictionary. This would be the dependency key. And it would be coming from our dependencies, prop name. Yeah, all of this is just basic JavaScript. And we then need to replace it with the actual implementation. Dependency. And this we get from our container. And we pass dependency key. Now we're able to get our dependency. And let's use also here another any just to remove this error. And now we have our real dependency. And what we need to do is inside the prop, we need to define our prop name. And it's equal to our real implementation. And also let as any for now here. And let's check. And it is working. Yeah. It's a little bit of a complex stuff, but it makes definition and reusing easier. It makes developer experience more easier. And this is an advanced course, so yeah, this should be on the levels that we are doing. So again, in summary, what we have done is that we have our with dependency as a higher order component, and it is basically returning a new anonymous component. We have our props, we can spread them, and we can pass the different dependencies that we need, and we can inject them in every property that we are requiring. And our component, which is TodoContainer on the index level, would say, okay, I have a prop called TodoService. Please give to me my DI TodoService from your container. And with dependencies would go to its pool of dependencies, which were defined before earlier, and then would start inject them inside our component. And this is a summary for it. So let's now do the cleanup part, because yeah, it's a little bit of ugly here. Okay, so let's do them step by step. The first part, which I like to do, is to create a file. I call it dependencies, and basically I define this container inside it, just to be on the top level and be able to see it. So we have dependencies.ts, and I can extract this part for our containers and paste it here. And I can import my different dependencies. And in this case, my file or this file only cares about defining dependencies. It doesn't do anything else. And we can, after we define it, we can export it. And we can have, yeah, let's have a small name. And export shouldn't be here, but rather on this level. Okay, so we first get our dependencies. Now we create our higher order component directly. We call it HOC. And we have the first one, which is with dependencies.ts. Okay, or tsx, because we are going to define our component. And let's go to our index and let's extract this part as well. And let's add it here and then export it. And I like when we have higher order component, instead of like having a capital letter, I prefer to have a small letter, the first one. And let's import our container from dependencies. And let's go back to our index. And instead of having with like this, we're going to have it with small letter, and let's import it. Let's clean our services. And now we see it is more cleaner. So there is a file to define the dependencies, another one to define how we are going to inject it, and the other last file, which is inside our dependencies, is going to define how we are going to start, how we are going to define these dependencies. And then the last one is the TodoContainer is going to reuse it. Okay, let's close all these files, because we don't need them. And let's do more cleanup, make sure everything is working. Okay, now let's do more cleanup. So first one, which is we would like to rename this DI to do service because it's a string. You could need to copy and paste it everywhere, but one day you might need to rename it. So there is one way of trying to search for every naming for it and then start renaming them, but it would take a huge time, a lot of errors. So instead of having them as string, here we can use a reference. So we can define them inside our dependencies, and instead of exporting the whole instead of exporting the container, we can also export our dependencies. So basically it would be just key value to these names, dependencies. And we can say if you need to do service, like to do service, you can use di service, and then instead of using it like a string, we can just import it, dependencies, and then we have our to-do service. So this is the first cleanup. Another one is instead of using them as strings, because you might have a micro front-end architecture and each one has their names, dependencies, might collision. You have one big container. You can use symbols, and symbols would be a more cleaner way of doing it, and to start reference these things to each part. So instead of having it like this, we can define symbol. And if you don't know symbol, it's just you can pass a value to it and it would be completely unique. Even if you pass it again to symbols with with the same name, they are not equal. It's something unique. It's a complete unique name for it. If you don't know, you can request it inside the comment and I could create a video for it, but it's a simple one. So we have it here, and then we can say if you need dependencies, you can use this one. So let's replace it, and we can replace it here. But yeah, this looks weird and I don't like it. You're just using the key for the object as reference for this one, but yeah, it's not great. We need to just switch them. So this was the first of the name of the dependency, and this was the actual implementation. But as you can see, this doesn't look good. So instead of having it like this with an accessor and then also inside our dependencies, we have it also accessing it like this. We could have a defined API for our container. So to define an API, we need to create a class and define the two APIs. The one to add a dependency and the other one is to get a dependency. So we have our dependency container class, and we can define our two methods. There is one for add, there is one to extract it, and we define an internal property to store our dependencies. Okay. And for adding, we need two things. We need our key, and it's of type symbol. Make sure you write it under like underscore like this, because the uppercase is not the uppercase. The one was, yeah, like with uppercase S is a different one. We need this dependencies like this, and we then define our dependency. And it would be of type generic T, and then when we add, we define this type. Okay, and then for dependencies, it starts with an empty object, and we start to add it. So we can add it like this, but because if you add it like this, TypeScript would complain because it would say it's an implicit any, and you can't have an like you need to define the different properties and types of them for your dependencies object, but you don't know because you still haven't added them. So you cannot define them. So it makes a little bit of a weird thing for TypeScript. So instead of using it like this .dependency, you can use another method called object.define property, and it will do all of this to you. So underscore dependencies, and then the second parameter is the key, and the last one is the value, and the name of the dependency. And it would remove all your complaints inside TypeScript. Okay, and forget We don't also need to use the accessor because we are defining as simple. So we can use another method for object. It is called getOnPropertyDescriptor. If you don't know any of these things, I could create a video about explaining them in detail. So if you need, you can you can comment for this part down in the video. But it basically would get the own property for the descriptor for my object. Okay, and what we need to pass to it, we need to pass a key of type symbol. And we need to pass the first parameter similar to the first one is to use this dot dependencies, and we need to pass the other one is the key, and we can return it dot value and make sure that it exists using like the checking one. And we can also expect that if we need to pass the type for it as type T. You can pass it like this, or you can pass it here as well. Like all of them are the same thing. Okay. So we now define it. We can reuse our container. So we can have our const container is equal to new dependency container. And we can start adding them. So we have the first one is add, and the key would be dependencies the todo service, the one we have inside the symbol, and we can copy, and that's it. We can then export our container just to make sure anyone needing it is using it correctly. And we can also do dependencies here as well, so all of them in one place. Okay, so now we have our dependencies and we have our container, and we defined our type. There is no any here. Okay, nice. Let's now do it with dependencies, and it's simple. And instead of having our container like this, we can get it. So we have our key, and for our type, we can remove as any, and we can also access the property similar to the getOnDescriptor things that we added here. So we can define it here, not this one, sorry, incorrect. It was the first one, define property. So object, and we can use now this dot props, and the key would be prop name, and it's not this, it is props only, and dependency is the last one. Okay, and for component, it is called element type. So we define it here, and element type, when you check its definition, it is a more general name for component class and function component. If you remember, there were ReactNode, the ones that we used inside our header, inside our partial link. There was the ReactNode, which is the actual execution, and there was functional component. So element type is it's function component and also class component. You could use function component if you would like to force everyone to use functions only, but element type is more generic, and yeah, it's more generic. Okay, let's implement this one. And for dependencies, this is the actual usage for it inside our index. So the first one is type string, and value would be of simple. So we can define key is of type string, and value is of type simple. We can extract it, but yeah, it is fine to have it like this, like key and simple. Okay, let's make sure we don't have any any's. And for dependencies as well, we can, instead of accessing it like this, we can use its own object descriptor. So object dot get on property descriptor, and then dependencies, and key is prop name, and then we access value and make sure we are checking it has the value. Okay, and this also another error, which is weird. If you console log our props, if you console log it, you would find it has value for it, But when you check it inside my component here, you would find it says, okay, you didn't pass anything. And if you do a lot of debugging, you would find the reason. And the reason is that when we are using the spread operator, internally JavaScript is doing enumeration on it. And if you are using define property like this, you are not saying this property that you already defined is enumerable. So when you spread it, it doesn't return anything. So we need also to define that this property is enumerable as well. So when we do it, everything should be fine now. So we can say comment. Yeah, I'm writing it wrong. Yeah, comment on video. Yeah, it is working now. So we did a huge measure explanation for this. And yeah, dependency injection is very useful when you are doing huge projects. And there is another library that helps managing all of this. It is called Inversify.js. If you are interested, again, you can comment and I could create a video about how we can use it. And it helps to manage dependency injection, and it also has TypeScript support. And let's not forget git add and commit. Commit use dependency injection. Okay, now let's work on our edit to do task. So we already have the ability to add and also the delete. We would like to have the ability to edit as well. You know, also notice that on the checkbox part, we haven't implemented the update as well, because we will do the whole update and edit in one shot. And what we actually at the end we would like to implement is that on the side there would be a drawer that would appear, and it would have different fields. So we'd have our text fields, there would be another one, maybe the checkbox part, and there would be our text area so we can add details to our task, and there would be the canvas part so people can draw on it, and eventually there would be our save and cancel buttons. And cancel would just like close our edit, and save would save it and also close it at the end. And the idea is that we would like, when we click on the edit button, our todo container would send an ID to our edit container. So our todo container would send an ID to our edit container, and then our edit container would speak to our todo service and fetch all details about the todo. And then it would be able to edit it away from the todo container or what is inside it, just to create this separation. So this part would be a little bit fast because it would be probably there wouldn't be much new for it. But you would see different ideas, especially with the canvas part, which we are going to have a different video speaking about how we are doing this whole drawing, but I will also explain it here quickly. So let's get started and let's go to our editor. And first thing we need to do is to create our edit container. So edit container, and then we create our files. So edit container.tsx, and also edit container.module.sass. And then we create our dummy component at first. So edit container, and we export it as hello world or like edit to do something. So let's create a div edit to do, just to be able to see that it is imported and it is working fine and so on. So let's import it here. So edit container, it's imported. Let's check out. Okay, it is working. Now we would like it to appear on the side because this is not right place. So let's go to our edit container, and I'm going to copy some CSS files as well. Okay, so I'm pasting it, and let's apply it as well. And basically what I did is position absolute and top 0, right 0 to be on the side, on the right side, background white, so I have some background, some button, and some padding on the both sides and on the top, and some box shadowing. So just simple CSS styles. Let's import our styles. So let's go to our todo container, and we have it inside class name, and we need to import it through classes, and then we import our classes from editor edit container dot module dot Sass, and let's see how it looks like. So yeah, now it is getting better. Let's start to build our edit to do itself. And we basically are going to have few components. So I'm going to, and let's start writing them. So the first one, we are going to have a title, and we can call it edit to do. And then we start having our fields, so we can add them inside a div. And we can start first have our text field. We don't have it, so we need to create it. So let's just at first we have our, we should have it already actually. Let's check it out inside our component. Yes, we have it. So we can directly import it, and we can create our text field. This is the first one. And then we need one for text area. So let's create it, and let's create a new component, and we'll call it text area field. And we can create our file inside it, .tsx, and also our module.sass. And then we can const, export const text area field. And then we create our text area input. So it's text area, and we can, and it would be similar to our text field, so it would have also some properties. So let's define our props as well above here, and you would notice that we are now jumping between multiple components, but this is fine. So we need to define some props, and add some, just let's add, we have some props of type props here, or let's say it's, and let's pass our value as string. Just for the time being, let's add just one input or one prop, and let's do the others later. Okay, so we now have our text field, and let's import it. So we have our text area, and it is imported, and text field, it is imported, text area imported, text area field. And then we can define value to be empty, and the other one to have value maybe 1 2 3 or something. It is requiring also our own input, so let's define it. Or this is just we would like to see something to appear. Let's check it out. So we have our input, and we have our text area. Let's also add our checkbox field. We can import it. And last one would be our canvas field, and this one would be a bit custom, so we will just add canvas here, and we will do it at a later point. And eventually we would have our two actions. So we would have our button. First one is save, and second one is cancel. So we now have our buttons, and it is okay. Let's add this one, save, as primary. We imported the wrong one. It should be, that's why it didn't apply the styles. We need to import our React component. And let's change it, and secondary for our cancel button. Let's check it out. Okay. Maybe we need to apply our styles for our secondary. Yes, secondary was implemented incorrectly. It should be secondary, not transparent. Okay. Yeah, it's fine. Okay, and this extra space is for our canvas. Okay, now we need to do some styling. Of course, we don't need to care about the warning for the moment, because it just says the value is, like, we don't pass the on change for our text area. We will pass it. So let's start some styling. And we can do some styling for our text field. So I'm again going to copy and paste, and we're just adding some spacing, some border, and some border radius, some width and height for our text field. And we can apply and import it here. So let's import it from classes and text field dot module dot sass. and we can apply our class name, be classes dot, let's check the name, text area field, and let's check it out. Okay, now styles have been applied. Now we need to add some labels for every input field, because you notice that so far when we implemented our components, they didn't require any label. But here they will start to require label, because showing this field doesn't make sense. So we need to show one for title for our edit, one for done, and also for text area. So let's apply them one by one, starting with our text input or our text field. So let's go to our text field, and it is as simple as creating a new property, and we can call it label, and it's type string, and then we can extract it from our props, and eventually we create our label on the side. So we have label, and we just print it. And what we can do, of course, to add all of it inside a fragment, so we don't have these errors, but we need to check if label exists or not. So we need to wrap all of this in curly braces to create an if condition. And basically we are saying check if label exists. If label exists, print label. If not, return null, because it wouldn't render anything. Okay, and we need to define label as an optional property, because we are checking here as well. So now nothing from our old component don't break. And let's go to our edit container. Let's put our text field beside our edit container just to make it visual. And we can add label, and we can name it task. Let's check how it looks like. Okay, looks nice. One last property as well for label to have some accessibility for it. We need also to define which label is this for which input. So basically we need to define some property called HTML4, and this basically would reference our input to have accessibility, and we can have it as a prop passed from outside. So we can have name, and it's of type string, and we can pass it, and we can add it to our input as well. So now we have accessibility for it, and basically it says inside HTML this label is for this input, because it doesn't know which one is for which. And we can set it as an optional field as well, and we can add name as task. Okay, let's now do it also for our checkbox. And label would be on the opposite side. So we need also to create our props. So checkbox, props, type. And we define, of course, we didn't pass any value so far. So we need to define value for it, because we are going to need it. And we need also label, and this is optional, and this type string, and also name, and this type string. And let's render it. So we have our condition, we check if we have label, and if we have label, we render it. And if not, please render a null. Okay, and we need to pass it from our props. So we pass label, and we define our type here. So we now pass label, and it would require it. It would require our value. So let's just say value is optional for now, and then we are going to fix it later. Let's now add our type label for our checkbox, and we can set it to is done, question mark. Okay, now it is fine. Now we need to make our label have some spacing here. So we can just add some margin. Let's go back to our checkbox, and we can pass class name margin left 1. Let's check it out. Okay, yes, now it is much better. Okay, and we can also define our HTML4 as well. So we can define it from name, and we can extract name from here, and we can define name as well for our input. And let's make sure that we create it as well. And we name it is done. Okay, now let's do it also for our text area field. And we will need to maybe wrap it in our fragment. And it would be similar to our text field, so we can just copy and paste it. So let's go to our text field. Let's copy label and let's paste it in our text area. And let's also define some. We already defined our styles, and it is oh yeah, I was wondering where it is. Okay, and we have name as type string, and we have as well label as type string. And we need to extract them from our props. So name and label, and we add it in our EditTodoContainer. So we have name, and we can say it description. Yeah, we don't need it capital letter. Okay, but label is capital, so description. Okay, and we forgot to make them optional as well, because they might be needed. So like, yeah, it would be the only place. Okay, so we now have title for task is done, description, and let's do it as well for our canvas. And for the time being, we are only going to create a canvas component for, not for the time being, but rather for this moment. And we are going to explain it, but let's just create it and let's add our title, and then we implement the canvas, yeah, at one point, because it's quite complex, but it is fun to explain. And we are going to have a separate video for it to explain it in details. Okay, so we have created our files, and let's export our canvas field. And let's return, and we're going to return also a fragment. And we are going to do the same with our text field. So we are going to import our label or copy paste our label. Let's go back to our canvas field. Let's add our label, and let's add our canvas HTML element. And then we can extract them. So we have label, we have name, and we can also define our props. And it is type canvas props. And we have label, again, optional string, and also for name. And of course, technically, we don't need this HTML for, because Canvas doesn't have name for it. But of course, it can be done with other ways, but we wouldn't discuss it for now. Okay, let's go back to our edit container. Like you notice, like not now. There are many things that needs to be explained, but yeah, knowledge is never ending. So let's define our canvas field and let's create it. Okay, and it is imported correctly. So we now have our text field, checkbox, text area, and canvas field. And let's also add some styling for our canvas field because it looks a little bit boring. So we can copy and paste them as well. I'm just adding border radius, some width, height, and cursor to have crosshair because this would be as if it's our like brush that we're going to use to draw later. Okay, and we can have our class name, and we can import our classes from our Sass module. .module.sass. Okay, and let's use our style. Let's check it out. Yeah, it looks good. But of course, this looks very wide. We need to shorten it. So let's change it inside our edit container. And we can have width of 400 pixels maybe. Okay, yes, now is much better. Okay. Let's now start adding some reactivity, because what we need to do is that this only appears when we click on our edit button. So let's go to our to-do container and let's close everything just to make things easier to read. And let's go to our to-do container, the one that has multiple to-dos. And we are going to create a new state, and we're going to do it later in a better way, but we will do it with the easy one now. So we can say selected task, and we can set it selected task, and it would be just a number, and it would have start value as -1. And basically when we edit, we set this value. When we close, we set it again, and we set it back to -1. So if it's -1, we just make it disappear. So it's as simple as creating a new condition, and we can say if it's not equal to -1, then show our edit container. If not, then show nothing. So it would now disappear. And when we click on one of these, we need to set our value. So we need to go to our to-do item, each one of these items, and we now add one other button for on edit clicked. We previously had on delete. We now need also on edit clicked. And we set our ID, send it, and it's a void function. It returns void. And when we click on edit, we call it. So on click, we call it, and we send to it our to-do ID, and we need to extract it from our props. So when we click, we call the method, and then we need to call it here. So on edit, maybe before on delete, and we call it, and we define it up here. So const on edit clicked, and we then set selected task to our ID. So we are going to get our ID from here. We're going to copy it, paste it, and then use it here to set it. Let's check it out. So if I refresh and edit, yeah, it's working. What we need now is to pass our ID. So to do ID, this is the ID that we are going to edit. So we pass it as selected task. We can actually define it as selected to do ID. This would be a better name. Let's change it as well here. And it would be set selected to do ID. And then we set it here. Yes. So everything is nice. And then we need to define inside our edit container. So we are going to define it in our types. And we have edit container props is equal to do ID of value number. And then we can import it from here. To do ID. And its type of edit container props. Everything is nice. And let's just console log it at the end to be able to make sure that it is working. So when I edit, it opens and it sends my ID. Okay, now when we close, we also would like to reset our ID. So we can call them here. So we can define also on save clicked and on close clicked. And for the moment, we don't need to send any IDs, so we just can pass them and call them when we save. So we can define internal functions or intermediate one. So we have on click save button, and we define it as function, and then eventually we would call on save internally here, just to be able to call it, and then we'll define different values that we would like to send later. So we have on save, and the other one was cancel. So we have also on cancel, and We can name it actually on cancel, and we can pause it, and on cancel clicked. So they have the same name. Okay, and then we call them. So on save, we call on save button, and on cancel, we click and on cancel button. Because it's eventually a container, so it would hold logic as well, not only UI, but also logic. So we don't need to pass everything to the outside. And let's say it is just now a normal function. And let's see what properties that we need to pass. And I'm sure there would be properties that need to be passed, maybe. But for the time being, no. Okay, so we have only on cancel clicked and on save clicked. And for the moment, we can just call close drawer. So we can name it even here like close drawer. And what we need to do is set selected to do to -1. And we are going to do a lot of cleanup because this code seems not good. Okay, let's check it out. So we have our edit, we have cancel working, edit, and we have save. Let's now implement our update methods. So on our edit container, we would like to have an effect to fetch the ID because we would like our to-do stored here is separate from our to-do stored in the list because they are two different things. This is our current status, and our edited to-do is something that we would like to be in the future. So we cannot edit the reference, but rather we need to create a different state. So we can create first our internal state. So we have const, and we can say to-do and set to-do and use state, and we can call it. And since it would be a different model from our to-do models that we have created, because our to-do model, if you checked it out in our models and then to-do, it has an ID, and we don't have an ID. So in this case, it would be a separate state from it. So we create a new type, and we can call it to-do state. And let's set it inside our use state. And then it would ask us to set our, or we can set our initial status for everyone. So we can just copy it, and let's remove our ID because we don't need it. And let's set it here. And let's set our initial values. So string empty1. And let's do it for the others as well. And for done, it starts with false. Okay, now we need to fetch it. So we have a useEffect, and it would be at the start, and it would call our to-do service. So we need to inject it. Now we need to add some dependency injection. So we can create our index file here, and then we can use our with dependency injections that we already created and inject our components and inject our services that we need. So the first one is our component, so edit container, and we can define our dependencies inside it. So we have our to-do service. This is a service that we need to inject, and then our dependencies. So dependencies dot to-do service to be able to find it from our container. So now we have it. Let's inject it now as one of our properties. And we set it of type to-do service. And now we don't need to use new keyword. So we now have one object for the whole application. And it's easy to inject, and later it's easier to test. Let's import it from our props, and let's fetch it. So we need a method to get a single to-do. So let's go there and implement it. So go to to-do service, and I am going to copy and paste it. So we have also a call to our get to do, and it's just calling again HttpAdapter get method, and it's calling our specific endpoint for to do /id, and you can find it inside our service.js. There would be also definition for endpoint, and basically it finds inside our array and then returns it back. So it's as easy as this one. So let's call it get to do, and we need to pass our ID that we get from the outside to do ID, and then get our task. Or we can, yeah, it's named to do. Okay. And when we get it, we can set our to do element with our to do that we get from outside. And we need to define this as an empty array so it doesn't expand it with multiple calls, but also our to do ID might change, so it is better to add it as a dependency. And for the other one, which is mentioning dependency on also to do service, we can set it just to remove the error, but I didn't put it because it's unnecessary for our case, because to do service would not change. It doesn't change, it's just a collection of functions, so it doesn't matter, but we can add it. And now let's check it. Okay, so the last error for this one, it is just mentioning that our to do service is missing, and the problem is when we check our TodoContainer, we are basically importing internally. We are importing the actual edit container, but rather we need to import the one with dependencies instead. So we can import our default instead, and this one should work. Okay, and this error is saying that to-do ID and all the other props are actually not assigned to our edit container, because if we check back again with our dependencies, we didn't extract our props or internal props that are passed to our anonymous component. So it's basically as if we check back again our to-do container, it's as if we are like this edit container, it's just an empty React component with no props passed to it. So we need to also to extract our props and spread them internally. So we need to do a small fix for our with dependencies to be able to also extract props. But you would notice that we already have name for props, so we can change it to maybe resolved dependencies. So these would be our resolved dependencies, and now we can have our props just as a name, and then we can spread them as well. And we can define our type, and this one would be called component props, and we need to define the type of our component. So basically we are going to call type of component, and this would be just the definition for our props type, and then we define it is these props internally for our component are the ones for this prop. It's just like referencing our type component to use it to extract the types of its props and use it for our prop. If it's unclear, you can also comment in the video and I could explain it there as well. But it's just like referencing our props from internally our component, just to make it work. Okay, now it is working. Let's check it out, our edit, and let's check also our network. And when we click it, we fetch specific to do. Okay, now we need to set these values for our to do. Let's maybe also hide this swiggly thing because I don't like it. So we just add to the to do service, but again, this is unnecessary. Okay, we need to pass our value for each to do. So we get our to do state, and then we pass it internally for our values. So text field, it would be our task. And then for our checkbox field, we will define a value and we are going to use it, but we haven't used it yet. We're going to define how we are going to use it. And for for text area field, we are also going to pass our description. And yeah, we already, yeah, let's remove the other one. Okay, so we now have our value, and let's do it as well for our canvas field. And it would be our todo.handnotes. And we are going to have label handnotes. Okay, and canvas field needs value, so we can pass it as string, and we can extract it. And let's remove name because it is not needed, like we said. Okay, let's check it. And if I click edit, I should see the title, like the video, and description. And now we need also to be able to change it and send it back to our API. Let's implement our patch call, and we need to implement in our Todo service. But I also remember in our HttpAdapter, we haven't implemented our patch call. So let's implement it. This is as easy as copying post, and we say patch method, and we rename the method itself. Yeah, that's it. Now we have our patch. Let's implement it in our Todo service, and we call it update todo. So we can copy, update todo, and it would call patch. And we need to change this one because now it's task that is being used, or to do actually. Yeah, then the model is to do. Make sure, yeah, this is the correct one. But we can partially update things. We don't need to update everything because, for example, we are not sending the ID as an example. So we need to use a different type, and then instead of to do, we can define we are going to use partial. So we can basically update few parts of our to do. We don't need to send all object. We don't need to send it with ID, description, handnotes, and everything. We can rather send it with one, and it would help us when we would like to implement later our checkbox for a single to do, because we can update single field for our component. We don't need to send the whole payload or the whole body. So in this case, we define it with partial, and then the name of the object and TypeScript would be happy. Okay, now let's replace it, and we send task, but I am guessing there is different. Let's check our service.js, see the implementation of patch, and we see there is a route with an ID, and we send our to do in the request body itself. So it should be fine inside our body. And we can, yeah, we need to change our patch body so it would be task, but since it is partial to do, we can define it like this. So it is partial to do, task, same type. And we send our ID as part of the update, so we can actually separate it to another parameter. And we send our ID here. So now we have our update to do method as well finished. Okay, now we would like, when on click saved, we call our to-do service to update and then close. And this would be inside our edit container. It has nothing to do with the to-do container. To-do list is just managing, close, and open this drawer. And again, we're going to implement it in a better way. But our edit container is the one responsible for updating. So when on click saved, we need to send our update to do payload, and we can send the whole to do object or updated state, and we send our ID, which we get from outside, and we don't set, but rather we can call when it is done because we don't need our to do. And let's remove the other save, and we are able to patch it. Let's now try to change title. Okay, it doesn't work because we haven't implemented so far our on change for every field. So let's call our on input for our text field. So let's implement it. And I guess this is not right. Let's remove it because we already have our on input. And we can call set to do value to update it. And we can get our current state and pass it as a function. So we can spread the whole current state, and this curly braces to return an object. We need also to return it in normal brackets. So we have bracket and curly braces to return the object directly. and we can update our task, and we here get our value, and we can update our task with our value. Let's make sure it is a correct name. Set to do and task. Oh yeah, comma at the end. Okay, let's check out and let's try. Okay, it is working. And yeah, let's try to save. And if I refresh, it is working. So we need also to refresh when we click on save. So let's go to our Todo container and make sure when save is clicked, we refetch again. So we can call it here, because this also is called after the promise is done. So we are on the safe side. Let's now clean what we have edited. Save and fetch is working. So now edit is working as well. So we can edit and save. Let's now implement on change for checkbox, description, and ultimately also for our hand notes. So first one would be our checkbox, and let's go to our components, checkbox, and checkbox field, and let's close everything or everything other than checkbox, and let's keep our edit container open because we will need to change it simultaneously. So we will need to allow on input, and we need to keep the same name with the others. So everyone will have on input. So let's keep it with the same name to make sure they are consistent. And it would send value of Boolean, and this function returns nothing, or expected to return nothing. And we need to import it, and when our input for text for checkbox, when it is a change, we can get our event, and we can call on input, and we can pass event.target.property called checked, and this would send if it's checked or not. So this is for checkbox, and let's also do it for our text area. So we have again on input, and this would be good if we implement it as an interface to make it sure it is consistent among all fields that would ever come. So let's also define as string, and it expects to return void, and we can extract it, and we can call it for our text area when on change is called, and we get our event, not like this, we get our event here, and we call our input and event dot target dot value, and then we need to implement our methods. So let's go back to our edit container, and we need to implement our on change, but in this case we need to copy and paste in everyone. It doesn't make sense, so let's create another method, and we call it on the top on form changed, or we can call it on form change. It's fine. And we can call as const, and it expects two things. It expects key, and it expects the other one is our value or updated value, and it would call our setTodo method. setTodo key instead of task, it would be generic, and value, it would be our value, and key is of type string, and value is of type string or Boolean because we have to do. So we can define it like this, but there is a better way. Instead of defining as Boolean and string and making sure this type is the same type, we can actually define it as partial. So we need to send a complete object, and this object would have our key and value inside it, and it would be of type partial to do state. So it would be part of it, and we need eventually to define this, and we can just replace our update state, our key and value, because this is not valid JavaScript. We can replace it with updated state. So we can send partial, and then it would overwrite our current state. So we have our current state, and then we overwrite it with on updated state. And then we can call on everyone. So we have on form changed, and this one would send partial task value. So I just need to send these two only, and it would work. Okay, let's do it as well for the others. So we have for checkbox, we have on input, and it would send is done and value, and also for our text field, so it would be description, and it would send it value for it. Let's check it out. And this one is from our checkbox from TodoContainer from outside, because our on input, we need to define it as optional, and we need to check it exists. So if it doesn't exist, yeah, we can define it as an empty function, but we can make sure it exists by adding our name and then doing an end. So if it's false, it would never call it at all. So we save also like another code. Let's make sure it is working. So if I click on is done and then write some stuff, and if I save, if I refresh, check it out. So this one is working. Is done is not checked. Let's check why it not. So let's get back to our code and checkbox. And basically for our input, we are not passing our value, but checkbox doesn't get value, but rather we need to pass to another property called checked, and we pass our value as true or false. And we need to import our value from our props. Okay, now let's try it. Let's open it. Yes, it is working. It's done. It's working. If I open the other one and I save it, and if I open again, is done is working. So let's also implement our is done for our list from the outside for our to-do container, just to also finalize it. So let's get back to our to-do container, and we would have on done clicked for our to-do item. So on done clicked, and we have also another method on done clicked, and we create our function. We can call it from first one. So on done clicked, and let's create the method. So we have it. Let's define it also in TodoItem. So on done clicked, and it would send again our ID number, and there would be status. We can call it is done, so it would send it as well, and it is type Boolean. And let's call it as well, so we can pass value from our to-do dot is done. So actually we could have kept our value to be non-optional to make sure that we always get value. So we can just remove it from our checkbox quickly. Let's get back to our container, not container. It was every to-do item would have it. So back to our to-do item, and we have our own input. And when our check field is clicked, we need to call our on done clicked. So we pass it, and we call it, and we pass our ID, and also we pass value. And by the way, adding these methods here are not the correct way, and we are going to fix it as well. Too many performance improvement coming. So yeah. Okay, now check this working. We need also to call our update. So let's go to our to-do container, and if you remember, we need to pass our dependency. We already passed it our to-do service, so it is fine. And we just, when on done clicked, we need to patch it. So let's copy one of these elements or these calls, and we call update to do, and we pass our to do ID, and then we pass partial for is done, and we get our to do ID from the call, define it as number, and is done as Boolean, and then we can send it. We can also remove all of this because it is the same name. Okay, let's click, and it is calling. So yeah, like, comment, and hopefully get 1 million subs. Okay, we also need to do some visual. So when we click on this checked, task need to be like strike through. So it is being like struck through it. So let's implement this part as well. Let's go to our TodoItem. And it is as simple as we add a new class for our task when done is when the value is done. So let's add our classes and then add plus here. And then we have a condition that checks if to do is done, then add our class. So we can add classes dot to do done, and we can define our class. So let's go to our classes, and we already have it. So to do is done. We have text decoration line through. So let's make sure it is the same name. So to do is done, and yeah, that's it. This is just a short way to do if conditions, by the way. You just like check if it's true, and then it would add the others. If not, it would not implement it. Okay, and probably class is not added. Yes, we need a space here, and it is working. So we now also have our line through when it is done. So let's commit before we start implementing our canvas. So git add, git commit, implement, edit, to do feature. Let's now start working on our canvas, and I'm first going to explain it in details before we start writing code, because I'm also not going to write every detail in the code like step by step, but rather I would do like a lot of copy pasting. And there would be another video where I'm going to build a painting application, and there would be like more details there. But here I'm going to explain the concept from higher level. So we are going to have our canvas HTML element. And let's think of how the user is going to use it. Basically, they would click on it, and then they start move to draw stuff, and then they move or unpress the button to stop drawing. And this would be our 3 phases for our canvas. So we would have 3 event listeners we are listening on. We have the first one, which would be mouse down, where we are going to listen on presses. And there would be another one called mouse move, where we are going to listen on movements. And the last one would be mouse up. And mouse up would be when we unpress the button. And there would be another event listener we are listening on. It is called mouse leave, because if they are drawing stuff but then they still keep pressing but they move outside of the canvas, we would like also to stop drawing. So these would be our 3 event listeners. And there would be the same thing like with every input fields that we have. We have a value prop that we are sending inside, and there would be our on input event that we are emitting to our state outside. And also we are going to have an inner state where we are going to store the state if we are drawing or not. So we are going to have 2 states. There is the outside state, which we are going to store the value, and this value would be a base 64 encoding for the image. Basically it is the image but just encoded as a string. This is the whole idea. But we are going to have an intermediate state in the middle where we are going to store if we are drawing or not. So we'd be able to, if we are drawing, then we start drawing on the canvas. When mouse up, we stop drawing. So we set is drawing to false. This would be the inner state. And of course, we are going to have a reference to this element so we can attach like events to it, reference it, and use it, and so on. So these are the different components for this element. And if you have questions regarding this speed explanation, you could leave it in the comment. But now we'll start copy pasting the code just to get the element working. So let's start copying the code or creating or writing it. So the first part we would like to create, we are going to reference to our canvas. So we are going to use our useRef, and then we are going to reference it inside our element canvas HTML, and also we are going to import it. And we are going to attach our different event listeners that we need. So I'm going to copy and paste them as well. So we have on mouse down, when we press, we need to enable drawing, and then mouse move, we will start drawing, and when mouse up or when mouse leave, and basically it is when it exits the canvas, we will end our drawing. So we would need to have our state for isDrawing, and we are going to import useState. So we now have the two states, and then we are going to have the first one, which is enable drawing mode, and basically it is just setting the state to be true for drawing. And we are going to also copy in drawing, and it is basically going to do two things. The first one is to set drawing to false to end the drawing procedure, and then it is going to input the value for our canvas. So it is going to get to the reference, get to toData itself, and then it is going to toData. Basically, it's a method on our canvas, and it is going to change it from its like canvas stuff to become base64, basically to become a string so that we can reuse it at the end. And we are going to define it here on the events. So we would have our value as string, and this method returns void. Okay, and we're also going to import it. Now we need also to listen on value. So when value is coming from the outside for the first time, we need to attach it to our canvas, and this is where we are going to use a useEffect. And when we use useEffect, we will get the value and then attach it to our canvas. But we don't attach it to the canvas directly, we attach it to something called context, and all of this is related to the canvas API. And to get the context, it's as easy as just having this variable canvas context, and then we trying to access it to the get context to 2D. This is the method. We just like invoke the method called get context, and then we pass 2D to it, and now we have access to the context for this canvas. And then we can fire up our useEffect. And by firing our useEffect, we need also to import it. And what it is going to do, it is going to listen to our value when it comes from the outside to changes for it, and also to the canvas context if it changes, because the first time when it runs it is null, and second time it would have value. And basically it would check, do I have value? Then create a new image, and when image is ready, just attach it to our canvas. So draw an image, draw this image, and then now attach it to it, and then yeah, source is equal to value. And that's all of what is doing for drawing it from the outside to the inside. Again, we are going to have a paint course, but the concepts, just keep in mind, we try to understand the concepts, but how internals and all of this works is like unrelated to React, but just to get an idea of how we can integrate with a third party element. So we have useEffect to run as the first time, get the value, and then attach it to our image. And now we need to implement the last method, which is going to start drawing. And start drawing is a little bit of a long method, so I am going to copy and paste it as well, and again explain it. So let's copy it up here under the useEffect, and then let's explain it step by step. So start drawing is a method. It's called when we start moving. So the first part, we need to check if we have the canvas context, and also if we are drawing. If we are drawing, then please proceed to the next steps. And to start drawing, we need two things. We need the point on the canvas, like this would be the start point. We need the starting point, and then we need the end point, and then we can draw a line. But since we are drawing, like moving along the lines that we're doing, we are finding multiple events. So you can think of, we are drawing small lines, like one line here, one line there, one line there, one line there. So basically we need to listen on the start, and we need to listen to the end. When the first time, when we start drawing, there is no initial value. There is no X and Y. So we need to initiate them with zero, like not with zero, but rather with X and Y for this event and not draw anything, because we need to first define our first or initial coordinates. And then when the next event comes, we will get the second point on our drawing, and now we can draw a line. So let's see it inside the code. So the first part, we are just getting some coordinates. All of this is just calculating the coordinates, but this would be where we are checking. Do we have previous coordinates? Is there any coordinates that we already have? If not, then just set the coordinates. This would be the first point, and then just don't do anything. Next time when the event fires, it would get previous, it would find, okay, actually there is previous coordinates, then I wouldn't implement this part of the method, and I will start drawing the line, and then I would set the current coordinates as the previous coordinate. What is this previous coordinates? It's also another state that we are going to create. So I am also going to copy and paste it. And this would be also another state. And it would be coordinates. I didn't copy all of it. And this would be type coordinates, and it have X with 0 and Y with 0 as initial values. And we are going to define our type up here. And we're also going to import our event type from React, and the canvas is already imported. So it would start first with 0, then we get few properties, and this properties is just to get the point on the canvas. And if previous coordinates are already with 0, then just set as previous, like the current event set the value to know the initial start. And then next time when it runs, it would get, oh, they are no longer 0. So in this case, I will start draw lines, and then it will start drawing our lines, and then set the previous to current. And then the next time previous would be the last current, and there would be the new current, and now we have coordinates for our lines. And you can imagine also when we end drawing, we need also to reset these coordinates that we have copied and pasted. So also we need to set them to 0. So I'm also going to copy and paste this part. And again, there would be a full app to build a painting application. Okay, so now it just needs our values that we need to pass to our field. So let's go back to our edit container. And we now need to set on input is equal to value, and we have also form change. But this time we pass hand notes. And we also we already get the value from the outside. Okay, let's try it. So open it. It is not working. Let's see what we didn't completely copy. Okay, so what we are missing is also to call the stroke method. And basically it would do the stroke for the line. Let's try it again. Okay, now it's working, but it is like the line is very thick, and basically we need to use the size of our image. So we are just going to give it a width and height larger one, just to make images bigger, and then it would become like it would be bigger, but then width and height from the outside from the CSS would make it smaller. And that's one of the reasons why we needed this scaling, to reduce to be able to convert like where our pixels are actually pointing on our canvas. And now let's try it. And it is working, and it is looking nice and smooth as well. So this is the canvas in summary. And if you would like to see in detail like approaches and canvases and everything, make sure to subscribe, because there would be a video about the pending apps that I have mentioned. Okay, let's now commit. So git add, git commit, add canvas field. So in summary, what we are able now to do, we are able to set or update the status of our to-do. We can also change things inside here. We can write some notes, and we can save. And if we refresh and open it, everything is still working. We need just to remove this console log thingy, and everything should be nice inside our app. Maybe also we need to give some styles for our save and cancel button, because they don't look good. So let's copy them. So I'm going to go to our edit container, and in general it is simple as putting our class name and giving it flex and give some margin top equal to, and then giving some styles to our button. So we can set class name, and we don't have a property called class name, so we are going to create it. But just like first add our styles. So we have flex grow 1 and margin right is equal to 2, and the other one would be also flex grow as well, just to make it like expand. And let's define a property called class name to our button. So we can go first at the props, and we define it's optional, it's of type string, and we can extract it, and then we can pass it to like the styles of our button, but it's just as easy as extracting it. So we define class name as one of the props inside the array, and we define it starts with an empty string. Let's refresh, it's open, and now it looks much better. We also need to fix this scrolling part. So we can just give an overflow to our edit container. So let's go to our edit container, and we can just give it overflow auto. Let's save, and now it is much better. Let's now do the filtering for the list of our to-dos that we're going to have here at the top. And afterwards, we will discuss the virtual DOM, and also we're going to do a couple of improvements to our application. But first, let's do the filtering. And it is basically going to be a couple of buttons. So we can create a new component and we can call it button select. And it would be similar to the same idea of radio button. So when you select one of them, you can select from a group, but instead of having radio button group, we can have button group, or we can call it also button select. Like all of them is fine. And basically when we click on each one or any one of these options, that's why I'm calling it button select instead of like button group. So it's like select field. And when you select one of them, we are going to emit the value similar to what we do with the select field. So let's create our components, and we can call it button select, and we create the file button select.tsx, and also our module.sass file, and we are going to create it. And what we need to do is to return, let's just return div, and let's say like again hello world, and let's import our classes as well from that button select dot module dot sass. Okay, and let's use it inside our to-dos container. Let's close the others just to make things easier to look at, and let's open our todo container. Let's go here, and it would be basically in the middle between TodoItem, AddTodoItem, and also the array. Okay, so now it's going to be here. And let's imagine, so for a select, we need the value to be the current value. And we're also going to have on input when we change our field to update the state. And we're also going to have our options, which would be an array of different options that is going to be passed to our field. So this is another way of how to look at how we are going to build our component, to build the API, like the API for it, or the props. Okay, we create the type, and then we define value, type string, and we have options of type string as well. We can make it type string, or we can have also like key value for it, which would be better. And we define options is basically an array of options, or option, or button select option, which is better. And this type, each item of it would be just a label of string, and it has a value. And in this way, we can separate the value that we store, which we will also send it to the API, and also how it would look like in our array. Okay, so we have list of options, and the last one is on input. And this would fire value of type string again, and it requests or gets nothing. Okay, let's define it here. And let's extract each one. Input. And basically inside our div, instead of this, we create our curly braces, we get our options, and then we can map each option to a button. So we have our options, and we can return a button from our components. And we set internally or inside it as one of the children. Now we created like two of them. Like the children of it would be the option dot label. We close the curly braces, and we have on click. We fire our event, which would call on input that we have passed from the outside, and we pass option dot value. And by this way, we can pass the value for it. Let's also define the status for each one. So the first one, we need to define the different options that we have. And they are going to be these. So we have all, the value all, done to be true, not done to fire false. You can have these with whatever you would like. I just use this name. So we have them under options, and we need also to store the value, and we can create a use state for this. So let's go up here and create a new state, and we have to do state filter and set to do state filter, and we start at first with the state of all, and let's use it for the value. And then we have on input, we need to update the state. So let's create a method for it, and we are going to call it on select to do state filter. And let's define it here. So we have on select, and we set our to do state filter to be value, and this value would come from here, and it's with type string. Let's check it out. So we have these states. We need also to set class for it. So let's copy and paste them. So I'm going to paste them inside our Sass file. And basically we have our wrapper to make them on the same line with flex. And of course, like it's not completely needed, but it's fine to make sure that we are having it on the same line. And then we have styles for each button. We can have like secondary as style for these buttons, but I would like to have this button option select like with these exact styles, and to make sure it has uppercase as well. Of course, like also the other buttons have other uppercases, but the rest of the styles. And we can also have like all of this like secondary button, like all of them make sense to have like secondary. But anyway, and the last one would be selected to make sure if we have one of them is selected to have certain styles. So yeah, they are simple as this. Let's start applying them. So class name, we have classes and button wrapper, and for each class from what we have, we are also going to apply for button select options, and we also need to apply style if the button is selected. So we can just say if option dot value is equal to value, then just add the selected style. So classes dot selected. Let's also make sure we copy it correctly. Okay, and let's wrap all of this to make sure this is the one that is returned, because it's going to add all the first and then do the end. This is not what we intend, so we need to add the brackets to make sure I would like to do this conditional operation at the end. So we now have all is surrounded by a border, like blue border. And we need to lastly as well do some margin top. So we add it inside a div, and we define a class name and button maybe of 1 or 2. Like any one of them should work. But this one is better to have, like this one is closer to add instead of like the list. Or yeah, like this one is better because the filtering is actually to the items, not to the field. So we can add even more. So this is better because it makes sense. These filters are closer to the to-do, but not the add field. Yeah, some UX stuff. Okay, and lastly, we would like when we select, we start filtering. So it is basically going to call the API. So we are going also to add it. So we have to-do service, and we need to get all to-dos, but we are going to filter them. So we need to define a filter. So we can just basically copy one of these. So get to-dos, and we can set them, and then we can define the filter here. This is not correct. Okay. We copied in the wrong place. Sorry about this. Should be the other one. Yes, correct. So we get all to-dos, and then we get the to-dos, and then we assign it to our state, and then it's going to update the list. And we need to pass the filter here. And before implementing it, let's see how we are going to define it first before using it. So inside our get to-dos, we somehow need to pass params here, and in the get request, we need to pass params again down more. So we need to pass it here, for example. And we are going to get it from the outside. And lastly, inside our get method, we get it from here. So we get params, and we can define a new type for it. Like it would be fine to define it, but rather I'm just going to do someone simple inline. So we are going to say it is equal to type query, and this type query is actually an object. So we can just define it like this. This would be the type, and then we can start it with an empty object, and we can say query is of type is equal to an empty object. So this is just the type definition, and this is the initial value or the default value because we are not going to reuse it again. Okay, anyway, let's write or copy paste some code again, sorry, which is going to basically get every key inside this query and combine them and have the ampersand to create the get request or the query header for the request. So I'm going to get our query from our params, basically. So it would be params.query. And we are going to map over every key. So we're going to extract our keys, map over everyone, get descriptor to be able to get the value and get the key. And then we just assign them, like we have the key equal to the value. And then we join them with the ampersand to create the header. And eventually we can add it to our query. So we can eventually combine it, and we need to create the question mark string. By the way, there are other methods that could help you do all of this instead of like doing it manually. But this would be more than what we need. Okay, so let's define also params. And for our get to do, we only have one value for it. So we pass query, and we have is done of type Boolean. This would be the type for our params. And we don't pass it as an object, but rather we pass it all. And then we can define it on the get all to dos. So let's get more up, and we can define it here in the query. So it's done, and it would equal to our value. Okay, and this is not correct because it makes sense. We need to change our value to become Boolean. But I did a quick recheck again on the servers that I have created. So if we go back to our service.js and we check our get for the list, we can pass it actually as a string. So if it's done is true, we pass these, and if it's false, we just filter them. So we can pass them as string for the time being. So we can define this one as string, and we can save it, and let's try it. Let's get back. And probably we need to define this as an optional value. It is not required. Okay. Okay, after some debugging, basically I forgot to extract the value when we call getOnPropertyDescriptor. Okay, let's now try it. And it is working super nice. Cool. Okay, and we need also for both on select, we need to define key. So we can define it here, and we can just use option.value as our key. Okay, so we now can do filtering as well. So in summary, what we can do now is we can add tasks. We can also set them to done. We can edit them, and we can do some hand notes, and we can save it as well. And for this error, it is just because at first, if we go to our service.js, when we add a new to do, we are not setting the initial status for is done to be false at first, because we need to set it when we create a new to do, because if not, the value of a checkbox would be undefined, and it's undefined, and then we set a value for it like true or false. React wouldn't understand it, would say like it didn't have value but now has value, so I don't know, should I control or not uncontrolled element? This is like a different story. But instead of like going to all of this, we need to set the initial status for it so React can control it. Okay, so let's try it now. If we add test and we do it, React is happy for us. Okay, let's now commit and we will discuss our virtual DOM. So git commit and add to do filter or to do filter. Yeah. And let's now go and discuss virtual DOM. And virtual DOM is internally how React is doing its own rendering and algorithm and trying to render and find the state and so on. Okay, so what is the virtual DOM? Virtual DOM is a representation of the actual DOM but in JSON format. So we have, if you remember from the first initial part in the video, we used a function that is called createElement, which is like it's a representation for JSX that we are writing so far. And basically when we are creating element and so on, we are building a tree in a JSON format, and this tree would be a representation of our actual DOM tree, and would have like every sibling. Like for example, here was the TodoContainer, and then there would be here like the add element, and maybe inside it there would be the add element field and buttons and so on. Here would be our list of to-dos that we need to do, and here there would be like each element and so on, but everyone would be a representation, and basically it just represents the current or the name of it. Like for example, it's a div, and then there would be the different props passed to it, and there would be an array of children. And if any changes happens in any of these, means that this node has already changed. And React would do all of this in two phases. The first phase is the reconciliation phase. So there will be the reconciliation phase. I hope I'm writing it correct. And there would be, it is just comparing what is the current tree, like this one, and then the work in progress tree. We call this one work in progress tree. And this would be the trees that we would like to transition to it. So for example, inside our tree, maybe after we build it, we needed to add a new element. And let's do it in another color. And this would be the change. In this case, React would run it and say, okay, I would need to update this whole part. And then it would do the second phase, which is commit. and it would commit these changes. So first it's done reconciliation. It's just a fancy name to mean like I'm going to check the current tree and next tree and find the differences, and then I am going to commit to the actual DOM. I'm going to apply the changes that you have told me. And this is just how the virtual DOM is doing all of this. So instead of keeping memory of a real DOM and keeping memory of the actual real DOM that we would like to change, this would consume too much memory. But if we just keep them in JSON format, it would be just very lightweight. It would be very small. It wouldn't take too much heavy processing. And this is what is the virtual DOM. And React had before a reconciler, the reconciler algorithm, which was, I think, like before version 16, it was called the stack. It was called the stack algorithm because it works like a stack memory, and basically it is going to like stack all the changes into the memory and then return all of them and then apply them to the DOM. The new one, which now currently exists, it is called Fiber. This is the new algorithm, and basically it is going, instead of having a stack and then using this stack, it is going to block the UI until everything is returned. Fiber is doing all of this in incremental changes. So instead of applying all changes at once, it is going to add them as if like different promises, but of course like it is not working as promises, but as a small async tasks. And this is like small work tasks that it needs to do. And then it's going to process each one depending on the priority. For example, it might be some animation needs to be done later, and then a user clicks on a button. So instead of doing this at the end, it is going to do it at first, in front of the whole work that it needs to do. And it is adding these tasks into, like it is calling a callback into the window DOM to add these tasks in like in this, like not the stack, but in the work queue that it needs to do. There is one called request ideal callback. Yeah, I'm writing it incorrectly. Maybe I'm going to add it directly. So we have the first one, it's called request ideal callback, and the second one, it is called request animation frame. This one would be for normal task that is not required to be high priority, and request animation would be request animation frame for higher priority tasks that is need to be done in the DOM. All of these are just small details just to have an idea how React is just working, but is it necessary? No, it is not necessary. But just having this idea makes you appreciate how React internally works and have understanding of how the library works. And you have like some advanced knowledge about React. And the last concept as well regarding this whole React internally is that when, for example, you are using setState or you are using other methods in React, it is not doing it automatically, but rather it is adding it to the queue. And eventually it is going to process these changes later. And also another note about the tree itself, it's how it's structured, like the fiber itself. So you would have your root element, and then it would point to a child, and it points to a single child, and then this child points to a sibling, and this sibling would point to another sibling, and so on. And every child could have, of course, a child as well. And every sibling as well could have like their own child. You can call them child as well, but they are sibling because child points to its own sibling. And React, how it's going to process the tree, it would first start the root, start it and find, okay, I have a child for it. Maybe I use another color. So first it starts the root element, find I have a child, then it processes it, it finds, oh, there is a sibling. Then I am not sibling at first, but it finds, okay, this child have a child. So it is going to process it. After it is done, it is going to return it to this child. And then this child is going to have a sibling, then it is going to process it, nothing here, it is going to be done. It is going to go to the other sibling. When it is done, it is going to return everything to the root, and the root is done. All of this, there would be few links if you would like to get into more details into the link of the GitHub repository that I'm going to add in the description section. And there would be few videos if you would like to get into more details into React Fiber. So all of this, it is nice to know. It is not necessary to work with React, but just to have an idea of how Fiber is working. And if you have any questions, again, just leave them in the comment section and I will answer them. So how all of this can be useful to us. So far, when we build our application, we didn't try to optimize the re-rendering process for our application. So when we try to do a certain change, for example, when we try to write certain text field or we try to set this to do, we thought, okay, this would only the part is going to render, but actually React is going to re-render the whole application. Like for example, when you are going to change all of this, it is going to re-render this part, all of it, even including the button, also like the button didn't change. And also here inside these elements, also like it's only a small part that has changed inside this whole component. And to be able to see it, we need to install a plugin that is called React Dev Tools or React Developer Tools. And we just can go to our profiler. And if you cannot see it, you just need to refresh, close the DevTools and open it again, and you would see it. And we open the profiler, go to settings, and we highlight updates. And when we enable it and we now try to write things, you would start to see that is being highlighted. And you would see the text field is highlighted and also the button. And if you are not seeing it, we can do some quick style changes to be able to see it as well. So I'm going to add some padding to our text field and also some padding to our button. This is just temporary stuff. It is not like we don't need it actually, but just to keep it temporarily. And also for our whole element as well, we're going to add temporarily styles and we're going to add some padding and 20 pixel. It's just to be able to see the styles and keep it. So now when we try to write it, you would see there is one for the whole add item and there is one for the text field and there is one also for the add button. Maybe I will do more changes to make it more visible as well. So instead of adding it inside the styles, and also I added wrong inside the button select, shouldn't be here, but rather it should be inside the button styles. But instead of this, I'm going to wrap the button in a div and just going to add this temporarily style. By the way, this is just to make it easy to see these changes for you. And let's close it. And also let's do the same for our text field. So let's go to text field and our element, and we can change this temporarily as well. Okay, now let's do it. And you can see now it is more visible. So you can see one border around text field and another one around the button every time when we write, although this button didn't change. So it is as easy as just wrapping our component into function called memo. So even it's called, like we could call react.memo, and that's it. And you wrap the whole function around it or the whole component around it. It's a higher order component as well. Or instead of React, you can just use memo, and that's it. And let's refresh. And when I write now, you can see button doesn't change, and only the text field that is going to change. And this is a nice improvement. And if we open our edit and also try to write, you would see every element is also changing. So we need also to also wrap every element field around this memo thing, like this memo higher order function. So we can wrap this around memo, but for forward, it wouldn't work like this. We need to wrap what's inside our forwardRef function. And this would work, and we need to import it as well from React memo, not memu. Okay, so we wrap it around memo, and let's do as well for our the rest of our elements. So also we are going to do it to our text field. We are going to do it as well for our checkbox and also for our canvas. So everyone would now be memoized. It doesn't need to re-render every element since only certain props has changed. Okay, and we need to import it as well. Okay, but now when we, there is also for the checkbox, we didn't import it. Set, let's import it from React, and also for text field from React. Okay, hopefully now it works. And I'm guessing it should be the opposite for text field. Should be this one that is memoized. Okay, and yeah, let's refresh. Yes, so it is the opposite. Memo, and then forwardRef is the one that is inside. Sorry, it was the opposite one. Okay, but now when we open it and try to edit, it is actually still going to re-render every element. And the reason behind this, if we go back to our edit container and we if open it, you would remember that we already passed functions when we, like if you would like to, when a certain change happened to a certain field, we would like to call the state and update it and so on. But the problem with this function, it is that every time when we write something, it is going to create the same function. Like it's going to create the same function, but it's going to be a new pointer. So it's basically a new function. And it will consider it a change inside the props, because memo, it is just comparing the props for for the elements that we are building. It's comparing it. And when it's re-rendering and creating the other tree to find if there are changes, it would come to the on input and find, oh, it's a new function, because it's pointing to a new function. Like using this anonymous function, it's pointing to actually a new function. And it would say, oh, this now changed. So what I need to do, I need to re-render again. So to avoid this, we need to call another function or wrap our on input callback into a function called useCallback. And this is also from React. And when we wrap it, React would keep a memory for it. And it's similar to useEffect. We need to pass an array to say, okay, when it is going to be changed, or we just don't have any dependencies when this use callback is going to be changed. And since on-form changes, it doesn't depend on anything, like the function itself doesn't depend on anything to be changed, we can pass an empty array. And let's now try to refresh. And if we open and edit, and what we have changed is the text field. So if I try to do it for the text area field, our text field doesn't need to re-render. And now we need to do it for every function as well. So we can wrap this around use callback and also for the rest. So let's do it as well. Wrap it. And also for the last one. And we need to pass a type for this one. We need to say it is type Boolean. Okay, now let's refresh and let's try to edit. And when we change, it is only going to change this description and of course the main element, because it is also going to change. And now we improved our application. So it's only going to render the part that is going to be changed. So this is done using two methods. The first one is memo, and the other one is called useCallback. Okay, let's remove the temporary styles that we have added because they are no longer needed. So there is one for the button, we need to remove it. And also one for our text field, we need to remove it as well, correct? Text field, yes, this is on. Let's remove it. And yeah, it wasn't fully, but we need to make it a fragment. Okay, let's end it. Let's now refresh, and now our application is better. Also was one for the add to do. Let's remove the style as well. So now our application is optimized and it is better. And of course, we can do more memoization for our application, but this would be left for an exercise for you. Let's continue to do more optimizations. And one optimization that we would like to do, we would like that the edit container, we would like to do some abstractions for it. So the first one, we would like to abstract the drawer part because technically it is not part of the to-do or edit to-do container. Like the drawer could be used in anywhere. You could have another side drawer. Maybe you would have user icon here, and it would have drawer when you try to open the settings. So this would be better to be abstracted to its own component, and it could be done as a higher order component. So we create a new higher order component, and we can call it with side drawer dot tsx. And since it is going to have some styles, maybe it is better to create a new component into its own directory. So we would have with drawer as directory, and we add with side drawer inside it. And we also have a file with side drawer.module.sys. And this one is easy. We just go to our, maybe we can close everything as well to clean things up. And we go to our edit container, we open it, and we need just to extract the classes from here. So it would be just as export const with side drawer, and it is going to again also export function to basically export the component, and it is going to be a div, and we are going to pass our component, and it is going to be of type element type, and we need to import it from React. And then here we are going to have props, and we can say component props. And lastly, we can execute it here. So have our component, we close it, and we extract our props. Save it. Let's check this error. Yep, correct. We need also to pass the type of the props. So we have our component, and we say type of. Okay, so now everything would be happy, and we can use with side drawer, and we can go to our edit container. Let's also extract the styles. This is not the correct one. Let's go to styles. We can cut and get them. Let's go to our with drawer, and we add them, and we can rename with side drawer, and we can import our styles. This was maybe missed auto. Should be as well like overflow. Why not every overflow? Okay, and let's import our classes from dot with side drawer dot module dot sass, and we can use it here. Class name dot with side drawer, and W is capital. And let's go to our edit container, and we can now remove these styles because they no longer exist. Now the edit would be in a weird way. Now we need to encapsulate it. So we go to our index, and we can encapsulate everything into with side drawer. And we need to import it, of course. And now it is working. So now we are able to abstract with drawer and use it with whatever component we would like in the future. If we have user settings, we can abstract. So this is the first thing we would like to improve. Second thing we need to improve as well, if you remember, for edit container, we already passed the to-do ID, but we don't want to do that because we are passing it from TodoContainer to edit container. But maybe I would like to use the edit container somewhere else, and I don't want to depend on the current opened todo IDs that we would like to edit. It would be better if the edit container is not in the same level as the todo container, but on the level of the app. Like it would be much better if it's here, not inside our todo container, or like not inside this part. So todo container would be separated from the edit container. And it would be much better if we have it here. So we can have edit container here instead of having it internally. But the problem is we need to pass the todo ID into it. And this would be a problem. So how we can share the state between both of them? We are going to introduce the React context. And React context is going to create a shared state between these two components on the same level, or like from one level to the other whole level, and it's going to share a certain state. And how React context it works, we first create our context. So we have a method create context, and then we can use it, and it will provide us with two things. The first part, it is going to provide us with a provider, and this provider is something that we wrap around all the elements that is going to have this state, but we don't need to pass them as props. Like, we don't need to pass them as props, but rather they are going to magically pass through it. So the provider is something that is going to wrap all the components that is going to have this state, and internally we can call a hook similar to like the state and effect and so on. It is called useContext, and we can pass from the provider. There is like the create context is going to return a provider, but it's also going to return a consumer. And then we can use the use context and pass the consumer to it, and now we have access to the state. And we don't need to have this like props and pass it from the props from outside and pass it to its children and then to more children. So it also helps not just to share state between two components, but also if we have like we would like to get access to the state very deep, like in multiple other levels, and then instead of have something called prop drilling, you would like to avoid this. So we can use context to pass all of it down to wherever we would like to have. And we have it already, like multiple levels. We have the first level, which is going to inject the dependencies. There is also another one with the drawer, so it's another level. So instead of having props in the drawer and also props in the dependencies and also inside the edit container, we can just use the context to pass all of this through everything. So let's go to Visual Studio Code and start adding it. And it's as simple as calling create context from React. And here we can pass the initial value for this context that we would like to pass, which at first we would like to pass the value like edit todo ID. And we can start with -1, and then we can extract, or we can call it. So we can call it app state. And now I have access to this context, and we can wrap every container that we would like it to have access to this value. So we wrap app state and we get access to the provider. And then we wrap it around our two containers that we have here. And the provider would need to pass also again value or something that it needs to pass. This would be like the initial, but it needs to have the same signature. So we can have our edit to do and pass the ID as -1. So we now have access to this value, and we can go to our edit to do container. So let's go to our edit to do container, and we can call it. So const and edit to do ID, and we can call use context, and we just need to pass app state, and we didn't export it, so we need to export it up here. Export app state, and let's try to import it. Yep, it works. Let's try to console log it. And if we refresh, we can see now we have access to this ID. Of course, like the edit container is open because we have added the other edit container. Like we have edit container here, and we have also another one on the app. But eventually we are going to remove this one because we don't need it. Okay, let's continue. So this value is now only a read-only value, but we would like to be able to change it. And to change a certain variable inside React, this means we have to use a state. So instead of only passing in the app, instead of passing as value, we need to pass a state. So we need to pass two functions. The first one is the state or the app state, and the other function would be set app state. So we have the ability to set and get and do whatever we would like for the state, and React would be aware for it. Because if we try to change this variable, we can't. Like we already extracted as const, and if you call let for it, you're just changing the internal variable. But you need to call React and tell it, hey, please set the state and do the whole refreshing part. So instead of only passing the edit to do, we need to pass a state. So first part, we need to create a state. So we would have the two functions, app state and set app state. This is normal use state thingy. And we have use state, and we can start with the initial value of edit index, edit to do ID is -1. So we now have our use state, and we need to import it as well. So let's import it from React. And now we have access to these two methods. So instead of passing edit to do ID, we can pass these two methods, and we need to also change the signature to have the same value. So we can update edit state types to have also as an object. This would be the first one. And set state, we can just pass function for now. And it would need like more stuff. So we just keep as any, and we are going to update it later. So state, and we can keep it as any, or yeah, or let's just define the type. We are going to do it anyway. So for create context, we need to define app-state type here, and then we can create our type, and we can define each one. So app-state, that would be one of the properties, and it would have EditTodoID, and it's going to be of type number. And setState, I'm going to write incorrect one just to get access to the correct one. So I go to like setState, and I find it's a dispatcher setState type EditTodoID of type number, and this makes sense because it is going to get the signature. I don't fully remember everyone, but this is the way, and just make sure that I'm correctly using it. Okay, so we now also have defined it, and we don't need to use any stuff. So we have EditTodoID, and we can see it here. Like we have like app state and set app state. So we can, instead of like having todo ID, we can get access to each one of them. And luckily we can see the autocomplete. And we have app state, and it is rendering correctly. So instead of app state, we just need, for this level, we need to set app state. So let's do it. And let's go to our set todo ID, like we have here on the edit container, we have selected todo ID. We just need to find this method, and instead of having set selected todo ID, we would use set app state. So we go here, and instead of set selected ID, we set app state, and we can set todo ID is equal to todo ID, and we can remove this one. Let's make sure it is not called anywhere else. Okay, it is called as well here in the clause todo ID. So let's also change it. So set app state, and edit todo ID is equal to -1. And I guess it would be, yeah, this would be the only place. And for selected todo ID, it is only passed here inside our edit container. So instead of having it here, we can remove it. And we can remove this one as well. Or yeah, let's keep it for, yeah, let's remove it. Let's remove it. So we can remove all of these, and let's add it here. And let's also comment the edit container on this level. We will add it here, but just let's comment it here because we are now having it on the side as well. But we need to use app state inside edit container. So let's extract it from here. So select it todo ID. And we are going to go to the edit container, and we can also extract it as well. Not the useState, it is the one from the useContext. Sorry about this. And we have set app state, and we also have access to the app state. So we have access to both of them. Let's import our methods. And we can remove todo ID and todo ID here as well from the edit container, and we can now use them directly. So for edit, we have access to edit todo ID, and we can update this one. So instead of like one of the dependencies for the useEffect, when it opens, it has access to the, it depends on the app state.edit_todo_id, and when we save, we also send the app state.edit_todo_id. So now it doesn't depend on it, and we don't need the set app state, but let's keep it because we are going to need it. And we can say if app state is equal to -1, like the EditTodoID is equal to -1, then return null. Do not render it. And now we don't need dependencies between both of them. Let's see also the error here. Yes, because the callbacks that we already used inside every edit, it needs to be separated. So the callback shouldn't be here, but rather should be used outside each of them. So let's just comment it for now. And we are going to change all of this. Like we are going to change all of this, but just to get this one to work. And the last one, yeah, this one has some dependencies as well. Let's remove all of this. And again, we are going to fix all of these. We are going to keep the useCallback, but just to get it working. Yes, because we also have the withdrawer. And lastly, the show and the hide. So instead of adding it here, let's keep it in the to-do container for now, because we're eventually going to remove all of this. Let's also remove this set selected thingy. And let's add the condition back. So we have app state, and we need to extract it. So app state from here. And let's just add the condition here for now. If equal to -1, then return null. Otherwise, return the edit container. Okay, so now it's working. If I open it, it should only open my element. If I close it, it cancels it. And now it is not using the to-do ID from passing like the props from the outside internally, but rather it is going to pass it using the useContext. Now let's continue also clearing everything up, because we would like eventually to move the edit container from here to the app state. So let's do it. First part is the on cancel clicked. It is going to close the drawer, and close drawer is just calling set app state to -1. So instead of having it from here, we can do it inside edit container. So it is going to set the app state to -1. So we have one here on cancel clicked and also on save clicked when it is done. And we no longer need on save clicked, and we no longer need on cancel clicked. And we can move them from the props from inside, and we can also move them from the types. And we can now move them from here, but you will notice that we need also to fetch to-dos as well. So we need to somehow listen to our app state effects when it is going to change. So we can pass it actually as one of the dependencies, and we can say edit to-do ID. We depend on the to-do ID for the useEffect. And when app state.edit to-do ID is changed, we can call fetch to-dos. Or basically if it's like when it is changed and it is equal to -1. This is one way to do it. Okay. And the other error is just saying for the fetch to-dos, because it's also another dependency. We can add it, it is fine, but it is not needed for, so it's fine. And let's console log it just to make sure it is running correctly. So we can console log, and let's check our app. So it is running when it is -1. This is the first time. When we open it, it wouldn't run. But when we save now, it is going to run again and fetch our to-dos. So it would depend on app state.edit to-do ID. Of course, this is not the nicest one. The more nicer solution is to have an event listener, and we could have the event listener on the app state, and it could be on edit, like edit container closed, and then we can fire these functions internally. And we can pause this edit listener and so on, but I wouldn't go into more details for it here for the time being. Okay, so now we don't need on cancel and on save. And now let's refresh. And when we open, everything is working. We can save. If we open, it's still there. Let's also close all these updates because it's a little bit annoying. Of course, like it is not generally annoying, but only for this being or this time. Now we don't depend on anything on this level, so we can safely remove it from TodoContainer and have it here inside the app directly. So we can put it here on this level. And now it's going to be on this level. And if we go to edit container or to-do container first, let's make sure, yes, we don't no longer have the close drawer. And yes, everything we are still using. Let's remove also the edit container. And this is not needed. Let's refresh. And everything should be working. Okay. And we can also move the app edit to do inside edit container instead of like having it here because it's not fully necessary. So we can move it from here, go to our edit container, and we can have a condition if app state edit to do is equal to -1, just return null. So don't render anything. So we can do this. Now we see like more errors, and the reason behind this is that we are using useCallback, like we are defining it even after we already like returned null, like the first one could return null. Because in React, you cannot define a useCallback in a different direction. This is the reason. You cannot have different effects because running these effects are basically registering them. It is not like running when it runs the function, it doesn't run every function, but rather first run it is going to register and then it's going to return. So when we have different outcomes and each one is going to have different use effects, React is not happy because it would have different registrations. So the way to solve it is to move every action hook or every effect or every custom hooks or React hooks, sorry, like every React hook, instead of having them with different directions, we define them all above. Like basically we define them before any if conditions that could happen. And this is basically TypeScript is saving us. Okay, so we can define them as functions. So the first one on task changed. So we just define them before the if. So on task changed, and we can pass it here. And we can say value is equal to string. And also, and it's also like it's cleaner as well. On done changed. This also changed. Jumped again. Okay, let's go up. Yes. So const on done change is equal to the second callback. And for the third one, on description changed. Let's also define it here. Const on description change description. Okay, let's use it here. Let's do also for the canvas as well. Const on and the nodes changed. Let's use it. And let's define type for each value remaining. So it's type string. Yeah, now it is working. And also we need it for the drawer as well. So yeah, we can do like multiple changes in this case because the drawer is opened or closed. So actually we can have all of this outside. So instead of having the edit to do on this level, we can add it inside the drawer. So we can have another state for the app state, and we can have open drawer as another state, and we define it here as Boolean, and it starts with false. And we also define it here for the state, start with false. And we can have it inside the with drawer here instead. So instead of returning only a normal div, we can remove all of this. And now with drawer has more value because it also has some logic. So we can get access to app state, and we have access to useContext app state, and we can define it here. So app state dot open drawer. If it's true, then return what's inside. If it's false, return null. Let's save, and now it's cleans things up. And we can have it inside the to-do container. So when on edit clicked, we set app state for edit to do ID, and also the other variable, the drawer, it is open drawer. Yeah, we can call it actually is drawer open. This would be better value, and we set it to true. Let's rename the value for app state. So is drawer open, And lastly is drawer open. So when it opens, we set it to true. And lastly, I guess here as well, yeah, for type for the dispatcher. TypeScript is very nice to catch all of these errors. So we are setting edit to do and also is drawer open. And now EditContainer doesn't care about opening and closing, but rather it only cares about the edit to do ID, which is much cleaner, doesn't need to care about it. But when it is done, it is going to reset edit to do to -1 and is drawer open to false. And let's remove this one. Yeah. And yeah, this was the last one. For the drawer, we have set the incorrect one. Is drawer open. Now let's try it. It's nice. And we can delete. And everything is working perfectly now. So now everyone has their own purpose in life. So application can set different components. And also TodoContainer just cares about opening and closing and fetching. And EditContainer is just caring about editing. So now everything is cleaner. Lastly, we can also abstract state, like all of the state, to become its own custom hook instead of having it here. So we can create a new custom hook and we can call it useAppState.tsx, and we can define our hooks here. So we can move AppState from here to its own file. And we can also move create context, and we can import our create context function and action from React and dispatch from React. And we can also use this for our useState functions that we are going to create. So it's created. We define it here. So export const use app state, and we can define it as function, and we can export these two. Can export them. Not export, it is return, sorry. And we use useState, and instead of defining them here, we can use AppState instead. And we also need to extract the provider. So we need to extract the provider and use state, all of them, to create a new component or a higher order component. So yeah, it's a mix of custom hooks and higher order components. So we have useState provider, and it is basically going to get a component type element type. It's going to return function eventually, and its type props, component props, going to return it. And we're going to set type for it is type of component. So now everyone is happy. And this one is export const. And we need to import element type. Okay. And we need to get state from here because we're eventually going to wrap it. So we have our app state and set state. Now we need to have our app state provider. And instead of having app state and set state, we can call them state, but let's keep them app state and set state because it's easier. Okay, and what we are going to return, we are going to return, like we said, a function, but we are going to encapsulate it with app state dot provider and value. We're going to pass it as well. Let's close it. And we have here our component, and we pass all props, close it, and then we get our value, which is AppState, and set AppState. And we can now use this directly instead of like doing setState and AppState and everything else. So now it's much cleaner. We can remove this as well. And let's import our AppState provider. And let's clean all of these. Yeah, it's much cleaner. Let's see this error. And I'm guessing we did this one is incorrect. It shouldn't be it shouldn't be a higher order component, but it rather returns directly because all of this is actually not needed. But we need access also to the prop. So instead of like passing component element type, we are going to pass type of ReactNode instead to have it as children. And we can extract it. So we can extract children instead. And we can say internally here, children is of type ReactNode. And then instead of like initiating it, we just pass children instead. And it would be happy because it's not a higher order component. This is a mistake that I did. Okay, now we need also to fix useContext with AppState. We can now have them as custom hooks. So we can have use AppState and we can export it as a method that calls useContext and AppState. And let's export const. And now we can use AppState directly. Let's use this one. Let's do more cleanup. And this is one of the benefits, like we are separating concerns with everything. Okay, and this one as well. Use AppState. Let's remove these. And lastly, for our edit container as well, use AppState. And now we have more abstractions and our app seems to be happy, or it is happy actually. Okay, so everything is working nicely. Now let's commit and start working on the routing system. So git add, git commit, improvements, yeah, using context and memo and callback. So we now have understood use context to share state and memo to save our component from re-rendering with also use callback. Now let's starting with the routing. And with the routing, we would like to create a new container which would host our stats. And we create StatsContainer. And we create our file statscontainer.tsx and also our module.sass file. And we can export it equal to, and we can return dev hello from stats just to be able to reuse it or reuse it to be able to use it, and import classes from statscontainer.module.sass. Okay, and now let's try to use it. And we will start to explain the theory behind the routing system, and then we'll start to implement it. So first part, we need, of course, to import our stats container. And when we import it, we can refresh and we can see it. But eventually we would like to have an if condition, depending on which link we are going to press on it. And we will start to show either this part or we are going to show the stats container. And all of this would depend on window.location value. path's name as well. So we can get the path name, and from there we can start to, oh, we are in this page or the other page. So let's go and start add links as well. So let's go to the header, and we can start add URL is equal to about, and stats is equal to stats route. And since this would be root, so we can have the root one. And also this one would be the root URL. And we can have the about at the end because we'll start with stats. And let's refresh. And now each one is doing routing. And we would like, of course, like we said, we can go back here and we can console.log window.location.path name. And from there, we can have the value and can start either show this one or this one. So it would be as simple as storing it maybe in a variable. So const location is equal to window.path. And we can just have if condition here, if the location is equal to slash nothing, like empty or like a start, like the root, we can show these two, TodoContainer, EditTodoContainer. Otherwise, let's show stats. This is one way to do it, and it would work. Yeah, because we need to remove the second one. So we only see home, we can see stats here as well. So it works, but of course this is not great. So we can have that if location starts with slash, we show TodoContainer and EditContainer, and we can close this one, and we can have another condition that if location is equal to slash stats, then we show stats, and we can have it with triple equal, and it will do the same thing. But now we need to do more improvement. All of this is just to understand the concept behind React Router before using React Router, but just to understand it. So what you see is that every time when we click, we do a full re-render for the page, and we don't want to do that. We would like to have a smooth transition. So what we can do is to hijack every link on the page and remove its default behavior, which is transitioning between one page to the other. And we can start using the window history API. And basically the window history API is just a stack where we are pushing a certain state, and when we go back and forward, it is going to either push a state or it's going to put the state back again to the stack. So basically it's just a stack, and it adds states and removes states. And before we can just like remove this console log because it's a little bit annoying. So we have a console log here. Let's just remove it. And yeah, this would be fine. So let's start exploring the window history. So what we need is we have a useEffect on the app because it would be something global, and we can hijack every element. So query selector all, and we can take every link and we add an event, not an event. First we get the element, and we can add first take the element and prevent defaults. Not prevent defaults. First thing, we need to add an event listener for every link, and we add a click event listener. We get access to the event, and for now I'm just going to have it as any, because all of this we are going to remove eventually, but just to make it easier. An event, and we have prevent defaults. Maybe if I remove the any would work. Yeah, it works. Yeah, autofills it. Nice. So we first prevent defaults. So if we open and we try to click, you can see it doesn't do any refreshes. Second part, after we hijacked every event, we would like to add it to the stack of the history. So we access window.history.pushState. And basically push state is just adding some values in the stack of the history. So it's similar when you go back, you go forward, it's just a stack and you're transitioning between each part of it. And first part, we can add data. Second part, we can add some strings and so on, but we don't need to care about it. But the last part is the URL, which is the more important part. And we can add this one from event. And remember, this is a link. So we have access to target and we have access to the href. And we can rename, add the type for it, for target, and it's HTML anchor element. And we can take all of this and we can const link just to keep it. And we can push this one to our state every time when we click. So if I refresh and if I click on any one of them, you would see URL up here is it changing for each click. And if I click back and forward, it is going to change it. But you notice that when I click about 3 times or multiple times, each time when I go back, it's still about, because it always adding the same state. So we need to differentiate that. If the current state is the same as the link I clicked on, please don't add it to the state or to the queue. So it's very simple. We just can create some variable in our data for the states that we push, and we can say maybe the name is path. You can name it path link. All of this is fine, but we just add link. And before we push, we check if window.history.state, which is the current state, dot path link is equal to my link, then please don't push it. So we can just change it from triple equal to negative. So if it's not equal to it, then yeah, it's fine to push it. And let's now refresh. Let's go to home and let's refresh. And if we go to state, if we go to about, and if we go back and forward, it is fine. But you can notice that when we click on state, React is not behaving to it, because window.state that we already fetched the first time, this is the first value. But we need to also change it. We need to change this value each time we change the history, which means we need to change location from a normal variable to become a React state. So we can have location and set location is equal to useState. And we set the initial value as the current window path name. And we can change it when we click on an event, like we click on a link, and when we click back and forward, and we will do both of them. So the first part for the link is as easy as when we click and we need to push some state, we can set location and we can set it to become the new link. So this one would work. So if I refresh, if I go to home, it is, yes, we need also to change this one. Yeah, it has changed it. So let's refresh. So this is home. And when we click on another link, it would show stats. Okay, I added some punch of console log. And of course, like anchor is returning the whole URL, but rather we don't need the whole URL, we just need the slashes. So instead of pushing the link, like one from the href, we can push window.location instead. So we can add window.location.path name. And it would be fine for link, because we are using this as an attribute just to make sure that we are on the, like we are not transitioning into multiple pages. Okay, let's try it now. And it looks fine. If I go back, of course, like going back and forward doesn't work. Like we said, we are going to add listener for it. So we need to add a listener, and it would be window.add event listener. And this value, it is called pop state. So we will listen on pop state, where if any value inside the history queue is going to change, we need to do a certain action. And it's just as easy as we are getting the event. And in our case, event.target would be actually the window element. And we just need to get access to location dot path name to get access to the current one. And we need to update our React state. So when we do this, we cancel all of this. And let's now try to do it. So hello and state. If I go back with the mouse, it also works. I'm going back and forward with my mouse. Okay. So all of this is some manual work, but we don't want to do this because eventually in the future, we would like to also have SSR and we would like to have like also like multiple features inside routing system. And we don't want to do all of this manual work. That's why we are going to use React Router. So instead of doing all of this, we are going to remove it. And let's actually like commit it. So git add, git commit, use location history. And yeah, we be fine to delete it. Just I wanted to keep it for references. Okay. And yeah, we can also move this and this and yeah, now we have more cleaner one. Okay, let's now install our React router. So it would be installing two packages. So npm install React router and React router DOM. And it would take a minute to install. And it is done. And now we can start using it. And it's actually very simple. First, for React router, we need to understand few things or few types of routing that exist in it. So let's go to React router and homepage. And you would see here there are multiple types of routing inside React router. The first one is the browser router. And this is a normal browser router that you see here. That's the ones that we are using. Like going with links back and forward, similar to what we did. The second one is hash router, and this was in the old days before the history API was invented. People would use hash at the end, and then they would add different values to say, okay, we are in this location, on the other location, but all of them start with the index.html. Because at that time, there weren't any ability to have like multiple like slashes and links and so on, or maybe the idea didn't exist. And it would be very famous with AngularJS because at the time it didn't exist. Second one is memory router, and this is stored in the memory. You don't have any access to it, but it's less recommended to use here in the browser because you would like to keep the state of the page in the link, not inside memory. And memory would be useful during writing unit tests, for example, because we don't care about the router in the window. But in memory, yeah, it would be beneficial there. And there would be the last one, which we are going also to discuss at the end. It's the static router, which we are going to discuss for server-side rendering. And by the way, we can use these routers as functions. Like these are actually can be used as functions like this. You can define the router and then you pass it to the router provider. Same idea, by the way, like the context provider. This is one way. The other way, we can use them as GSX. And it is preferable to use it as GSX because it's easy and also to have like an idea with the static router when we are going to implement it. So we are going to use a browser router. So let's go back here into our application and we can define, we would like to use a browser router. And when we define it, we need to define inside different routes. So first we say we would like to have our routes, and then we can define each route, and each route would have link for it and also which component you would like to load. So let's just keep our components here just to not forget them. And let's import routes and import single route. And we can define it. So first part is the path, which path you would like to go to. We would like to go to the root path, and then we can define element. And for element, we would like to use our TodoContainer, but we would like both of them. So EditTodoContainer and TodoContainer, and we can add them in anonymous, like in a React fragment. And second part we can define route path, and we can say for stats we would like certain element, and this element would be our stats container. We can close this one, and let's also create our about container. So I'm just going to create new and about container. Yeah, I created file instead, so I delete it, and we go back to our container, new folder, about container, and we need our tsx and also our module.sass, and again let's export const about container, and we define it as about page, and we also import our classes. So import classes from about container dot module dot sass. Okay, and now we can use it here. So we can define our stat, and instead of stats we use about and about container. And let's check them now. Let's refresh. Let's go to stats, about, and home. Let's build our stats page, and we are going to go to our stats page or stats container. Let's first close everything, and we can quickly build it. And this will be like as simple as reviewing few stuffs. So the first part, I'm just going to copy and paste some styles because we are going to need them, and I'm going to explain every style, of course, that we are going to do. And the first part you would like to have a container div, and we can have an h2, and we can say it has stats title, and we can have two divs because we would like to have two columns, and each column is going to have list of different stats like done and not done. So the first part, we would have a normal list, and we can have a list that we call to do, and here there would be a UI or unordered list, and there would be different lists like to do 1 and to do 2 and so on. And it would be for the second one as well, there would be also not done. Okay, and we would like to, of course, add our index because we would like to use our service, like to do services. So we would have our index, and we are going to import stats, or we can directly export default with dependency, and we can pass here our dependencies that we would like to pass. This was the first part, right? No, the first one is a component. Okay, so the first one is a component, so we would have our stats container, and second one would be our dependencies. So we would have to do service, and we will import it from dependencies.todoService, and we now inject it there, and we need to update our app.tsx. So instead of importing our stats container like this, we will import the default, and we would now have our to do service, and we need to define our TypeScript. So mostly this part is a review, like review of what we have done, but we are doing it a little bit quick. So we define our types, and we have our to do service, and it is of type to do service. Now we have it. We would have a useEffect, and it would run at first. So we'd add an empty array, and here inside it would have our to do service, get all to dos, and we would have our then, and from then we get list of to dos, and we need to set it inside a state, so we need to define a state. So const todos and set todos. And this is going to use state to be a first set empty array, and it's of type todo. And we import the model and we define it as an array. And after we define it, we set it from when we import it. And we can console log it just to make sure we have everything working. So let's refresh and go to stats, and it looks like it is working here. So this is looking good so far. So we need to get two arrays. First one is for done, todos done, and we are going to filter on todos. So todos dot filter, and we would like to extract is done from it. Let's check out. It's yep, it is done. It should be named done, but I need to add this also is another bracket so I can extract property. Yep, now it's correct. So the first one is when it is done, and for second one, which is not to do, not done. And this would be the opposite. And instead of having a UI, we can list them. So you have access to our to-do, and we would like to just return its name. So we replace this one with task, and we can do it as well for our UI. UL is the other one for not done. And we replace this one with not done, and we would like also to show our length. So we show it here. So add a bracket, and then we add the other bracket curly braces, and we get to do done, and we get length, and we do the same but for the other type, which is not done. Okay, let's check it out. So far look good. It requires a key, so we have access to our ID. We can get it from todo.id, and we can do it as well for the other item. Let's refresh, and looking good. So like you see, it's pretty fast. One way that I would also note here is that we already fetch to-dos here, and we also refetching them here. There is other libraries, for example, like React Query or JS Data that already could store these type of fetching. So you only fetch it once. You don't need to fetch it twice in the API. So this is something you can use instead of using the fetch or the library that we implemented, and you would only need to change it inside the HttpAdapter. So instead of the HttpAdapter, you would use, for example, jQuery adapter, and you can replace both of them whenever it's needed. Okay, now let's add the styles. So let's close all of these, and let's go to stat modules. And we have first stat border, flex, and we have some margin, basically to make all on the same level. So we have class name, and we have classes dot stats board container. So now they should be on the same level, but not the title as well. So we need pose list. So every one of them is like a column that we are going to have. So we need to wrap everything actually in another div, and we can apply our class again. So we have classes dot stats board container, and then let's check it out as well. So now post on the same line, and we need to apply style for every board. So we are going to use stats board, and it's going to have also a title and also UI and LI. And title would have some padding, and title is just going to change font size, making it some bold, add some margin button. And for each unordered list, it is going to remove some of the like the dots and padding and margin. And for the each list item, it is going to add some background color, some border, some shadow, some padding, and some margin. So it is just simple styling. So we're going to define our board, and then we are going to define for each title their border, board title. So we copy and paste. And yeah, that was pretty fast. This one is done pretty fast. So we already have our stats board. Let's also do our about page. And for the about page, we are going to use or to do something different. We're actually going to integrate with a third-party library, and we're going to use Markdown. So Markdown, yeah, I guess you already have an idea what Markdown is. So basically, like we have some Markdown, and we would like to insert it into a library using asynchronous loading, and it is going to transfer them from Markdown to HTML. There is a library that we are going to use already. It is called React Markdown. Surprise. And it is going to do this Markdown transfer from normal Markdown to React. And it's basically integrating with another library, Markdown library, which is doing this transformation using regex. But we are going to use this library directly. So we npm install React Markdown, and it's going to install, and it is done super fast. And we already created, of course, the file about.md. I did it just pretty fast, but it's just like a small file, and it just have little content. And what we would like is to pass this content to AboutContainer, similar to what Gatsby, for example, is doing. And instead of returning our div, we would open it, and we return React Markdown, and all what we have to do is to pass a string here. This is all what it needs to be. So at first, I'm going to show a small example. So we add, for example, here a constant called content, and we define content as like an H2 title. So let's save it. Let's open it. Let's open about page, and let's refresh, and we have our title as H2 with the styles that we already defined in our library. Now we need to replace the content with Markdown. So instead of having text here, we would like to replace it with Markdown. And basically what we need to do, we would like to import our about.md file. But you will notice that because of the internals of Webpack, we cannot say, okay, we would like to fetch, because basically we are going to do a fetch API call. We cannot do a fetch API call to about.amd because Webpack eventually is going to like bundle this file and add some hashes to it and build it during our build process. And it's going to have like its own separate file. So we don't know what is the link for this file. We have no idea what is like the hash for about.amd, because you don't need to think of it as text file, although like we can open it inside VS Code, but rather you can think of it as an image. So we need first to be able to import it to get access to the link, and then we can fetch it. So we can do both these two things. So we can actually do an import, and we can say about text, and this is one of the beauties of Webpack. And if you would like to get more details or get more advanced in Webpack, there would be a link for a course for Webpack. It would appear like up here. You could check the course later. And we just import about.amd. And TypeScript here would complain because it doesn't know what is the type of AMD files are. So we need to just create a global declaration for Markdown files. So we create a new file, just a temporary fast thing, but because it's a simple thing. So we are going to create a new file, and we call it types.d.ts, and we can declare module here. So we can declare module, and we can say this every Markdown file, and it is going to have const value of string. They want to have one of the properties, and it is going to export defaulted. So export default value. Okay. And now we can try to console log it. Let's check back. Yes, the error now disappeared. And we can console.log the file. So we have access to the link, and you see there is a hash here. So that's good. And we can just now do a normal fetch. So we can do a useEffect, and we can do fetch for our file. So we can fetch it, and we say we would like to import the file with the name for it, and then we can have .then, and let's get access to the content, and let's console.log content to make sure that it is imported, and let's also make sure that is only during first mount. Okay, let's check it out. So we see the content, and basically to be able to read the file, we need to invoke a method called .text over the content or the response, and let's refresh, and there would be the result here. So we need to just invoke text and then invoke our promise to get access to the content. So we do .text. Because this is a stream, this is like a readable stream, so we need to resolve all of it. And streams are like a total different thing. So we can do content again. For the first one, actually, we can call it response. And second one, we can call it content. And let's finally do console.log content. Let's refresh, and now we can see the content. Okay, so let's even do our promises in a better way because we are doing weird chaining, which I don't like. So what we can do is to take this then outside, and we can directly return text. So you would see like it's similar to JSON, but instead of .json, there is .text. And we chain it with the other then. And now we have the first then, and then we have the second then. So instead of like .json, we have .text. Okay, and eventually we need to store it inside our state. So we create const content, set content, and it is going to be a useState, and it is going to be an empty string at first. And we can then set our content. Let's remove this one, and we can set content. Let's check it out, and yep, we can see it, which is working. Okay, let's now discuss some code splitting. But before we discuss code splitting, we need to fix the pages, because if we check the network, you would see that every click, it is doing a full or hard refresh, like how we call it. So we need to fix it. And basically we need just to go to our header link, and instead of the A tag, we would use the link tag from React Router. This should have been recorded first, like when we were talking about the React Router. And instead of the href, we call to. And yes, we need to define to as well, because URL can be not passed. So let's make URL as a required property. And it broke. And this is mainly because we are using probably React Router. Yeah, we have the header outside the browser router, and basically we need it to be inside it here. So we can add it, and it would have access to the same context. But now we see our pages is broken, so we need also to move the div or the pages styles as well inside. So let's add our div here, and also we add our div at the end here. Okay, looks nice. And let's check our network tab, and now there is no longer hard refresh, so it is doing soft refreshes, which is better. Okay, and now we would like to discuss code splitting. So as you can see here, we are importing the whole file, and of course it is simple, it's just 300 bytes. But when you have an actual application, it would be in couple of kilobytes or even megabytes, the whole application, and it is not well optimized. And we would rather split the code, so we would have only what we need. So only what we need would appear, and the others wouldn't appear. They would be imported whenever we would need them instead of importing everything. And actually, it is very simple. And this concept of code splitting is not something inside React per se, although like we are going to discuss React Lazy and React Suspense, but it is rather something inside Webpack, or actually inside the HTML API documentation, which is called import ES modules. And you could find it here, import ES modules, and you can check it on MD Mozilla, and there is a normal import and there is the dynamically import function. And basically Webpack is going to use this import, and it is going to do the code splitting and adding hashes and doing bunch of stuff. But in either cases, how we can use this concept? So basically you write import but as a function, and you would pass the link for it. Like we would like, for example, we would like to do code splitting for TodoContainer, and you would pass directly the name for the file itself, similar to what we import. So this would do two things. It's going to import the file and it's going to import the content for it. And you can chain it within, and from it you would have access to a module, and inside the module there is module.default, and it would be exactly what this default for this module is exporting. So this brings the idea that we can change TodoContainer to become asynchronous. So let's do it internally here. So we can define const async TodoContainer, and it would be a normal component. It would be just a component, but instead of returning TodoContainer directly, we would return a component at first as an empty, and then when this component loads, we will fetch the content of this file and replace the temporary component with the original component. All of this is to help you understand how React Lazy and Suspense is working, because it's the same concept. So what we are going to do, we are going to define a state, and we call const, and we would have our component, and we can set component, and it is going to use state, and we define it first as an empty component that is going to return null, like it's a function that is going to return nothing, or we can make it to return loading. So we can do this, and instead of doing the normal import like this, we will do it inside a useEffect. So when useEffect is loaded or the component is loaded, we need to set this component with the content of the default of this file, and eventually we are going to return the component as a element. So basically here we are going to invoke it, and first it is going to be loading, and then when it is done, it is going to replace it with the default of the module. So we don't need to chain it, but rather when it is going to return it, we are just going to set component with the content default, and that's it. So this is how asynchronous is going to do. Basically, first we have like an internal state to set the component, and we return it first with loading state, and this is like a temporary component that is used as a state. And eventually, when we get the content, we get the default and set it as component. And instead of having our todo container, we can now have our async todo container. And this would complain a little, so we just have as any for the time being, because eventually all of this we don't need. And we can remove this. This would be fine, because we would like to reduce the file size. And now let's refresh. And if we go to our network tab, you would see, of course, like the bundle size wouldn't be reduced because this is a very small file, But if you try to open it and try to search for TodoContainer, you would see it is just doing the import. It wouldn't import the actual component itself. So if you see it here, there would be the first, like some JSX for some injections and some files, but it wouldn't import the file itself, like the container itself. So even we can try to check for something that was inside, like maybe the word done, maybe. Let's check if it exists. And there is zero existence for it. And even if we try to single word, so it doesn't exist in this file. So this is good. Now, if we try to go to our home page, you would see that it would create a new request and load this component, or where is it? Inside the app. It's going to load and it's going to import the file. So let's go to our home page. And let's check the reason for it. And I am thinking it is just because, yeah, at first I thought it would import the component and we need to create a JSX node from it, but actually this is directly the node. So we can just return it. Let's refresh. And now it is working nicely. Let's check the network tab. And if we go to our stats page, you would see that it's not imported. And when we go to our home page, you would see now there is a new file, source containers, TodoContainer, and now this would have our not done. So it would exist in this file. And now it is splitting our code. So this is the whole concept behind code splitting. But instead of doing it like this, we can actually create an async element. So we can create it as an HOC. So we can replace all of this and we can have here import function. And import function, we just run it and we pass then. So we can add as any, and not as any, sorry. We define type as any and this as any, just temporary because all of this we don't need it. And we can now use it. So we would have const async to do container is equal to async, and we can pass our import as a function, and we just invoke it and it's going to invoke it, return it, and do what we have done already. So we need to go to our containers and to do container, and it will do the exact same thing. Probably there would be an error because we are returning the component and firing the function at first, but we don't want to do that. We actually would like to create a higher order component. So we are going to do a return, and we are going to return, we are going to return a function that is going to return a function. But useState is going to complain because it says we cannot return an async function inside a component because it thinks this is as a component, and to fix this, we just need to call with async. So now it becomes a higher order component. And if we save it, now it would work. And if we check the link, we see each one of them is imported asynchronously. And we can replace now each one. So we have also stats and edit, and also about page. So we have edit to do, and it would be edit container. I hope we have it. Probably yes. And we can name this one async edit to do container, and we use it. And let's also do for stats and about here, and we'll call them async as well. So async stats container here and async about, and let's replace this one with stats container, and the last one with about container. And I think about container doesn't have an index.html, so we need to create it. Not index.html, index.tsx. And we can be as simple as export default about container, because we don't have any dependencies. And we can remove all of these. So now they are imported asynchronously. Let's check. And yeah, it's still not getting lower, but yeah, of course, like there is no content for it. And let's check when we go to another, like stats page, we import the stats container. And for the about page, probably there is an issue. Let's check it out. Okay, I spent some time and I actually think this is very interesting to understand. So when we check the errors here, we see that even if we try to edit, it doesn't work. And the first part, it would go like too many errors, like as if it's an infinite loop. And I will just like open it again. And the main problem is that for the use effect, when we define it, we forgot to add this empty array. This was the first error. But when we still try to open the edit, it wouldn't work. And the problem is that when React renders the first time, so it didn't subscribe or register all the hooks. So basically, when React first, like you have your component here, and this is new. You would have your component here, and you would have bunch of hooks inside. So you would have useEffect, useState, and so on. So first React would run the function, and it would register these hooks and make sure that, okay, we have a useEffect at first, we have a useState here, and so on and so on. And eventually you would have the return that is going to return your tree, like the different divs eventually. But when we build this component, first run, it would return, yes, this is correct. It would create the component and create a state for it. It would have a use effect, but the first time it is going to return a component, like this anonymous component, like this inner component, it is going to return with loading, and this one doesn't have any hooks inside it. And the other component, this one, like for example, this is going to be our TodoContainer and so on, is going to have multiple hooks inside it, of course, because you have useState, useContext, and so on and so on. So basically, we need to return, instead of returning a component, we need to return anonymous component, and we have an if condition, and would say with if condition, is the item is loaded? So we take the first direction. If the item is not loaded, we take the other direction. So basically, we'd have like an if else. And in this case, we would have like two trees, like two different trees. The first one would be when we are first having our loading text. Like this would be our separate loading text. And this would be now like when we do it with an if condition and we have this anonymous function, React would have a separate tree for loading and a separate tree for component. But at the current one that we did, both of them were component, like both of them were in the same tree. So we need to fix this one. So let's go and try to fix it. And the first part would be have a separate component for loading. So let's also do Control Z to make sure that, yeah, this is a current state. It's just like the pen moved away. So, okay, so we would have here const loading state. And this would be just a normal React component. And it's going to return loading dev. And instead of having like we have like our component, we would keep it, but instead of having a certain component, we would have null. This would be the first thing. And second thing, we would have is loading and set is loading. This is where we're going to create our branching. So we'd have two separate trees, and React would make sure, yes, these are two separate components. It first returns null, but now it returns a certain value. And we set it to false. And we say if is loading, please return the loading state or loading component. We can keep it like loading like this. This would be better. So now this is the first tree, and second tree would be like if loading is false, it is going to return a component. So we need to change this to become a function. And now we can run component here. And this should be fine. And probably this is an extra function. We just need to remove it. Okay, and we need to do set loading after the component has been set. So we set it to true, and let's save. Let's refresh. Let's check again. It's a difference. First, it is loading, true. And when it is done loading, it's set to false. And now we have 0 errors. And for a split of a second, you see like the true loading at first. And let's do the network and do some throttling and do slow 3G, and let's refresh. Yes, it will take a while. It first loads a bundle and we see the loading. And after it is done, it is now importing every part and everything is super nice. And if we go to the states, stats is going to do loading, and then this is going to do the imports. Okay, now let's remove the throttling. And all of this is just to understand internally how React Lazy and React Suspense is working, because all of this is done with React, but just to understand internally. So it's the same concept. You would have a sync function, and it is called React Lazy. And you would have your async component, but instead of running your component like this, we would wrap it around Suspense React. And that's it. Now it's suspensed. And it would be the same concept, exactly. Nothing different. So React Lazy internally, same concept like this. So we can just replace with async with React Lazy. And we do each one of them. And we can remove all of this. We can even keep the loading because we can reuse it. Okay, so we have Suspense, but we need also to change it for the rest to make sure they are working as well. So we need to wrap each one of them around Suspense. So we have async, and we have also async about. So now they are working, exactly same concept. And for Suspense to have the loading component, we can path it as well as fallback property. And we just pass it. And that's it. Let's do it for the others. And yeah, you see also the loading appears for a flash of a second. And as you can see, this can be reused because it doesn't make sense to add like suspense loading, suspense loading, suspense loading. We can change all of this to become a higher order function, and we can call it with suspense.tsx. And it is going to do the same thing. So we would have const with suspense. And let's also do the ones that we did with sync, or it doesn't matter. It doesn't matter. So export const with suspense. And this is going to be higher order function. Again, you see like higher order function is very highly used here inside React. And also in Vue.js, it is called composition API. And we are going to have also a just enough Vue.js coming up soon. So we would have our loading element, and we can cut and copy here. And you can replace this loading with a spinner. So just giving ideas. And we have our React, and we have our component async function, and we can call it component function. This is not nice. Let's or component import function or callback. All of them are fine. And we can use it here. So we have component async is equal to react.lazy, and we pass our async function here. Not async function, sorry, but rather async import function. And we can eventually call our component here. And lastly, we take with suspense, and we can replace each one of these directly. So now we just pass the import function directly, and we import with suspense. And now we don't need with suspense anymore. And the only difference is that with suspense would return component, so we can call it directly here instead. I think, second. Yep, this is correct. We replace these ones, and lastly, this would be a fragment, and we return both other component, and we remove this extra piece of code. And lastly, we can just add any type temporarily just to make sure it is working. And as you can see, it is working nicely. Let's now define the type for it. And we can define it as type like here, like with an I, or type, callback type. And we can have our type here, and it's basically going to be a function that is going to return a promise, and it is going to be of type, it would have type default, and it would be component type, and we can say it is of any component type. Let's import from React, and everyone is happy. Okay, so we now also discussed in details how code splitting is working, and how also it's implemented, and how we can implement it with React Lazy and React Suspense. Let's do one last change because I don't like this dev, and we can actually move it into component, or we can also do it in a hierarchy component, but the component would be fine. So let's create a new component, and we can call it page layout, and let's create our component tsx, and this would be fine. It doesn't, like, we don't care about the other style part. It's fine to have an inner style. And let's copy, and let's go back to our page layout, export const page layout, and it's going to have children, and it is going to return children inside, and it's going to return we close the div, and we extract our children, and we define just inline children is of ReactNode, and we go back and use it inside the app. We close the tag, and we import file. Make sure everything is working. Nice. Let's now commit and save all what we have done so far. So git add, git commit, use React router, and code splitting. Each one of them is a certain feature, should be in a separate commit. And now we will discuss SSR, server-side rendering using React. And server-side rendering is actually the first technology that exists before client-side rendering. So server-side rendering is not something like very high advanced or something. Of course, it's relatively advanced in realm of React when you are using it, but it's actually not something new. It has been very, very old. So far, what we have been using client-side rendering. Basically, the server would send just a very small index.html file in our case here, and then would attach all the JavaScript files that are needed. And then it would send back the whole JavaScript file, and it would contain how to build the DOM, how to add elements, how to add reactivity to them, and everything. And the browser would build everything. So it has to execute the whole JavaScript to build everything. So it is, of course, like yes, it is has a lot of reactivity. It makes us easy. It makes it easy to write JavaScript and state management and all of this, but it would take some time to load an application. So there is longer time to load our app using our client-side rendering. And before the existence of client-side rendering, before the existence of React, jQuery, all this JavaScript stuff, there was PHP. And PHP is the first, I wouldn't say like the first, but probably the most famous server-side renderer. Even if you don't like PHP, it is, I like PHP. It is very famous and very strong. And you can see it is actually like very, very old from the 90s. Okay. And all of the PHP stuff, you would write code on the back end to inject variables, do for loops, and everything you can imagine in JavaScript, but it would render on the server and then send to the client pure PHP, pure HTML, just pure HTML, and just the browser would render it, so it's very fast. Of course, if you're using WordPress, it takes some time, but we wouldn't go to this. But using just server-side rendering, you just render it and maybe cache it as well. It would be instantaneous to be sent back to the browser. So this is the benefit of it. It is very fast, faster than sending JavaScript to the client. And this is a big benefit for SEO. So for example, if you are building a blog or a e-commerce website or a website for a company or something, and they need faster SEO, you would need server-side rendering. You cannot only rely on client-side rendering. This is the first point. Second point, like we said, you have to send the whole JavaScript file, so the whole app would have to wait until the whole JavaScript is loaded and then build the application. So there is a lot of time. And if you would like to see it, you can go to your settings in the DevTools. And if you go down, you will be able to disable JavaScript. And if we refresh our application, you would see that it stops working. Although, like, of course, like most browsers or anyone would have JavaScript enabled, but this would show to you if when JavaScript is still not running until your whole JavaScript is loaded, your application would be like this. It's a little bit weird. So it would take some time. It would hurt you in the SEOs, and SEOs are like another realm on its own. So we need to have faster loading. This is a selling point of server-side rendering. You just need faster load. This is the only selling point. There are other benefits, but this is the biggest thing that I saw so far regarding server-side rendering. And the idea is that we would like to build our HTML and send it back to our application. And why we are like when we are using JavaScript, the biggest thing to build our server is a Node.js. So basically, we are going to build a Node.js server that is first going to send just simple HTML stuff, and then we find how to do server-side rendering for React to send it back to the browser. And to create our simple SSR server that is going to render HTML, not HTML, it's going to render JavaScript or our React at the end and then send it back to our frontend. So we can just create our node server and we can call it SSR server, so SSR underscore server.js, and I'm creating under the server directory that we have here. And then we just use Express. So we need to import it. So require Express. And we need to create a new app. So we'll call it Express function. And for this app, we are going to listen on a different port, and we listen on port 3004, because 3000 we are using it for normal React that we have at the moment, and 3001 we are using it for our node server. And node server is a normal node server that has just normal APIs. And maybe we can also close our node, just to close this one. This is our create React app function that is running, so we just need to stop it. Okay, let's get back to our Express. So we're listening on port 3004, and then we just print a new console log server started. And for our endpoints, for our Express app, we will just listen at the root directory or the root endpoint, and we are going to return a simple hello world rendered on Node.js. So we have our request, we have our response, and then we are going to respond with hello world. Hello world, yeah, it's fine. And then we start our SSR. So I would like to add a new script. So we have our start, but now we are going to have, we have start server. We can have also start server SSR, and we are going to have nodemon, and we are listening to SSR server, and we can run it. So we create a new terminal and npm run start server SSR. Let's run it, and let's go to localhost 4000, and it's working. So basically it would respond with a normal text, and it says hello world. So this is the first part. Now we need to continue, and let's also close the others just to keep everything clean. So at the moment we are simply sending a normal string. We would like to now start sending some React components. And so far, the tutorials that I have seen, they are using JSX inside Node.js. It is fine, but I don't like it, or I don't like the idea of it. I would prefer that we build our React application as a normal JavaScript, and then send it to our Node.js server to build it. So in this case, we have separation between our Node server and also our application. So the frontend team would build the app and then deploy it somewhere, like maybe on an S3 bucket or something. And our Node server is on the backend team. They are building it on its own, and they are deploying it separately. So we are separating both worlds. We don't have both of them in the same file. Of course, this could be beneficial for some cases, but for our case, we would build the front end separate from the server. So we would like to be able to create first, we would like to be able to create React components, just simple React components here, and send it to the front end or the browser. And how we can build React components inside our JavaScript file. Of course, we can add Babel and then have Node.js transpiled through Babel, and then Node.js would run it. We wouldn't do that. We would use the default create element function that React has. And since React is just JavaScript, you can actually import it. So we can React require from React. This is possible. And from it, we can do our create element function. So React.create element instead of using JSX, because we can use JSX here, but for our case, we don't need to. We don't need to have Babel as well, like transpiling, because this is another layer to transpile. We would like to just read the file and render it and just send it immediately. So we don't have too much constraint on our server. So like always transpiling and sending it. So no, it would take some time. Okay, so basically we would like to create element, and we can create an h1 element, and we are going to have no props. And for our children, we could have just maybe a normal string, and we say hello from React. And React create elements. This is how JSX is being transpiled at the end to this method. Like every element that we have here inside, like about or something, every JSX element eventually is transpiled to create React element. So we don't need Babel to do all of this. So this part is going to return a React component. So we can have const is equal to, and we can say this is our app, and it is going to return React create element. Instead of like having it in JSX, we are just having it inside our create element. And similar when we had index.tsx, you remember we had React DOM and we had create root for it to attach our React tree to the DOM and render it to DOM element. We also have React server. So this one is called different. We call it React DOM server. Of course, like this variable could have any name, but if you check when we imported React DOM, we are importing it from React DOM client. We now import this one from React DOM server. And now we have our server renderer. And we can, at the end, have our React DOM server. And then there are multiple ways to render to the browser. So you could have streams if you would like to send it as streams, but at the moment we're just sending it as strings. So there is render to string. And if you would like full read about it, it's exists here under React DOM server. And there is a way to send it as streams. And of course, streams is better, it's faster, and it is more, yeah, it's faster in general. Okay, so, but anyway, everyone would eventually take our component, which would be our case, our app. And the output would be HTML, lovely old HTML. And we can send it now instead of our hello world string. And it should eventually render all of this, change it to string, and send it to our browser. And I think we lastly need to execute it because this is like just creating our element. And you remember when we used our node, we need to eventually like execute it as ReactNode so we can execute the function and it will do the same thing. Now we refresh and it returns our h1 element and it says hello from React. And of course, you could have an array inside and React create element. And you could have maybe inside it some div and there is no props. Of course, you could add props, but just to prove another point. And let's check it out. Let's refresh and we see it's another point. And of course, it's under h1 element. So let's check. And you can see h1 and there is a div. I don't know this weird structure, but yeah, we just wanted to prove the point that we could change React components to become normal strings. So we would like now to change our whole app to become inside our Node.js. And to do all of this, we need to use different structure for Webpack because what exists at the moment inside create React element is not sufficient. So we need to build our Webpack bundler. And again, if you would like more details about Webpack, there would be link again also for the Webpack course. You can check it out later. Okay, so let's start creating our Webpack configuration and it would be pretty simple. Basically at the end, we would like to get our application, but the only difference, we would like to extract this browser router because we are not using the browser router. We are going to use the server router instead to be able to render the exact or the correct route we would like on the front end. This is the first point. Second point, we are not going to use a normal renderer from React. We would like to use our render server eventually. So we don't actually need all of this. We just need to extract our application. And instead of using browser router, we are going to use server router instead. So let's first create maybe our server side application and we can add it under SSR, maybe like another directory. And we can have our app under SSR. So we would have tsx, and this would be fine. And we are going to create our version for our SSR app. So eventually we would like to, of course, like export SSR app, multiple SSRs, very high case. Maybe we have it like this. This would be fine. And we are going to build our app, but in this case, we are going to export different app. So we are going to return our application at the end. And let's go to our app tsx, and we would like just to extract this browser router away from our normal app, just to separate our application using browser router from our applications that is going to use server router, just to have them in different places. And we just move this browser router to become here. So it would be on a top level. And we just import it. And we can remove it from here. And actually there are quite few things that can be removed. Let's remove all of this. And we are going to, like we said, going to return our app. And let's import it. And this would be export const SSR. But instead of using browser router for SSR, we are going to use static router. And this is basically our server side render. So it is called static router. And we encapsulate our application inside it. And we need to import it, of course. So import static router from React router. And /server, just to make sure we are importing it correctly. And you would see an error because you can imagine in the browser, it makes it easy because you need to load the whole JavaScript and then it would know which location you are in or which path name you are in. And then it's going to render the correct container. But for the server, we need to send the exact location correctly to our SSR application. So on browser router, it already knows it from the global variable window.location.path name. But for SSR, it doesn't know it. So we need to send it. So we can actually inject it. So we can call path name, and it is of type string. We can inject it inside our component or function in this case. And we can call it here. We can inject it. So location is equal to path name. And now the static router would know from the routers that are already defined inside our application which route it should render. And before we continue, let's check our application is working correctly. So we can localhost. Yes, we stopped it. So let's start it again. npm start, just to make sure while we are doing this SSR thing, we are not destroying our original application. So our efforts are not destroyed. And let's wait until it's load, and our application is still fine. And we see the normal loading thingy. Okay, let's continue. Now we would like to use our Webpack application inside our SSR server, but of course we are using JSX inside our SSR. Maybe also let's name our file SSR app, because it is going to confuse us if we keep it like with the same name. And again, we would like to transform our JSX to use our create element methods. And basically we're just transpiling React. So basically this is just how to create custom configurations to Webpack for React. So we need, of course, to install Webpack. And we're just going to install a bunch of stuff quickly, and I'm going to copy paste them because we would like to make this pretty fast. So we would have our install npm install -- save dev, and we're going to install Webpack because we need our bundler. Of course, you can use Vite. I'm just like, for sake of this part, I'm just going to use Webpack. And we are going to use TS loader to transpile our TypeScript to JavaScript, Sass loader to also transpile our Sass to CSS, and then we are going to use mini CSS extract plugin to take our CSS files to create a separate file to do it, and HTML Webpack plugin to create our index.html file that we need to send, because we cannot send pure JavaScript. We need to send also our index.html at one point, not at first, but at one point we are going to use it. So let's install each one of them. And now we are going to add our Webpack file or Webpack configuration. And let's create a new file and we'll call it webpack.ssr.config.js. And I'm going to copy a bunch of stuff and I'm going to explain each one of them. So I have copied the configurations for Webpack, and let's try to understand each one of these configurations. So the first one is mode. We would like to define we are already in development mode. Of course, when you eventually send this to a production, you would change this to production mode. For DevTools, we define that we are using inline source map because we would like, when our code is eventually transpiled to JavaScript, we would like still be able to see the original code. We would like to be able to see TypeScript inside the browser. So we can also find, if there is bugs, we are able to find where they are. And we are defining our target for Webpack, and it's going to be Node.js, because eventually we are not transpiling this JavaScript file to the browser, but rather we are going to send it to our SSR server to render it. And for our entry, it's simple. We just define which file we would like to load, or our entry point for our file. And each one of these other configurations, I just hit them, but we abstractly say what they mean and then get internally for each one. Resolve, it is going to define the different files that already exist, and Webpack would be loading them with file types, by the way. Like we have TSX and TS and JavaScript files that exist in our application. So we are telling Webpack, hey, we don't need to add .tsx. You just assume it would exist inside our system, so just load it. And then module, we define the different loaders that exist in our system and how it's going to be transpiled. So we have Babel, for example, is going to transpile our JavaScript files from old to modern, from modern to old or backward compatible. We have also TypeScript files. We would like to transpile them to JavaScript. We have also Sass to CSS and so on. And then we define our output files that we are going to send to our front end, not front end, to our SSR, but this would be like the place for our output where it is going to be sent back. We define the different plugins that Webpack is going to have, and externals means that libraries that we don't want to include inside our bundle. And what we don't want to include, we don't want to include React, because if you go to our SSR server file, we already import actually React inside the React DOM server. So basically, if you go to React DOM server through node modules, and then we go to React DOM, and there are many imports. Yes, this would be the one. And we can go to our server and then server node and then legacy node development. This is the one that we're using, and it already imports React. And you will see this weird variables called secret internals don't use or will be fired. Whatever it is, basically these are internal variables that are shared between React and React DOM server. And if you also bundle React again inside your bundle, which eventually is going to be executed as a Node.js, it will cause issues, because React hooks, if you check this website, also I would leave it inside the README for the project, you cannot import two duplicate Reacts. So we will have a React inside the bundle, and we also are going to have React coming from React DOM server. And this is not valid because both Reacts wouldn't equal, because it is going to share this variable internally somewhere. Like there are multiple stuff, like how React is working, but it shouldn't be like, you shouldn't have two instances of React. And it would be easy by comparing, like it happened when I was trying to debug it. If you compare React inside your project that you already bundled, of course, it would not equal to the project that is imported from our node modules, because both of them are different. And that's why we need to also exclude React from being bundled inside our Webpack bundle at the end, which is going to be used inside the SSR server. So let's open it. And again, all of this is not like something mandatory. This is how the way I built it, and it worked, of course. Okay, so let's open each one of them. So resolve, it is going to have tsx files and ts and jsx, so we don't need to add them inside the imports. Like you see here inside our source file, we're importing different files. We don't have to add tsx, for example, at the end. We don't need to add all of this. It's already going to be added automatically. And for our module, we are defining the different rules that we have. So for JSX file, which would be like React elements, we would like to use Babel to transpile them from JSX to JavaScript. And this is basically the core part. This is going to transpile from JSX to create element functions that we have. And we are going to transpile TSX files using the TS loader. And for our Sass files, we are going to use Sass loader to transfer them from Sass to CSS, CS loader to transform them from normal CSS into CommonJS to be able to use and import it. And basically CS loader and mini extract plugin, like mini CSS extract plugin, both of them are used together. So mini extract plugin, it is going to take our CSS components and create a separate CSS file to them. And lastly, Markdown, because we are using a single Markdown file inside our application, we are going to define it as an asset resource. So it is just like imported and then used separately as a file, and then eventually it is going to be emitted as a separate file. So these are the different loaders inside our Webpack configuration. And for the output, it's a little bit longer than you would expect. So it is not a simple file. So yes, we are going to send it as a simple file or emit it as a simple SSR file, but we need to define other stuff. So one thing we would like to define, which is the public path, and this would be our main entry for the different assets that we have. So when JavaScript is going to load our application at first, it needs to know where are the images, CSS, Markdown files, where they are going to be served. Are they on the root, or we are going to serve it from a CDN, or they are on a different directory, and so on. So here we are just saying, okay, it's a public path, it is the main entry or the first point inside the browser. And clean is just to clean our this file when we are building. So every time when we build, we just delete the old and just create a new directory. And for our library, we are just defining what is the library. Of course, like Webpack syncs the whole application that we are bundling. It's called a library. So we just say, okay, please use CommonJS2 modules for importing and exporting, so that when we are importing our application to read it, we can import it as a normal file and execute it, and Node.js would be able to understand it. And this would be the reason. So we can just import it as a normal JavaScript file. And we don't need to do like any magic basically. So Node.js would be able to read it directly. And the global object, this is just defines this. I wouldn't get into the details like what it is doing, but also it is just helping internally inside our application to know what is the global object exist. And we're just saying it is this. Just if it refers to any global part or global object, it is going to use this one. This is for some reasons inside React internally when it is bundled. And for plugins, we are using the mini CSS extract plugin, and we're defining which file we would like to export to. And for our externals, we are going to say, please don't bundle React, just keep React alone and just bundle my application separately. So we can reuse it independent from our React, and we can deploy it away from the server or anything and just deploy it separately on its own file. Okay, enough talking, let's run it. So I hope, of course, like if you have any questions about these configurations, just leave them in the comment section and I would reply to all of them. Okay, and now we would like to build our application. So already there is build, like the normal build, but we would like to have build SSR. So build SSR, and we are going to run our Webpack, and we're going to pass different configuration. So Webpack, and then we define different config, and we say webpack.ssr.config.js as our configs. And let's now build it. So npm run build SSR. And it would say, yes, we forgot to install Webpack CLI because we need it to be able to run these commands. And it is now failing for an error, of course. Probably, yeah, we imported probably in the wrong directory. So let's get back to our entry point and we say the current directory, and we would like to go to source, SSR, and source application. Let's run it again. And it already emits, but it says, of course, there is another error. And I forgot like to do, of course, like few stuff. So let's do them one by one. So the first part, I would need to install Babel Core, Babel Node, and Babel preset React because we are using a couple of them inside our Babel loader. So this is the first one. So it is going to, of course, like install immediately. And we would like to change directory, like our entry point, just we would like to import from source and SSR app. I think it was removed for some reason. And for our dist directory, we would like to emit in our dist SSR. And lastly, for our tsconfig, there is a configuration called no emit. We would like to set it to false. So basically, no emit, it says like don't emit, like as if it's like streaming to something else, and basically would like to stream it actually to Babel. So when we say no emit to true, so it's just going to output to TypeScript, like it's just like going to send the TypeScript to our dist file. So just setting it to false is going to pass it through like piping other configurations that we need. Just a small thing. Okay, and let's npm run build SSR again. And this time, hopefully it would work. Yes, it would work. It worked, and it emitted bunch of files. And basically, this is our application, but it is Node.js ready to be used inside our app. So probably you would be able to see require mentioned here, or actually not require, that is more important, but rather export modules.export. Sorry, module.export. So this is where our application lies in. Of course, like it says like false, so it is not going to execute this part, but this would be the runtime for JSX, and you will be able to see other exports as well. So our application would exist somewhere in this realm. Okay, we wouldn't go into details, but our application lives here, and we would like to import our main.js application into our server-side rendering. And this part is actually super easy. We would just require our app. So we can call const react app, or let's call it todo app. And we are just going to require it. Maybe I would add it above just to make sure that is actually like all required are just above. And we just go to our dist directory and then SSR and then main, and we already imported it. And of course, like there are multiple ways you can do this. You can, for example, read the file using the fs like reader, and then you can execute it as JavaScript and then you extract out of it. I'm just using require here for simplicity. And now we have our to-do app, and instead of having our const app that is rendering that another point thingy, let's just remove it, and we can pass our to-do app directory, and we would like to also pass our current URL so that our static router can read it. Let's also close all of these. Maybe I close others just to make sure it is easier to read. Okay, and we have our SSR app, and basically we would like to pass our path name so our static router would know which route we would like to open. And we can get it from request.url. And now let's check our app and let's refresh. And it would say, yes, I guess we have to access .ssr app, the method that we are exporting from here. And let's refresh, and it is working. Of course, it looks weird because this is the loading part and this is the second loading, because React render to string, it doesn't work, of course, with suspense. So if we go back to our application and just temporarily let's disable our suspense part. So we are now in the application or normal app, and we would import our containers. So TodoContainer, we first going to just use them directly, and then we are going to replace it with suspense. So just to be able to see some stuff, because it looks cool when you import things and it works. So we import here our StatsContainer and our AboutContainer. And I think, yeah. Okay, and we need to build our app again. So let's go to the first terminal, and npm run is build SSR. Is going to build our application again, but this time without the suspense part. And now we see our app is working. And okay, I think this, okay, let's check this part. And mainly it's because when we are doing app.get, we are only defining only one route, which is a slash. We would like to say any route that comes, please send it to our transpilation. And if we check our stats, we see our stats page and about, because it wouldn't work because it needs to have JavaScript. And this comes to the point which we need to explain why we don't see the styles. And when we try to add any to-dos, it doesn't work. It basically like sending a new request back to the server. And the main reason is that when we open our network tab and check what the server responds, it just responds with DOM elements. It didn't send back our CSS. It didn't send back our styles. It didn't send back our JavaScript, because we still need JavaScript to do interactivity unless we are doing a complete server renderer. So we need to basically hydrate our application. And this comes to the point where we need to discuss the concept of hydration. So with server-side rendering, it is fine if you're using PHP and you are using pure server-side rendering. But when you are still using client-side, we need some interactivity, because when we load the application, yes, we need fast response. Like you see, it is like 7 milliseconds. And if you check our normal application, yes, it would be still fast, but it would take some time to load. And I think there is an error for our application here. Okay, I just reloaded and it worked. Probably there was like another bug. Anyway, so you would see like we need to load all these files, and load time is 100 milliseconds to load the application. But with SSR, it is pretty fast. Load time is 60 milliseconds, so like 10 times faster. But we need also to add our CSS to have some design, and also like the JavaScript file. And this would mean we need to hydrate, and hydrate is basically making our application as if it's like a dry land with SSR, and we need to water it. We need to water it with CSS and JavaScript file. So we need to emit these as well, and we need to configure Webpack to emit them. So far, when we configured Webpack, we only configured it to emit what our Node.js server needs. But we need to also emit another bundle, and this bundle would contain our images, our CSS files. Of course, we emitted our CSS file here and also some assets, but these are not needed for our server to run, because our server just need our JavaScript file, because it wouldn't send these at this stage. But we need another file which would contain our hydrations file. And our hydration files are our JavaScript files that is going to add interactivity, and also our CSS files that is going to add designs, and of course our index.html, because we need to load these files inside it. So before we can continue, let's git commit these changes, because we need to be able to see the difference. So git add and git commit allow SSR. This is the first part. And let's add configurations for our hydration. And also I'm going again to copy and paste few files for our configuration and explain them. And I just copied only the differences first to understand what is going to be different. So the first different, of course, we need to have another entry because the entry we created so far, the SSR app, this is using static router, but we need to use the browser router again. We don't want to use the static router. So this would be the first difference. We are going to use a different part. It's going to be called hydrate. This is the first difference. We are going to use the browser router, but there is another difference where we are going to use a different function to mount. So if we go to our index.tsx, we have create root, and create root basically is going to build the actual DOM and then attach listeners of React to each DOM element. So this is going to do two parts. It's going to create the DOM and it's also going to attach listeners to each DOM element. But we already created the DOM in our SSR app using we created like our function, and then Webpack, not Webpack, SSR server is going to React DOM server render to string to change it from like React functions to become normal string to be sent. So we already rendered the DOM. This is the summary for it. We rendered the DOM. We just need to attach listener, and this would be another function React has, and it's going to be called hydrate. And basically we are saying, okay, this is the React file. You don't re-render the DOM again. It is already rendered. It is already inside the HTML. Just attach listeners to it. Just attach listeners to it. And we are just going to define where is the DOM or the root element inside the DOM. And it is going to know, okay, I'm just going to attach listener to each one of them to have the reactivity again for our application. So this is the first different file, which is going to be hydrate.tsx, and we are going to create it. And of course, we are going to have a different output directory where we are going to output our hydrate files. And it would be under like this hydrate, and just also to remove this, we don't need it. So we are also going to define our hydrate. It's going to be under source dash SSR. So this is the first difference entry and also the output. And we are going to create our index.html file that we would like to send back to our browser, basically. And we are going to define our root ID DOM to be part of the tag itself, because we are going to tell React similar to our index.tsx. We are get like by element ID, where we would like to get the root. We are going to do the same when we would like to hydrate. So we need to find an element with ID root to attach our listeners to it. So these are the two differences, and the other differences, like the other similar thing, I just call them common Webpack configs, and they are the same thing. Like modules, we're going to use the same resolver. Of course, the target, we no longer have target. So the target here is different than our node, because this one is going to export for node. This one we don't need to configure because already it knows, okay, this is the browser. And the pivot mode and dev tools and all of this. And of course, also our plugin for main CSS extract, and also our externals, we don't need it now. This is also inside our server only. And also another note is that when we defining inside Webpack config, we could actually export two things. Like so far you could think, okay, I'm just going to create another config and we would have like Webpack SSR and Webpack hydrate. No, actually we don't need to do that. We can tell Webpack, hey, you can export two configurations and do two things in the same config file. So let's first create our common Webpack configs, and we are just going to copy and paste, and it's going to be it's just a simple const. And we just need to find what is going to be common. So of course, again, mode dev tools and resolve as well is common part, and all our modules part. So let's extract it as well. And plugins, actually plugins is only needed for our like the hydrate part. It is not needed at all in the server, so we don't actually need it to emit it in the first place. It is unnecessary. Okay, so let's add it. We don't need add it here. We could add it here. Yeah, it is fine. Let's take this part. And we can actually combine our plugins at the end because all of this is not needed. So we have plugins and we have two plugins, the mini CSS plugin and our HTML Webpack plugin. And this would be the other output. So let's define our two outputs. So the first part we need to, instead of exporting only a normal object, we export an array and we define the first export configuration and the second configurations. Now it would be more happy. And we are here, we are spreading our common Webpack configuration for our hydrate part. And also we need to do it as well for our SSR part. And by the way, this is not actually needed for the server, but because it's going to complain, we need to also add our plugins SSR, not plugins SSR, but plugin CSS as well. We need to define it, like the CSS plugin. So I'm just going to copy all of this and then remove our HTML at the end. So again, it is not necessary, but we need it because we are just using common Webpack configuration, and this Webpack common configuration already has the mini CSS. But again, we don't need this mini CSS to be exported here. Like we don't need the file for our SSR. We just need the JavaScript file. This is the only file that is needed. The other part is not needed. Okay, we need now to create our hydrate file. So new file, and we call hydrate.tsx. Hydrate.tsx. And we just create our hydrate file. Sorry, hydrate content. So we call it hydrate root. This is the name of the functions that we are going to execute. And it's similar to our create root. So this is called hydrate root. So we just hydrate it. And we would like to get our root as HTML element. So this would be our root element that we'd like to attach to. And then what we would like to appear or to hydrate with, we would like it to be hydrated with our browser router. And inside it would be our app. And yeah, I did a silly mistake. Should be closing tag should be here. Yeah, all of this years and I still missed this part. Anyway, and yeah, this would be fine. We don't need to export it because it is going to bundle it correctly. And of course, I am sure it wouldn't work from the first time. I just also changed the file name because it was capitalized here. It wouldn't work, so let's see what would not work. So npm run build SSR and see what mistakes we did. And it's going now to generate our file. Okay, it didn't. We didn't have any mistakes. Okay, was a little bit pessimistic, but this is cool. And now we have our JavaScript file and inside it our HTML file. And also let's check. It didn't emit the root ID for some reason, but it is fine eventually. Let's check it actually inside our Webpack configuration. And we can see like all our files that we need to export at the end. Also, like there was a small error. This is not correct. Actually, this is not a correct configuration for our HTML Webpack configs. And eventually, let's get back to our hydrate files. We have our index.html, and inside our SSR server, we would like to replace the body with our div id root so that we can eventually inject our all other files. Of course, our CSS would work because we already have links to the CSS. So we also need to tell Express where it could find our assets file, like the CSS, JavaScript, to be injected. So let's do step by step. Let's close again all of this. And let's go to our server.js. And first part, we already rendered our app HTML. Let's call it app HTML. And we now need to read our index.html so that we can return it not only our app HTML but rather our index.html, and then we inject our app HTML inside it. So it's as simple as reading the file. So we can read our file index content, and we are going to use fs, and let's import both fs and pass. So const fs is equal to require fs, and also we can import path. So we have the power of autocomplete not to remember each part, and we can use path.resolve to resolve our file location. So we go to dir, and we go up, we go to our dist SSR, not SSR, it's hydrate. This is where our index.html exists. So index.html, and now we have our content. Also, we need to define the Unicode for the file. So it's UTF-8. I think this is correct. And let's maybe return our index and see if it works. And it doesn't. And this is correct. And let's maybe check the errors. Yeah, I wish everything works for the first time. And okay, okay, I get it. We added the UTF-8 in the wrong function. Should be in our read file. Okay, let's save it and let's try again. And what else is not working? So we have our index. I think we need to also define the content for what we sending. Okay, and I think I found the problem. So basically I shouldn't have added this. Maybe it was added when I was re-recording. Basically app.use express static. This function is a middleware inside Express and tells it where to find the static files, which are these files. And basically it is going to SSR. This is not correct. It should go to hydrate to be able to get the correct file. This is a middleware inside Express applications. And we need to say to it, hey, don't import index or use any index file because we already are going to inject it. And we are injecting our index content now. And let's check it. And if we refresh, our app is working now better. And it is importing our CSS file. Of course, we need to add now the content for our app. And it's as simple as replacing our body tag with another thing because its index content is eventually a string. So we can say index.replace, and we can say we would like to replace our body tag with another body tag. And inside this body tag, we are going to have our div with ID root, and we can close our tag. All of this is just a string, just to let you know that server-side rendering is as simple as just some strings being returned. And we would like to inject it, so let's change it to string literal. And we can now inject our app. Let's close this one. Let's try it now. And yeah, right. We need to return it. So let's const app is equal to this part. This is fine. Let's refresh. And now we see our application. It is back. But of course, we need to hydrate our app. So we would have our content and we have our useEffect that is going to call the Todo service to get our to-dos. So we need also to see why our JavaScript files are not being loaded. And I think it's mainly because we forgot to enable JavaScript. So this is working actually without JavaScript. Like you see, like there's some rendering and it's under 18 milliseconds without using JavaScript. So we just need to enable JavaScript. Yeah, it's a simple thing. Okay, so we now enable JavaScript and we refresh, and now our application is working as server-side rendering. and everything is working nicely. It can smoothly transition between files. It doesn't need to do the hard refresh that we had. And if we refresh, it is now doing few things. First, calling the server. It is injecting HTML content, so our app is getting very fast load at first, and then it is hydrating it with some JavaScript and CSS to give it some soul or spirit, or like to give it some life, basically. So this is nice. So this is server side rendering. So again, in summary, what we did, we have a Webpack configuration doing SSR, and what it's doing, it's just emitting two files or two configurations. The first part is going to emit our node imports that node is going to import, basically create element inside React, and it's going to create the DOM and create our DOM elements and everything, and send it back to our index to be returned back to the browser. There is the other second part, which is hydration. It is going to make our application have some life inside it with some JavaScript and some CSS, and it's also going to return it back to the browser. And we have a NodeJS server that is going to do all of this magic. And we have hydrate.tsx to create our elements, events, listeners to be attached to the DOM, and basically it's going to target our root. And for our SSR app, which is going to use static router to be also returned to the browser to render the correct routes. And lastly, we need also to allow suspense again to make sure our suspense are working. So this would be the last part. And we can replace all of these. So thing to do, and also our container. And let's take both of these and we replace them as well. And we can do npm build again. So npm build SSR, and this would be different. I hope it doesn't break. And of course, it would return normal empty HTML because we are doing async imports, and we also don't need all of these. And it's doing a sync import. So it's basically importing our JavaScript asynchronously. So when the SSR first render, it doesn't see anything. So it doesn't render them or import them. You can, of course, configure Suspense to actually import the JavaScript file to have also this speed, even if Suspense is not working. And as you can see, it first import our index, and the loading and every effect is working normally, but we are getting it as fast as 10 milliseconds. Like you see, it is super fast to have. And this is SSR. So this is the whole course about advanced React. I hope you found it useful and it would improve your career and also your knowledge about React. If you have any questions, just leave them in the comments. I am always happy to answer them to make this course better. If you have even any notes, any ideas to improve it, just leave them in the comment section. And I hope to see you there as well. And remember to like, subscribe, all of this to improve the algorithm. Share it if you find it useful also. And yeah, see you in the next Just Enough series course. Ciao.